Hello everyone, thank you for joining us today to learn all about Azure fundamentals. Today we're going to cover all 4 modules in this course. These will include Cloud Concepts, Azure Core Services, Security, Privacy, Compliance, Trust, and we'll finish out the day with Pricing and Support. Joining me today is Matt Hester. Matt, take it away.
So welcome to this course, AZ900, Azure Fundamentals. We have 4 fantastic modules we're going to cover in this course. We're going to talk about Cloud Concepts, more on that in just a moment because we're going to get right into that course as quick as we can. We're also going to talk about Azure Core Services. I like to think this is an inch deep but a mile wide. You're going to look about all the fantastic solutions from virtual machines to Internet of Things to machine learning and kind of everything in between. Then we have Module 3 where we're going to focus on security and privacy, compliance and trust. Oh, it sounds like a big topic, and it is. Matter of fact, we have a separate course, AZ500, and that's all it talks about is that module. So we're going to be the tip of the iceberg on the security stuff. And then Module 4, we're going to talk about pricing and support that align with our environments. How do you buy Azure? How do you get support if you get into a problem? That's our course and what it's designed to help us learn more. And so, cool thing about this, some of you are going to take the exam. And when you look at the exam, guess what? We have 4 study areas for the exam that align to those same 4 modules. Now you'll notice on the right-hand column they have the weights. What's that mean? Well, our exams kind of come out of a random pool of about a few hundred questions. You're going to get anywhere between 40 to 50 of those questions based on those different weighted areas for you to study and work with. When you look at the right-hand column, that's more than 100%, but that's okay because everybody's exam is going to be different. You're going to get different questions. The nice thing about this is that when you look at this exam, you pass it once and you're done. And you don't have to worry about taking it again because it's the fundamental level. Now, the other exams you may take on your certification journey, you might have to take the exam after a couple of years because Azure changes so much. Now, if you're looking to study, if you're looking to learn more about Azure fundamentals, look at http://aka.ms/azfunpath. This is an online version of the same course we're going through. They have some hands-on exercises. It gives you some additional materials to read and study and prepare for the exam. In fact, when I took the exam, that's the same area that I went on to learn more about the areas that I was a little weak on. So every exam has a challenge, and every exam you want to be prepared for as you go into it.
Hey Matt, what is actually a passing score for the exam?
So the passing score, great question, we get this all the time, it's 700. So if you get a 700 or higher, you've passed. Now, folks, let me be honest with you. You're going to have friends, and some of you may be those friends, and you might be that friend that say, well, I got an 800 and you only got a 700. Don't let anybody do that to you. When they say that to you, and so if Garrett were to tell me, says, Matt, I got an 800, you only got a 750, I'd be like, well, Garrett, I'm glad you got the easy exam because I got the harder to the exam. So the score is there. Now, with that said, if somebody comes up to you and say they got 1,000, that is worth a crisp high five, maybe a hug. That means they got a perfect exam. They didn't miss a single question. And I don't care what exam that you take, 1,000 is 1,000. That's impressive no matter what anybody will tell you. So understand, passing 700. If you get a 700, you pass. And it's no different than somebody gets a 900. They pass too. It's just like a hit in baseball. A hit is a hit is a hit. A pass is a pass is a pass. So when you look at this exam, folks, you really just want to get over that hump to pass it. The exams are tough. You have to study and work with it, and that's why we have this course for you. That's why we have the online version of this course for you, because we want you to be successful with that. Our promises over this course is really we're going to have some fun. Heck, it's in the title. I think it's even Garrett's title, as a matter of fact. We're going to have fun. It's Azure Fundamentals. Learn at least one thing. Certifications are important, yes, especially if you want industry-wide recognition. But really my goal was to get you skilled up in Azure. I want you to use Azure in your company. I wanted to use possibly in your life. We have free services, and we'll talk about that in Module 4, that you can leverage that if you're part of the community and maybe you just need a little bit of compute power to support a nonprofit or an organization. Guess what? Azure may have something free for you to solve that problem. And lastly, we're going to make ourselves available to you throughout this course. We're going to have some questions and answers as we go through. You're going to let us know. Engage and enjoy. This course is for you. Now, who am I? My name is Matt Hester. I've been with Microsoft for 19 years. There's my email address if you need to ask me questions about the course of what we're going to go through and study. But I live in Frisco, Texas, and if you don't know where that is, it's a northern suburb of Dallas. I live 3 miles away from the Dallas Cowboys practice facility, the NFL football team in America. But the cool thing about this, I am not a Cowboys fan. I am a Cleveland Browns fan and an Ohio State Buckeye fan. So if you are a Buckeye fan, OH.
I.O.
There you go. So Garrett, you at least know the proper response. inside of it. But I also have lots of certifications. I've been taking certifications pretty much my entire career before and after Microsoft. The cool thing about this, I'm in my dream job, but the reasons I get up in the morning are my family. My reasons why I do this job, and I love this job so much, is I get to support my family. I have a wonderful daughter, Nicole. She's a flute player at Stephen F. Austin in Nacogdoches, Texas. The cool thing about Nicole, she's a math major. She wants to be a math teacher. My son Mitchell, he currently stands at 6'7", and he's a volleyball player and a trombone player. It's kind of a natural instrument, a really long instrument with a really tall person, works perfectly. And then Caitlin, my heart and soul, and everybody will tell you that Caitlin is got me wrapped around a little finger. That is a true statement. She's a French horn player, and I love her to death, but she loves bacon. Trust me, this is important for something we'll talk about later. And then I have two fur babies, Pepper and Sugar. We're doing the annual spring thing in Texas where we're taking pictures in the state flower of Texas, which is the Texas bluebonnets. And so you have an idea of what we do in Texas every spring. You can see all the forced fun smiles that we have. But the cool thing about it, I have Garrett with me throughout this course. So Garrett, why don't you talk a little about who you are?
Sure, yeah, thanks, Matt. So I'm Garrett Bundy, as Matt mentioned, and I am a director on our fundamentals team. I look after a team of trainers that are based anywhere from in the United States all the way through the rest of the world, in China, Japan, all over the place. I'm based in Los Angeles, California. I also have been taking a lot of certification exams throughout my career. Been at Microsoft for 14 years, so not quite 19 years like Matt, but I've been here for 14 years. Most of the same certifications that Matt has, and I enjoy the technical part of this. And as far as my reasons why, very similar to Matt, it's my family. So my wife, my older children, my oldest son, James, who's in college in his second year, Skyla, who started college this year. She goes to UC Santa Cruz, so go Banana Slugs. And then my other daughter, Kaylee, who's in high school, my son, Caden, who is in first grade, and my daughter, Devin, who's a kindergartner. And really, my family is why I get up in the morning and why I do everything I do. So very similar to Matt, but that's why I do what I do.
Awesome, and I love your title, Fundamentals. It's perfect. It fits what we're going to cover today. And let's go ahead and get started with Azure, Module 1, Azure Fundamentals, Cloud Concepts. And in this module, we're going to talk the basics of cloud computing, from private computing to public computing to hybrid cloud computing that we have. The cool thing about this, whether it was Azure, Amazon, or Google, these terms are industry standard. We're also going to focus on kind of the key terms of infrastructure as a service, IaaS, platform as a service, or PaaS, or software as a service, SaaS. These are, once again, terms that we use broadly across the industry. So the great thing I love about this module, it sets the stage. Now, if you're listening to this and watching this and going, wait a second, I got all that stuff. The one thing I want to stress to you, especially when you take the exam, is you have to think like a Microsoft person. So yes, we use industry standard terminology that's for all of these services, but when you take the exams, you kind of have to, if you work for a company that's been using Azure for several years, you might have to ratchet yourself back just a little bit to understand what we're asking, because we have to ask a question at a general level, not specific to your company. I love the fact that if you're using Azure, thank you so much. But the exam is going to test that general Azure knowledge, that general cloud foundational knowledge as we go into it. So let's talk about some of the key terminology of why we use cloud services, as well as some of the foundational things. So why do we use cloud? It's all about the compute power. When you think about Amazon and Google and Microsoft, how big our data centers are, well, how can you leverage that power? Well, the most common way is using compute. And compute doesn't always mean virtual machines. Understand, everything you do in a cloud service is run by some piece of hardware and computer underneath the covers. The cool thing about this, we have a huge amount of resources for you to leverage, so we can do things that you may not have been able to do, like analytics, being able to just do truckloads of data, petabytes and terabytes of data, and we want to find out that seasonality. We now are on a network, and a fun fact about Azure, last time I checked, we have enough fiber to go to the Earth and the Moon 3 times. You're on a private network, and Microsoft has gotten really good at this. A lot of people think we're new to the cloud business. We've been in the cloud business since 1995. Our first cloud service was Windows Update. So we've been doing this for a long time. We've gotten really good with our networking. We also now have storage. Now, when you think about storage in our environment, we'll talk more about this in Module 2. The cool thing about storage is that we have really just a wide, vast array of storage for you to leverage for files, databases, anything else that you want to store inside the environment. So why do we use cloud computing? It provides us ability to leverage resources that we otherwise couldn't do on-prem. And hopefully at a point that's less expensive than what we do on-prem. We're going to talk more about that in this module and in Module 4, because it's not necessarily just about how much a machine costs, but the whole total cost of ownership. So when we talk about why we use cloud computing to do things that we couldn't do normally, but also do them at a price that's less than what we could do on-prem. And so when we start working with Azure and we start working with our cloud terminology, we have some very key concepts and availability that we have to understand, that how we think about Azure. And the first one is high availability. What is high availability? Really, it's the ability to make sure that our services are up and running as much as we can. Now, when we think about high availability, it's making sure that it's service. When somebody comes to my website, it's there for me. When somebody comes to my database, it's there for me. It's available. Now, when I think about availability, Garrett, what do you think? Do you think that's a Microsoft responsibility? Is that our customer's responsibility? Or do you think it's both of our responsibilities?
I think it's probably a shared responsibility.
Definitely. And you used a great term there. You used shared responsibility. And when we look at availability, we're going to provide a platform that has guaranteed service level agreements. And we'll talk more about those in Module 4. But we also have to give you an ability to design solutions so they are available. And we'll talk about in Module 2 two very important concepts. And they're critical. By the way, exam tip. You'll see these two concepts, availability zones and availability sets. You'll see them on every exam you take from AZ900, AZ103, the architect exams, AZ300, 301, and we'll change those names as we grow them, but trust me, you're going to see them in the wide variety of those things. We also have two terms, scalability and elasticity. Now, scalability, we've been doing on-prem for years. You've been able to scale up. What's that mean? When you scale up a resource, you add more memory, you add more CPU, maybe a bigger hard drive. You're trying to solve a problem on a server. Think, for example, or imagine a query that's running in our database where we just need that query to run a little faster. Well, we can't solve it with another server, but we can solve it with more horsepower, another CPU maybe. That's called scaling up inside the world. Now, if you were to take the hardware away, which we very rarely did on-prem, that's called scaling down. Whereas, what if your website is announced on a popular TV show and all of a sudden you need 10 more web servers to handle that problem? It's called scaling out. And we have scalability that we can use. And by the way, if you remove those servers, it's called scaling in. Generally speaking, we've been scalable in our cloud technologies for forever, but also we've been doing this on-prem. But now we have this term elasticity. What's elasticity, Garrett? What do you think?
I don't know. Yeah, I was actually looking at them. Those terms seem so similar to me. How do you really differentiate and distinguish between scalability and elasticity?
Yeah, and a lot of people, when they see the term elastic, well, Azure's not scalable. Nothing is more further from the truth. We are scalable, but in cloud technologies, we use the term called elastic. When you think about scalability on-prem, if you add more servers or you add hardware server, you very rarely will take those things in. So you scale up or you scale out, but you never do the inverses. Well, in cloud, we have a thing called elasticity. So we can scale up and we can scale down and we can scale out and we can scale in. And especially when it comes to scaling out and in, we can do this dynamically and automatically. So when you think about elasticity, how I've put it in my brain is it's dynamic scalability. This is a huge benefit of cloud technologies, and a lot of your organizations are looking at this. I'm willing to bet everybody that's listening to this and watching this right now, you have seasonality in your business. At some point in time, you need more resources. You know, here in the U.S., April 15th, the tax companies, they need more power. Well, we know that. Well, they had designed solutions that were scalable for that one day. What happened after that day? The cool thing about cloud technologies, and it's hard to capture cost for this, hey, I spike up for the time, and I come back down because we're a consumption-based service. Why use it for the entire year when I only need it for a week inside of it? So we're elastic. We have agility. It means we can do things very fast. For anybody who's ever done anything in the cloud, we're talking minutes. In Module 2, we'll create a virtual machine in minutes. From something that doesn't exist to something fully running in just minutes. Think about how long it takes to work with those environments. Take along how long it takes to put them on-prem. Well, guess what? Makes it very agile in the cloud when we can just start working right away. Then we have fault tolerance. Fault tolerance is an interesting concept. Is what happens when hardware fails. Everybody has maybe woken up in the morning and you hear that tap, 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 tap of the old magnetic drives when a drive head broke inside of it. You have fault tolerance. Well, whose hardware are you running on here? You're running on your cloud provider's hardware. You're running on Microsoft's hardware. And so when we talk about fault tolerance, so Garrett, I'll ask you the same question again. Is this a Microsoft responsibility, a customer responsibility, or is it both of our responsibility?
I think fault tolerance falls more on us as Microsoft.
Most definitely falls on us from a standpoint when we talk about the physical hardware and the framework. It is definitely our responsibility to make sure that we provide hardware. Because at the end of the day, let me on a secret, guess what? Azure, giant data centers. In Module 2, we'll talk about how big these data centers are, but it's physical hardware. So we have to provide fault tolerance for you. Now, when we start thinking about bigger concepts about business continuity and how do I make sure my web server that's running on-prem, if it has a fault, how can I fail over? Whole different concept of where cloud can help you provide that. But in the context of right now in our fundamentals, fault tolerance is how we handle those errors on our side. We want to have fault tolerant solutions. You don't have to worry about that. And this is one of those, once again, Garrett used that term, shared responsibility. You're on our hardware, which means we have to be responsible for you as you're our customers. We have to make sure it's up and running. Some other key terms. We have disaster recovery. This is another one of those ones when we think about, well, we can use Azure as a disaster recovery platform. And you think about just something as simple as backup. Azure's a great backup target. You have your on-prem resources, you back them up to cloud technologies. Now, if that on-prem resource goes away, it's up in the cloud. And everybody thinks, hey, that's great, it's a great backup target. The cool thing about Azure from a disaster recovery standpoint, it's also a recovery environment. If I don't have that server on-prem to restore the data to, you can create a virtual machine. We'll learn more about those in Module 2. But also disaster recovery takes on a whole nother level when you start using shared responsibility in the cloud provider. What happens if our data centers go down? How do we work with Azure to make sure that, hey, it doesn't impact your application? And we're going to talk about our concept of geographies and region pairs all in Module 2 to talk about how we do disaster recovery. Then we have global reach and customer latency capabilities. These two are tied at the hip. When you think about an environment where we have 56 regions around the world, where are you going to put your stuff? Where are you going to put your regions? Generally speaking, you're going to put it in the regions that are close to you. Wherever you happen to be in the globe, wherever that solution is going to be used, you're going to put that information close to it in a way that we don't have to travel across the globe. Now, here's the cool thing about Azure. If you did have to travel across from one region to another, you're on our network, a really high-speed network. And one of our case studies is NBC Sports, and you can look this up online. They actually use the Olympics, uses Azure to help distribute the media files. So if you're watching the Olympics anywhere online, chances are you're coming out of an Azure data center. And NBC Sports is using that global reach and customer latency to make sure that people can watch whatever Olympic event they want to watch, either stream it live or watch a recorded event. The other one sometimes causes people a lot of trouble with the one, predictive cost considerations. And I hear this all the time. I will not use the cloud because I don't know how much it's going to cost. True, we're going to give you an estimate, but it's a very predictive estimate of how much it's going to cost you. It's a consumption-based service. So like here, when I'm at home in Texas during the summer, we turn on the air conditioning. Well, how much is my electric bill going to be? Well, I know in the summer it's going to be higher. And based on the seasonality, I have a general idea of how much that's going to be. It's still predictive. I can still budget for it. Is it the exact number? No, it never will be. And in Module 4, we'll talk about how to leverage the calculator so you can be predictive about this. And the last one, oh boy, Garrett, this one always causes problems, security. So when you think about security, what are some of the things that you think about when you think about cloud and security?
Well, wanting to protect my environment from malicious actors out there. I'm putting my data in the cloud now, so I need to be more conscientious about how I'm putting that data, where I'm putting it, and who I'm trusting with my data.
Yeah, and I think about it, whenever I hear people about security, the one thing they worry, they lose control, right? They're no longer they don't see the hardware anymore. They don't see the blinky lights. They don't see the servers. They don't have, and I always joke with customers when we do these classes live in front of folks, we go, hey, look, do you have a friendly receptionist or an unfriendly receptionist? Now, folks, you want to err on a courteous but unfriendly receptionist. Why? Because if I were to go to any of your companies and say, hey, my name is Matt, I work for Microsoft, can you show me where the lunchroom is? Well, they walk me back and maybe buy me a cup of coffee along the way. Yeah, good, I love it, by the way, but that could be impersonator, how they know who I'm at. So we have to look at security. Once again, this is another one of those shared responsibilities. I often say, when you move things from on-prem to the cloud, it's going to be as secure as it was on-prem when you move it to the cloud. However, the cloud has some built-in capabilities. We'll talk about these in Module 3, and one of them, let's say you have a website. One attack that your hackers may come after you is called a distributed denial of service, or a DDoS attack. And what that is really an attacker of your organization not really trying to compromise, but what they're trying to flood is your website with so much traffic, legitimate traffic can't come in. Well, when you put things inside of Azure, automatically you have DDoS protection. It's turned on for every customer and it's free, the basic SKU. There's another SKU that we'll talk about in Module 3 that costs a little bit of money. But when I think about security, it's a really big term. In Module 3, we're going to talk about some of those key security concepts, and really security in the cloud is understanding how we talk to the cloud and make it more secure. How can we do things that we didn't do on-prem, but now we have a chance to fix when we move things in the cloud? So when we think about security, it's really that shared responsibility. You have to think about it from your side, and we have to provide you an environment from our side that governs that. And we'll talk all about that in Module 3. Let's give you kind of the tip of the iceberg. When we think about some other key terms, we have economies of scale. What does that mean? It means basically we have so much hardware, we can offer this to you at a cost that's less than what you have, and we pass those benefits on. The more efficient we get in our cloud, guess what? The less expensive those resources are going to be for you. In Module 4, I'm going to show you this. We have costs for virtual machines, and if I run them in West, it has a certain price point. If I run it in West 2, which is one of our newer data centers, the price drops. That's the cool thing about cloud when you think about what's happening in the cloud technology. And this is different than what we've ever done before in technology. You know, think about when you bought a version of software. You know, version 1 had a price point. Version 2 was a little more expensive. Version 3 was more expensive. Version 4 is expensive. But what's happening in the cloud? You have some very strong companies in the cloud, and guess what? Competition is driving a price point that is going down. Now, of course, Garrett and I are biased because we are Microsoft, so we're all about Azure. We'll talk about that journey in just a moment, but we get economies of scale because we have these large data centers and we can pass those costs along to you. We also have another benefit of cloud, and this is capital expenditure versus operational expenditure, CapEx or OpEx. Capital expenditure is what we've done for years on-prem. You had a large upfront cost. You had to build a data center. Now, think about this. You might think, oh yeah, I had to go buy the racks of computers, I had to buy the cabling, I had to do all that. You had to have a building. You had to have some place to actually put all that stuff in, then run power to it, then run your internet access to it. What I'm starting to get to think of is all the upfront costs that go into this and all the total cost of ownership. We had high upfront costs and they devalued over time. One of the accounting principles, when you acquire an asset, the minute you acquire it, it starts to go on the books and devalues. This is different because that capital expenditure is all about on-prem. Cloud is operational expenditure. You get a monthly bill. There's no upfront costs. Now, you might have costs to train and use your people, but there's no upfront cost to use the technology. It's pay as you go. As you work with this, you basically deduct the expense from your tax bill in the same year. You get billed immediately. And when I say immediately, you start using Azure on, let's say at the beginning of a month, you're going to get the bill at the beginning of next month for the previous month. So you do get billed immediately, but the bill shows up the next day or the next month or the next period of time. The cool thing about this is that's how all cloud services are, operational expenditure. And we look at the different models, especially when you compare IaaS and PaaS versus SaaS, how that operational expenditure model changes. And we'll talk about that in just a few minutes. When we think about consumption-based model, this operational expenditure, no upfront costs, you don't have to purchase or manage any infrastructure. And this is when we looked at IT pros, and I know, Garrett, you talked to IT pros as well. When cloud first started, the sky was falling, right? Because they thought they were going to lose their jobs, right? Did you have those conversations as well?
Yeah, I had those conversations on a very regular basis. Everybody thought, I don't want to get into the cloud. This is not where we're going, because they felt like they had to protect their domain on premises.
Yeah, and what they didn't understand is, unless they like to rack and stack hardware and run cable, which if you've ever talked to anybody who's ever done a data center in the history of ever, nobody likes to rack and stack hardware. Nobody likes to run cable. And something, by the way, and just kind of picking up people that are born in the cloud, there's a lot of companies that don't have the joy of doing that stuff. I think, by the way, Matt's personal opinion here, before any company can use the cloud, they have to go make an RJ45 cable and crimp it properly before they have to do this, something that, with the pain of this. But when we talk to IT pros about this, guess what? Oh wait, I don't have to make an RJ45 cable? No, you don't. You don't have to worry about the hardware. That's our responsibility. But what about the server up there? Do I have to back it up? Yep. Do I have to maintain it? Yep. Do I have to configure it? Yep. And the list goes on. You still have to architect these things. Even though we have the physical infrastructure done for you, you still have to architect virtual networks. You still have to architect the storage. You still have to worry about making sure the security is there. So when you think about this consumption-based model, it takes away a lot of things we used to do, but there's still plenty of work inside the world that we have today. The more you use, the more you pay for. And when you're done using it, and think about scale out for a moment. We just got mentioned on our website just got mentioned on a popular podcast or TV show, and all of a sudden we need 500 more servers to govern the traffic. Well, I just spin them up. 500 servers. Solves my problem. The minute I don't need it anymore, I simply start taking them away and I no longer have to pay for them. It's a huge benefit. That elasticity is huge around consumption-based model. It's hard to put in a price point, but think about how you would have done that on-prem. You would have spun up all those servers. Now you're kind of stuck with all those servers. So when you have a consumption-based model, we help you lower the cost for those same solutions, and in some cases, do things you couldn't do before. Let's talk about the types of cloud models we have. And we have three, and most of you have heard these terms. We have public cloud, private cloud, and hybrid cloud. Let's start with public cloud. What is it? You're going to Microsoft, you're going to Amazon, you're going to Google, you're going to somebody that provides the cloud services. You don't own them. You basically use those resources, you leverage those resources for whatever you want to do. All the cloud resources you go into are going to be accessed over some kind of secure connection, and we'll talk about these in Module 2 as specific to Azure. In Azure, we have a couple of ways that you can come in and work with it. We have ways you go over the public internet. You can even get, via a technology called ExpressRoute, a private dedicated link into Azure. And we'll talk about that in Module 2, but you're going somewhere. You're in that shared responsibility model. Almost every organization that's born in the cloud, that's all they know. All they know is public cloud. But a lot of your organizations that, as we go through and look at our customers today, you started off with private cloud. What's private cloud? Think on-prem. It's your data center, which means you had full control, full security. It was yours. You also had the full responsibility for managing that private cloud. In other words, you had to worry about everything. You had to worry about the rack and stack, the cabling, the physical infrastructure. If something failed, you had to replace it. If somebody supported it, you had to solve the problem. You had to have all those resources, and that's okay. Guess what? Everybody started with private cloud. Most of our organizations started with private cloud. Now, when you think about this, how do I connect the two? It's called hybrid cloud, and all hybrid cloud is connecting the public cloud with your private cloud to allow applications to run in whatever is the best location, whatever the most appropriate. We still have customers that are in this model. Why? Compliancy. They might have to run a certain part of that application on-prem for something internal or governmental compliancy, or maybe a compliancy we don't meet in the cloud, and that's okay. But what can we move into the cloud? Let me let you in all a secret. For those of you who think, hey, we've never used Azure, we're looking to jump into that, if you're currently using Office 365 today, you log on with an ID via Azure Active Directory. And most likely, the IT department of your organization took your on-prem Active Directory environment and connected it to Azure Active Directory. In other words, if you're in Office 365, my friends, guess what? You might already be in hybrid cloud for your identity. The key thing there is, one, you're already there. Two, I mentioned a very specific workload. And so when people think about hybrid cloud, they think, oh, I have to do everything. No, no. Pick the workloads that make the most sense and run them in the appropriate location. Well, I have to run this on-prem, but I can do this other part up in the cloud. Find what works out for you and get hybrid cloud. Hybrid cloud gives you the most flexible model that we have, the most flexible design, because now it's kind of do what you want to do. Microsoft came out with a marketing term several years ago, and I loved it. Cloud on your own terms. Now, make no doubt about it, we are a cloud-first company. We believe in Azure. We believe in Office 365. We believe in all our cloud services that are out there. But we want our customers to choose what's important to them. So cloud on your terms at a Microsoft, even at a Microsoft employee level, means a lot. Because one of the few cloud providers allows you to pick and choose. And if something doesn't run right in the cloud, you can bring it back down to on-prem to work with it inside of there. When we look at those different cloud module comparisons, just a quick refresh. Public cloud, it's no capital expenditure, it's operational expenditure. We have applications, we have the agility of the cloud. Organizations pay only what you use, consumption-based. Private cloud, you have full control over your security, over your resources, everything, but you also have full responsibility over that. Hybrid cloud gives you the best of both worlds. You get flexibility, you determine what makes the most sense to run your applications, and that's hybrid cloud. Now let's talk about the types of cloud services that run in those different models, and really now we're going to focus in on the key terms. IaaS, PaaS, and SaaS. And really it's a level of responsibility. So when you look at infrastructure as a service, if you look at where it's governing on this slide, the physical data center, that's us. The physical networking, firewall, and security, that's us. The physical servers and storage that run your environment, that's us. Now what are you responsible for? operating systems, the applications that run on top of them, or the configuration and development of those applications. That's infrastructure as a service. Now, if you look at platform as a service, guess what you don't have to worry about? You don't have to worry about the operating system. There's definitely a compute resource behind those PaaS services, but you don't have to worry about it. Then you have SaaS services, where generally speaking, you just have to configure that client to work with it. So if you use any streaming media today, if you subscribe to any of those, watch movies on planes or download that stuff, guess what? Most likely using software as a service. The great thing about software as a service, it's a very predictive cost model. Generally speaking, it's a $10 per user per month kind of thing, depending on what service you're using inside of there. Now, I like this slide because it kind of lays out the story, but really most of you have probably seen a slide like this of how we describe the shared responsibility model. So Garrett brought that up. It's a huge term, right? If you're on-prem, what are you responsible for? Everything that's in green. Well, that's everything on the list that we have for us to use. Infrastructure as a service, what are you responsible for? For that virtual machine, that operating system. So do I have to patch it? Yep. Do I have to back it up? All those things. IaaS is what we're responsible for. If you look at PaaS, all you have to worry about is developing your application. Developers still develop, and they still have to have right access to it. Versus software as a service, guess what? They just have to worry about data and access. Now, generally speaking, at a real high level, when you move from infrastructure service to platform as a service, from IaaS to PaaS, you're going to save money in your cost consumption model. Why? You're consuming less resources. You're just leveraging the application. You don't have to worry about the operating system or the virtual machine. You don't have to worry about maintaining that from a cost perspective. We see a lot of customers now that are in that kind of crux. Do I just take my VM from on-prem and do what is called a lift and shift and move it into a VM in IaaS? If you do that today, I'm willing to bet tomorrow you're going to say, you know what? I don't want to run that VM anymore. I don't want to pay for that virtual machine anymore. I want to just re-architect or refactor or redesign my application into a platform as a service so I can get out of that business. I don't have to worry about that anymore. And you're going to save money with most Azure services by doing that. A lot of our customers today are looking at, hey, I want to migrate to Azure. Moving that VM, lift and shift, is generally not their first option. It's the option of last resort. In other words, you know what? I can't get the application to work the way I need to just yet. I'll move the VM up because I need to leverage cloud resources for it and whatever else I want to do. And they're going to leverage infrastructure, but we see them on a journey. And now it gets interesting when we start talking about platforms as a service. This means your organization has the skill and the developers to be able to write and work with those applications. But guess what? We have software as a service inside of Azure as well via what is called the marketplace. So the question becomes is, do I build my solution or do I buy the solution? Something in SaaS to leverage inside the cloud services we have. So when we look at this, folks, it's really designed to solve the problem and how you want to solve it, what's going to be the best, and what is it going to cost you to do all of that. Now, a couple things I love about this slide. First off, from a Microsoft perspective, all those services can talk to each other, from on-prem to IaaS, PaaS, and SaaS. These services can all leverage each other. More to the point, Microsoft is the only cloud company today that does all four of these. Our DNA was built on Windows servers. We leverage IaaS, PaaS, and SaaS. So when we think about this, we're the only company that understands all four modules, or all four modes of this. The cool thing also about our company, everybody goes, well, when we look at one of our biggest competitors, Amazon, they jumped out to a huge market lead. And in recent years, we've caught up, and it's going to be a seesaw battle for the next, probably as long as our lifetime is, that's going to be there. But where did Microsoft start? We started as platform as a service. Why? We're a software development company. Why do you think we developed the Azure PaaS services? For our developers in the company to get more efficient, more agile, get global reach, customer latency, get elasticity, all built into the services. It's in our DNA as a development company. Where we see the organizations going in the world today, and this is Gartner and Forrester and any research organization, people are leaning towards PaaS. And they're leaning at leveraging either Azure or Amazon to do that. But that's when you look at those general modules, it's in our DNA, folks. Our PaaS story is incredibly strong because, and not to belittle any of our competitors at all, but it's incredibly strong because it's in the DNA of our company. We were born to be developers. Everybody's like, what's Microsoft do? We're a software development company. And so we have a great platform, and we understand because we built things for on-prem before we built Azure. Even though we had cloud in 95 with the Windows update, we have the ability to work with this. And so when I look at comparison, just as a summary of all of this, IaaS, infrastructure service, it's a flexible cloud service because really it is, hey, I want to move that machine from on-prem into my cloud environment, and all you have to do is configure the hardware. From an IT pro standpoint, this is where a lot of people start with cloud. Hey, That application's familiar. I know that operating system, whether it's Linux or Windows. And, oh yeah, I did say Linux. We'll talk about that in Module 2. We also have platforms as a service where we just focus on developers. Developers like to develop. Now the cool thing about this, when we think about PaaS services, I'm starting to get these questions again, Garrett. They're starting to go, wait a second, PaaS is going to take my job. What's going to happen when those folks come into PaaS? Well, guess what? You still have to have governance. You still have to have security. You still have to architect networking. You still have to architect storage. You may not have to worry about those virtual machines anymore. And guess what? When IT pros learn that, they're like, wait, I don't have to worry about updating? No more Patch Tuesday in a PaaS service? No. Who does the patches in our servers if you're running on PaaS? We do. That's our responsibility to make sure those servers are safe and secure when you're running those workloads inside of it. And then, of course, we have SaaS, which is pay-as-you-go. So when you look at all those models, you got to keep them straight. And for the exam folks, you have to keep these straight. They're going to ask you on the exams, hey, what's the difference between this? Or give you some scenario, what would you use, IaaS, PaaS, or SaaS?
You know, that's a really great question, Matt. We actually have a lot of activity happening behind the scenes in the chat happening here, people that are attending. And there's a great question, and I'm curious to know this too. How do you personally keep IaaS, PaaS, and SaaS straight in your mind? I mean, these are all potentially new terms for us. So how would you look at those three and just separate them and keep them in your mind as how you look at them?
So I would love to take credit for what I'm about ready to show you, and it's been on the internet for a long time. But let me ask you a question, Garrett. Do you like make-at-home pizza? Is that a fun family night? You got 5 kids, and I mean, I know you want to do pizza. Everybody likes pizza. So do you have that fun family night of make your own pizza?
Yeah, no, we absolutely do.
Okay. So how I think about this, how I keep it straight, I like to think of it as pizza as a service. All right. Now, when we look at this, when we think about on-prem, that's your fun family night. That's making pizza at home and work with it. Now, people listening to this are going, wait a second, Matt, this breaks your cost model. This now, we do make it on pizza night. What's the major value add, the value prop when you do make it on pizza night?
Well, you get to pick and choose how you want your pizza to be.
Pick and choose, and it's quote unquote less expensive, right?
Yes.
All right. Now, what I'll tell, and especially with 5 kids, it's a concern for you. But Garrett, now next time your beautiful bride comes along and says, "I want to do make it on pizza night," I got a solution for you. All right. So when we think about this, yes, the ingredients will cost less. Your pizza, your dough, your tomato sauce, whatever toppings that you have will cost less. They're not going to be the same quality as restaurant quality, or even, you know, if you have take and bake pizzas or even delivery, they're not going to be the same quality. But also, what goes into make it on pizza night? You have to turn on an oven. You have to have an oven first off. Have to turn it on, and now there's like these new ovens that are out there that are just designed to make pizza. I have to go get them because they can make a pizza in a minute. I'm like, oh, I'm in when it's there. But also, who cleans up? What's the rules at your house? So who cleans up whenever you have dinner?
Well, whoever cooks doesn't do the cleaning.
Yep.
So typically my wife will cook and I end up cleaning everything afterwards.
Yep. And do you like to clean?
Not my favorite thing to do.
Not your favorite thing to do. Or the kids have to get involved with that. Have you ever had, remember Caitlin, she loves bacon. Have you ever had the, wait, they took the last piece of bacon argument in your house?
Yeah, that typically happens frequently with all of them.
Emotional cost, right?
Yes.
And then when you take away electronics, that cost keeps going over the next week, right? The point is, when you look at the total cost of ownership with Make It Own Pizza, that's why we talk about this. Will it save you money? No. If you look at the whole cost of it. Saves you money on the ingredients, yeah, I'll give you that. But you have to look at the whole cost of an inside environment. And with Caitlin, when you get the last piece of bacon, if she hasn't gotten it, there's a lot of arguments that happen. Pizzas get spilled, dumped, and like I said, we're all scared of it. But when you look about this, how I keep it straight. You know, infrastructure service, IaaS, that's take and bake. You go to your local grocery store, and in Texas we have a thing called Papa Murphy's where, hey, I want this pizza. I still got to take it home and cook it. I still have to maintain it. Or I have it delivered. I just pick up the phone, call somebody, and they deliver a pizza to my house. Or I go out to eat, and I can leverage all that. Now, dining out has some costs associated with it, but which is more expensive? So the next time your beautiful bride comes to you and say, hey, I want to go out to eat, or I want to make pizza night, and say, no, Matt said it's cheaper for us to go out to eat for pizza, and you can put all 5 kids in your van, and away you go off to eat dinner. So that's how I keep it straight. It's a fun way to think about this. I don't think, although I don't know 100% certain because I don't have privy to the exam questions, you'll be quizzed on pizzas and service, but my friends, it's a way you can keep it straight in your head. It's a way you can keep these different terms. If you've never heard them before, you're going to be tested on them, so how do we work through them? So that's pizza as a service. With that, that brings us to the end of Module 1, where we talked about the different types of computing models. We talked about private versus public versus hybrid. We talked about some of those key terms, elasticity versus scalability, where remember elasticity is dynamic scalability we have in the cloud. We also talked about how to keep straight infrastructure as a service, software as a service, platform as a service, IaaS, PaaS, and SaaS, especially when we compare it to on-prem. In Module 2, we are going to cover some more technologies around all these services, and we're going to focus squarely on Azure, on how Azure is physically designed, as well as some of the services that will run on top of it. Let's get into Module 2, Azure Core Services. And when we look at this module, we're going to talk about not only the core physical components of how we build our data centers and our regions, we're then going to take a look at a lot of the products and solutions and even all the management tools we have available to work with Azure. As a good friend of mine on our team says, we're going to go an inch deep and a mile wide. And guess what, on your exam, folks? You're going to have to go an inch deep and a mile wide. You'll have to know the concepts of these different technologies. You really won't have to know how to do a lot of this stuff, but you'll have to know what they are and what they look like. So when I look at the online learning course, anything that says core services is a great area to focus because you will be tested heavily in this particular module. So when we think about this, let's look at the core Azure architectural components and how do we design our data centers. It first starts off with big buckets we call geographies, and they really help us contain our different data center areas, which we call regions. And the good thing about this, we set up our geographies from a data residency, a compliance, and we try to make sure that all the applications and everything that run in those geographies are all closely related by their regions. Inside of Azure, we have Americas, Europe, Asia Pacific, Middle East, and Africa, where we store all of our regions inside of it. So we have this big geography, and this is something we design at Microsoft. You as our customers don't worry about this, but just understand that everything goes into geography. And inside the geographies, we have our regions. Our regions represent a collection of data centers, and we have regions all around the world. We have a lot in the US, we have a lot in Europe, we have them in Asia Pacific, but when we think about our regions, they're a collection of data centers. Important to note here, especially when we talk about some concepts coming up around availability zones and sets, understand a region is a collection of data centers. On the average, talking with some of the folks in the product group, an average region will have 16 data centers. Now folks, I want to make sure I'm very clear with this. Sometimes a data center will look like, hey, this is all the same place. Well, when you see the picture of a Northern Europe region, which we actually think it's most of the Northern region, it's going to look like one building. But in reality, they are separate facilities, and we'll talk about that in a moment. But the main point is they have separate heating, power, cooling, networking. They're a separate facility. Although they may look like they're under the same roof, in reality, they're separate facilities. Why do we have regions? Gives us flexibility and scale. Gives us data residency inside of our environments. They allow us to work with our deployments. They're really global services. And the good thing about regions, you can find resources that are all around the world for you to do your job. But be careful. Although this is not, not big differences, but not all regions are equal. Some of the regions have different resources, especially our newer regions. Will, from a virtual machine perspective, will have some of the newer hardware for those virtual machines, where some of the older regions may not have some of that new hardware.
Hey Matt, so I understand that, hardware choices, that's one of the things that could pick this region versus that region, but as I'm thinking about architecting a solution, let's say I'm brand new to Azure and I'm watching this, what are some of the other reasons why I might select one region over the other?
Yeah, and so the first one is definitely making sure you pick a region that has all those necessary features and functions for whatever solution you're building. But the other things might be cost. If you think, for example, we talked about economies of scale. West 2 on a lot of the resources are less expensive. So I might pick a region where I'm not really concerned that it's too far apart. But we're also going to pick regions from a standpoint of what's closest to our users. The general rule of thumb with regions, you're going to pick the region that is closest to the people that are going to be using that data. And so when we look at the regions that are around the world, you're not going to be here, I don't know, in Seattle and pick a region in Africa to put your data. You're going to pick one of our West Coast regions for this. Or you're going to pick a region that might be driven by compliance. For example, we have Canadian regions that are available too, and most Canadian customers don't want to cross the Canadian-US border for some compliance issues. So they're going to use the data center that are up there and local to them. And so we're going to look at that. We're also going to look at latency. And when you look at solutions like the Olympics, they have to be able to distribute content around all the regions. The most important thing about this, you put the data in the regions that you need to choose. We don't choose them for you. You choose the regions. The geographies have some nice things for us, and we work with, and we'll talk about in a second, with region pairs, because every region has a buddy. And that buddy is designed for our fault tolerance, for our disaster recovery. Something happens to a region, we can fail over to another region for it. So really, cost, is going to be a concern, and then location is going to be one of those other areas that we want to work with, and then also making sure we have the right services are some of the common reasons we choose regions. And sometimes, that feature, hey, I want to use that new feature in Azure. It's not in region 1, but I got to use region 2 to get a hold of it. So there's lots of factors. It's a very easy decision to make. It's just drop down list. But now you got to make sure you pick the right one. And that's not even mentioning we have special regions we'll talk about in Module 3 for the U.S. government and for China data centers. So we have some special issues with those of how we adhere to the compliances for the China government and U.S. government as well. And we'll talk about those in Module 3. I mentioned this, every region has a pair inside of here. This is a small subset of the region list. We have lots of regions around the world, but you see some of those common pairs. The general rule of thumb is every region pair has to be at least 300 miles apart from each other. So we're talking about huge physical separation between this. This is done by design. You don't pick the region pairs. Once again, just like our geographies, at Microsoft, we design these region pairs. It's really designed in case one of our regions goes down, we can fail over capacity to this other region pair. Bear in mind, we also look at inside those regions, we have capacity if something happens inside the region, we can fail over with inside the region before we go to the other region. We also do updates in a very controlled fashion. We do not update both pairs at the same time. We update pair, region A, get that update, and then we update region B. So we do it in a very controlled fashion, so we don't want to do this at the same time. The reason we have this is in case something happens inside the region. Now, I actually asked a product engineer, I said, what if both regions in the region pair go down? Technically possible. And the answer I thought was pretty interesting. At first it might sound flippant, but he says, Matt, if both regions go down, that means dinosaurs are roaming the earth. And understand what I just asked them. Two separate physical facilities separated by at least 300 miles that have over 600,000 computers in each of them go down at the same time. Is it possible? Yes. Is it likely? Most likely not. But if it does happen, that means there's bigger fish to fry, that something else is happening in the world that's causing that huge outage. And that would be a massive outage. Do we have regions go down? In my career, I've only seen a couple times where regions went down for periods of time. And just to be very clear, this is not acceptable. This is why we have service level agreements. We'll talk about those in Module 4, and why we make sure we help guarantee those. If those things do happen, our customers get full credits. When I've seen regions go down, I've seen customers get a full monthly credit on their bill for those outages. And the worst outage I've seen as of recent was a 19-hour outage we had, which was a really bad outage. Now, here's a cool thing about this. Not to say that regions could be brought down for longer periods of time, but when you think about how we design the data centers, and it comes back to that dinosaurs roaming the earth, folks, not saying the region couldn't have gone down for a longer period, but my rose-colored glasses come on for a moment. A region was down for 19 hours, but the true story was, and the true kind of information that's important, the region was back up in 19 hours. And that region in question got hit by multiple lightning strikes is what brought that region down, and it was back up in 19 hours, fully functional. So when you think about our data centers, and you think about these global companies, especially Microsoft that does this, we've been in this business for a long time, and we know how to design them to be very resilient. So let's take a look at a region. It's my favorite region. It's where I'm hoping I'm getting Garrett will send me one of these days. I get to go to the Dublin, Ireland. This is, although there's a lot of debate on this one, this is most of, if not all of, the Northern Europe region capacity that we have. Look how big the facility is. And if you just look at the cars that are around it, you get a general idea of these facilities. On the average, most of these facilities are 400,000 square feet in size. They have multiple power centers. They have multiple heating and cooling. They even have a lot of physical security. It might be kind of hard to see, but if you're looking at the picture, you might see the roundabout has a big cement barrier. You can't drive straight into the facility. So there's a lot of physical security here. And by the way, if you're not on the list, you don't get in the facility. I mean, even if Satya were to walk up in the data center, if he's not officially on the list, the data center techs will not let him in. Now, I'm pretty sure Satya probably gets put on the list, but he'll have to be on that list. Not saying he can't get on the list, but he'll have to be on the list before they let him in, because there's so many compliances our data centers adhere to. There's a lot of internal security. So if you ever get a chance, if you're a Microsoft rep ever, I invite you to go to a data center tour, go, because you'll learn about the physical side of Azure where all your stuff is. And our cloud services run in these regions. Now, if you look at this, you said, well, Matt, a region's made up of multiple data centers. It is. You actually see at the minimum at least 3 in this picture. You have on the very top of this environment. You have that big long strip of white at the top. You have the building in the middle, and then you kind of have the building that's kind of out back. If I had to guess, and I don't know for certain, but those are 3 different facilities. I even could take this a step further, and this is kind of a debated question with me and some of my teammates. If you look at the top facility, you see different towers. Now, I don't know what those are. My guess is, and because I can't zoom in enough, those might be separate electric and power and cooling. But the point I want to make is, even though this looks like one facility, in reality, there are multiple data centers in this one geographic footprint. And that's how I think about it. So we're looking at a region, and we have these multiple data centers that have separate cooling, networking, and power. There's even separate physical firewalls that will separate it. And kind of a fun story, I got to tour the South Central data center, which is in Texas, and the person giving us the tour had us stop midway through the tour and had us look up. And we all look up, and there's a giant block of cement above our heads. And he's like, "What is that?" And we're like, "I don't know, what is it?" Well, that's the firewall. That if something happens on this side of the facility, we can drop that wall, it'll physically separate the 2 data centers. We design these for data resiliency in case something happens. As I was slowly stepping to the side to get underneath said block of cement, because on my brain I'm going, I hope they carried the one inside of there. So when we look at these facilities, you get an idea, and I want to make Azure real for you. And you can look at it. We have lots of videos online on our site where you can kind of see the physical design of this. For me, I'm curious about this. Is it something you'll ever go in and tour? If you get a chance, go. But folks, you have to understand where your stuff is going to be inside the facility. So we start with geographies. We have our regions. Our regions have multiple data centers, and every region has a pair. And that pair, by the way, only exists in the geography they're in. So we're not going to have a region in the US pair with a region in Europe. Those are separate geographies. They have to be inside that same geography of those region pairs to work with it. So Northern Europe pairs, I believe, to either Central Europe or Southern Europe. I can't remember the pair off the top of my head, but we designed them for resiliency, and there's tons of stuff that's inside of here. I could go on for days about the tours and my experience down in South Central. My favorite, though, out of all the stuff I'll tell you besides the firewall, in Texas during the summer, people turn on their air conditioning. There's a lot of power demands on our local power company in Texas. The local power company can actually call the data center and say, "We need power, we need to take you off the grid." And the South Central data center region can completely disconnect from the local power company and run self-sufficient on just the battery backups that are inside the facility. So my friends, these things are designed to withstand a lot, and they're great environments. And South Central is one of our older data center designs. We're getting even better at this as the generations expand. So with that, why do I spend time on this? We have 2 critical components that we're going to work with in availability zones and availability sets. Now, before I dig into zones and sets, let's talk about what they're trying to do. First off, zones and sets are for at least 2 virtual machines or more. So I am squarely talking about IaaS here. I'm squarely talking about infrastructure as service. Zones and sets are only for virtual machines. You got to have at least 2 or more. Zones and sets are also mutually exclusive. You either pick a zone or a set to do what they're going to do. All right, so you got to pick them. But what do they do? Well, inside of our data centers, we have updates. We have to update our data center facilities just like everybody else. We also are running on physical hardware, which means we might have faults from occasional time. A hard drive might fail, or a rack might go down, or a network switch might go down. This is a physical computing environment, so we might have these faults. So what we have to do is work with our virtual machines. And when you think about the possibility of something happening from an update or a fault, how do you make sure your virtual servers are still available? So if we have 3 web servers that run our front end, I don't want an update to bring down all 3. It might bring down 1, so I'll lose some capacity, but I'll still have my solution being available to me. So zones and sets are designed to essentially make your applications fault tolerant and update tolerant. They're designed to make sure that those systems keep up and running if something does happen on our side. So it's our way of saying, hey, look, an update, we don't want it to impact you. Zones and sets are also free. They don't cost you anything. Now, the resources running in a zone or a set definitely cost you something, but this is the design and architectural decision. When you choose a zone or a set, it also locks you into a region for those virtual machines that are going to be in that particular zone. So when you design this and say, hey, I'm going to make an availability zone inside of South Central, guess what? You're locked into the South Central region for all those virtual machines. This also has to be done at the creation of that virtual machine. If you, oh, I just created a VM, but I forgot to put it in the zone, you'll have to recreate it. Now, there are some ways you can export that VM and re-import it, but you're essentially exporting it and recreating it inside the zone, but you have to do it at creation time.
Well, and Matt, I think it's important to notice that you showed us in the Dublin slide that there are independent facilities for power, for cooling, for networking. And I think that's really important for everybody to understand is that one of the key benefits of these availability zone is if we have a power outage in this availability zone and you have your second VM in the second availability zone, then you will not go down in that scenario because you have independent power and networking there.
Exactly right, and that's an availability zone. And so that gets into how do we make our VMs be fault tolerant and update tolerant. And what you described, Garrett, was electricity went out. You just described a fault. So we're not just talking about a hard drive failing here. Now we're talking power to that facility. How do we make sure we keep things up and running for your solution? But you as a customer of Azure have to make this choice. You have to make what I want, a zone or a set. Now zones are a relatively new construct, and generally our advice is if you see an availability zone, if it's available in the region, choose that. Sets are an older construct and they've been around forever, but how they do their job are differently. And so when we start with the zone, we're talking about, as Garrett mentioned, those two different regions. So if we look at if you think about that Dublin data center, we had those three facilities. If I have 3 web servers, what will happen is when we tell Azure to use an availability zone, under the covers, Azure will take a VM, put it in zone 1, take the other VM, put it in zone 2, and take the last VM and put it in zone 3. So that in case one of those data center facilities inside the region goes down, guess what? We still have the other 2 up and running, all right? Our solution's still available. Now, you have to start thinking about, wait a second, it's available. I lost a third of my capacity. I just lost one of my 3 web servers. And that's what will happen potentially if an update or a fault hits that zone. Well, what do you do then? Well, either just make sure those servers have enough capacity so they can run and 2 servers can run your full solution. But that's where a concept called scale sets come in, and we'll talk about that in a little bit, where we can say, hey, these are increasing, let's add some resources, and it'll take care of it for us automatically under the cover. So we have the ability to work with it. So the nice thing about zones, they provide that great isolation boundary. They give us independent power, cooling, and networking of how they become update and fault tolerant. Because guess what? We don't update all the zones at the same time. We update zone 1, then we update zone 2, then we update zone 3, and there's 3 availability zones in every region that you can choose from for your different solutions to run, but you have to make that choice. So now, bear in mind, we started with geographies, we went to regions, multiple data centers in that region is where zones live. Its counterpart are availability sets. And availability sets, I want you to go, okay, geography, region, data center, racks of computers. Although inside of our data centers we use containers, we use physical containers, I should say. They're IT pack compute containers. But think about just multiple racks of computer. Now what happens when we get down into an availability set, we're inside of a single data center, inside of a region across multiple racks. Same concept, I put those 3 virtual machines in different what we call fault domains. You can have up to 5 fault domains inside of a availability set, and up to 20 update domains inside of a availability set as well. You have the ability to separate all these. And once again, what you're telling Azure and you're telling Microsoft, look, I don't want a patch or something hardware like an electrical outage or a workload to fail or a different rack to go down. I don't want that to impact the availability of my virtual machines. And remember, you need at least 2 virtual machines to use a zone or a set. And what that does, it just distributes them. So those single points of failure, guess what? It doesn't impact the availability of whatever solution you're deploying inside of our Azure. Key notes here, locks you into a region when you choose a zone or a set. They are mutually exclusive. You can't choose a zone and a set. You got to pick one. Our general recommendation, if you have a zone, use it. It's going to give you a little bit more of a better SLA, which we'll talk about in a second. But we also look at it, fault and update tolerance. That's what we're trying to design our solution. And what level do you want to live at? What's your application compliance going to work with? All kind of determine that. You'll see sets pretty much in all of our Azure regions. You'll see zones in a lot of our newer regions inside of it. When I look at this, why do we choose a set or a zone? It's all about part of it, it's about performance and resiliency. But when we look at our SLAs, our service level agreements, when you choose an availability set, you get 3.5 nines for those VMs availability and uptime. And what does that mean? That means that server is going to run 99.95% of the time. And in module 4, we'll make those numbers a little more real and kind of give you an idea what that means from a time perspective. If you choose a set, you get 3.5 nines. If you choose a zone, you get 4 nines. And so why do I recommend zones? You get a better SLA, you get that same resiliency, it works a little bit better for us. Now, when we think about what we're doing with a zone, you're basically saying, Microsoft, I don't want a data center to bring down my solution. If something happens, I don't want to bring down my solution. There's another way to do it, and that's when we talk about region pairs. You can deploy one VM in region A and one VM in its region pair, and guess what? You now have data center resiliency, and because they're pairs, you have update resiliency. So there's ways to design solutions to leverage the built-in architecture for Azure. With that said, most customers live in zones or sets when they're trying to design that resiliency inside of it. Now here's a cool thing. We were the first company to do this. What if I just have one hand clapping? What if I just have a single server? I'm not going to need a buddy. It doesn't need a pair. Don't want to do anything else with it. Can I get an SLA for it? You can get a service level agreement. You can get 3 nines for a single VM, but you have to make the VM with what is called premium storage, which is performance. And by the way, if IOPS and disk performance is important to your solution, you're always going to choose premium storage. But you also choose what is called managed storage. If you choose premium and managed storage, Azure will give you 3 nines for that single VM. So you can still get an availability, you can still get an SLA for a single VM. But most times when you have a virtual machine running inside of Azure, guess what? You're going to put them in a zone or a set depending on what's available inside of your region.
Yeah, Matt, there's a lot of activity going on. I mean, one of the questions here is how important really are availability zones and availability sets? I guess probably not just from a technology perspective, but a lot of people are thinking about taking the Azure exam. So how important are these concepts to really understand?
So first off, from an exam standpoint solely, and we'll get into the real reason why we use these from a practical usage today. I will tell you, folks, from my personal experience, you'll see zones and sets on every exam you take from an IT infrastructure side, and then some. You'll see it on all the exams that I've taken and passed to get my architecture. I took AZ 300 and 301, which are being updated and being refreshed as we work with it. I saw it on both of those exams. I saw it on our administrative exams. I saw it on our fundamentals exam, and understand the concepts. And really the difference when we look from an exam is how they ask the questions. In AZ 900 specifically, you're gonna have to know what they are and some of the differences between it, but you're really not gonna have to know why you would use it, or you're not gonna given like a big giant scenario and which one would you pick. You're gonna have just generally fairly straightforward kind of questions. But in those other exams, you're gonna have to figure out the puzzle and the game that you'll play inside that question that's gonna be inside of it. But you get to that really important question of, why do I do this? If you don't choose an availability set or option, you're just kind of rolling the dice, you're winging it, you're hoping that Azure will put the machines so an update doesn't impact those multiple virtual machines. You're hoping that it does do it, and chances are Azure won't. Most likely, if you don't choose a zone or a set, Azure will have a tendency, not all the time, but when we think about the concept of geographies, regions, data centers, racks, it could put all 3 VMs on a single rack of computers inside of a data center. Well, what if that rack goes down? You've lost all your virtual machines at the same time. And the cool thing about this, since they don't cost anything, it's really just a design decision. You still have to pay for those 3 virtual machines, but you want to tell Azure how you want to distribute those VMs inside of our physical data center. Remember, everything that we create here ends up in the data center at a physical level, and all we're telling you is how we want to do this. And since they don't cost anything, it's now about making sure that they're updated and fault tolerant. Now, a great thing about this, especially before we offered the single VM SLA, when updates were going to impact where my VMs were running for my test environment, I would get an email from Azure to my global administrative email account saying, hey, we're going to have an update. This may impact that. If you don't choose an availability set or a zone, you're going to get that same heads up saying, hey, we're going to have an update. It may impact your solution that's running because you haven't chosen to do this.
And just one more clarification point that was being asked. You mentioned that we have to select the zone or the set at the time of VM creation. And I think if I heard you correctly, what you're saying is that's because otherwise Azure will just randomly place your virtual machine, and it could end up on the exact same set of hardware.
Yeah, exactly right. When we and you hit the nail on the head is that understand that when we make a VM, Azure under the covers will allocate hardware for that VM to run, and we'll talk more about that in just a few minutes. We're going to step through the creation of VM. What's that hardware look like? That's the ultimate answer in every IT. It depends. How much do you want to pay for? How many CPUs and things like that? But Azure has to allocate it physically, and all we're doing with zones and sets is telling you where to allocate it. You're going to do the same allocation, but they have to be in that same region for that to occur, and more importantly, it has to be done at creation because we have to allocate that. You can move the VMs, and there's actually a really good article that talks about, and I was so excited when I saw the article. I'm like, how to move a VM after creation to a zone or a set. I'm like, oh, we finally figured it out. When you read the article, it's you're exporting the VM, creating a new one, and importing that VM to that new creation. And so you still have to recreate. That's really good, especially if you already have VMs that are mature, they're running for a period of time, and you don't want to have to recreate the whole wheel. But folks, if you just make your life easy, at creation, whatever you choose, zone or set. And the other thing that we'll see is, oh, why? I know I created an availability zone. Why am I not seeing during my VM creation? 9 times out of 10, it's because you've chosen a different region. So when customers see this for the first time, they go, wait, I know I created it. I can see it in my resource group. It's there. Wait a second, why can't I pick it? You've put that VM in a different region. It has to be in the same region. So Garrett, let me ask you a question. When you think about Azure, what do you think the very first thing you're going to create? Storage, a virtual network, a virtual machine, maybe an app service? What are you going to create first?
I probably would create a virtual machine first.
Nope, you actually create a resource group first. So when we look at I trick him. It's kind of like whenever I talk to my friends, like, how do you say Louisville, Louisville, Louisville? Well, how do you say the capital of Kentucky? Lexington. Anyway, work with me here. These are things that we have. When we look at resource groups, they're the easiest thing to create. There's actually just metadata. It's a container that contains all of our resources inside of Azure. So before you create anything, you'll create a resource group. Now, when we create a virtual machine here in just a minute, it's going to ask what resource group you want to put it in, or you can create a new one during that. But the very first thing Azure will do under the covers is create that resource group, which is just a bucket. Those resource groups are used to help us have the same life cycle for an application. They're a single management unit for all the different servers. So we might have a resource group for our web front ends, a resource group for our database back ends. It really depends on how you want to organize your resources. But a resource has to exist in one and only one resource group. Now, that doesn't mean resource groups can't talk to each other. They talk to each other often, and we'd be able to leverage the resources in different resource groups. So we use it for simply organizational purposes of our resources, and why and how, it's really up to you. How do you want to set them up? We also set security at our resource group with what is called role-based access control. We'll talk all about that in Module 3, but it's how we secure our environments. Resource groups can contain resources from multiple regions, so you're not locked into a region. When you create a resource group, you pick a region for the metadata for that resource group to live, but resources can be from multiple regions of different types of resources. So you don't have to have just all VMs in a resource group. You can have the VM, the network, the storage, whatever you want to put inside of a resource group, and they can be anywhere. Now, 9 times out of 10 with most customers, when they create a resource group, all the resources in that resource group will live in the same region. That's often just a general design principle. Now, the last thing, and it's the last bullet on this slide, and it's very, very important. We don't back up your resource groups on your behalf. If you think about all of our customers, we just don't have capacity to back them up. The reason I mention this is if you delete a resource group, you delete all the resources in that group. So if I were to go delete a resource group, it deletes everything inside of it. So how do I back it up? How do you back up your data today? Make sure you have your backups and your templates and whatever you need exported inside of it. In Module 3, we're going to talk about a fantastic concept called a lock, which prevents accidental deletion of resource groups. And it's important to do that because you want to protect your resources, because once that resource group is gone, it is gone. So be aware of what we want to do with our resource groups and treat them very carefully. They're containers. Now, for what Garrett and I do in our jobs, resource groups are great. Whenever I deliver a class like I'm doing here, when I'm done with the class, guess what? I go in and I delete the resource group so I can stop the consumption of my resources. That makes it very easy for me to manage my Azure subscription that I work with inside of it. So resource groups will be the very first thing you create. They're for organizational purposes only. And that's all. They can have whatever you want inside of it after that. All bets are off after that. Now, I mentioned a key term, and it comes into the hierarchy of when you think about how our structure of our Azure environment is created, we have a very specific hierarchy. At the very top, we have this concept called management groups. Under the management groups, we actually have what are called subscriptions inside of Azure. And subscriptions are where you create resources. Now, in Module 3, we're going to talk about another term, and I want to just bring it up right now. We have subscriptions is where you create your resources. And if you look at the slide, you go subscriptions to resource groups to resources, right? That's how we flow down. But there's another term you'll hear inside of Azure. It's called a tenant. And tenant and subscriptions get used interchangeably all the time. Folks, they are very different terms. Where I want to keep your brain at tenant, when you hear the word tenant, think that's where my Azure Active Directory lives, because that's where it does live. It's what you authenticate against. Remember, I can't do anything inside of Azure until I first log on. And in Module 3, we'll talk about Azure Active Directory, and we'll talk briefly about the tenant. But you log on to the tenant to gain access to your subscriptions. And we'll talk more about that in Module 3, but it's important you understand we have to log on somewhere. You're going to be logging on against the tenant. That's one of the things the tenant does. There's a few more things, but at a high level, that's what you need to keep it straight. So we have management groups, subscriptions, resource groups, resources. And why do we have these? Because we can do things like policy at different levels. We can set security at different levels of how we work with this. It's how we organize and work with our resources. And depending on what level you want to work at, what scope you're working at, you have the ability to do that work and control how people work inside of Azure. We're going to talk a lot in Module 3 where policy comes in, role-based access control comes in from a security standpoint, lots of reasons why this hierarchy is important, and lots of reasons why you need to keep the term subscription and tenant different. And my pet peeve, if somebody comes up and he says, Matt, I'm going to create something inside of my Azure tenant, my polite remark will be back, you're not creating a tenant, you're creating a subscription is where you create your resources inside of there. So when we look at core services and products, let's take a look at how we can actually create a virtual machine inside of Azure. So I'm going to take you through the creation of a virtual machine from the beginning to the end. And the cool thing about this virtual machine, you'll see how easy it is to create a resource, but you'll see all the resources that are created. So let me hop into my portal here so I can actually show you what Azure looks like. So here is my Azure portal. You see my environment ready for me to go. Couple quick things that you want to tour around inside the portal. First off, over here on the left-hand side, you have your management bar. Now, by default, and this is actually a debate question inside of Microsoft, this is how I learned how to use Azure, but a lot of my teammates do not use this. It's a docked flyout menu. I can minimize it this way, so I just have to remember the icons for screen real estate, or I can bring it out so I can work with the resources. Now, I do like to show this just from a standpoint if I go to all services here. Notice I have different services I can bring in. If I highlight app services, I have this little star that's available for me to fill in. And if I mark that, I mark it as a favorite. Folks, when you first come into Azure, I'll tell you that I don't know if we do this on purpose, but we try to confuse you. We put all this stuff in there. And we're just trying to show you the highlights. And by the way, the default favorites are the most popular things that people use in Azure. Chances are, when you think about the hundreds and hundreds and thousands of services that are here, guess what? You're only going to use a handful of them. So make them your favorites. Don't have this big, long menu structure you have, and you can organize it inside of it. So use those favorites to add and remove the services that are important to you and what you do inside of Azure. Azure should be easy for what you do inside of it, because you're not going to use all the services and features of Azure. You're going to use a certain subset for whatever your job is inside your organization. So you want to have that set up. Now, the other cool thing about this, notice that I'm on the resources for this, and I'm going to click on the star in a moment, but I always like to point this out. Inside of Azure, we want to make it easy for you to learn how to do these things. And you notice that I'm in app services. By the way, the app services is the main model we use to write applications natively against Azure. So we're talking about platform as a service, PaaS here. But look at below the description of what the service is, there's some free training. So we actually give you links to outside of Azure articles to help you learn about this particular app service. So we want you to learn these things, and we want you to be curious about these things. And if you're like me, that's how I learn. All right, so I'm just gonna click on the star, and notice what happens. It puts app services at the bottom of my list over here on the left-hand side of the screen. I can drag that up if I want to. And if I don't want it my favorites anymore, I simply move over it and I clear the star. So navigating this portal is important. And notice where I'm at here, folks. I'm at portal.azure.com of where I'm at. This is called the management portal. We'll talk about some of the other tools in just a little while of how we can work with and manage Azure. I'm just showing you one way to get things done. There's actually, like most of the products we create at Microsoft, lots of ways to whatever you want to work with, whatever your personal preference. I don't want to use the portal, I want to use script. Okay, we have a solution for that. Or I want to use an app, we have a solution for that. We'll talk about those in a little bit. Another little quick tour here. If you don't like the menu on the right side, you do have the ability, if I look at the little cogwheel here and go into settings, I can have that menu docked or flyed out. If I choose fly out, all it does, it puts it up here in the left, where I can simply click on it to get the same menu. So it just kind of hides it. Once again, people do that for screen real estate to work inside of it. You can change the colors. We have high contrast for some accessibility needs inside of the portal. So we have the ability to work with it, including language and region. Now, the other thing that I like about this, and the last thing I'm going to talk about right now, and then I'll hop into create a virtual machine, is this screen at the top and this very important thing that says search. And let me just kind of minimize that out of the way. This is huge, folks. When we look at this, if I just start typing in availability, okay, notice what happens. It starts coming in some of the services I have in Azure, but more importantly, over here on the right, it gives you some of the information in the Microsoft Docs. And I click on what are availability zones, it actually takes me an article on our doc website that explains what zones are, what zone services, how they work, what services actually use the zones. We have the ability to work with this. And notice, there's no additional cost for virtual machines running in a zone, but you get a 4.9 availability, all right? The cool thing about this, all I did was a search. All I went up the bar and said, this is what I look for. Folks, Azure should be easy to find things inside of it. This is how you find things. You simply run a search inside of it, and then it has the added bonus of giving you a search engine that'll query outside articles. Now, not on AZ900, but when you take other Microsoft exams, we have what are called performance-based testing, AKA you're going to have labs. In other words, our newer exams, you're going to be asked to go do something. Oh, you got to go create a virtual network, or you got to create a storage account, or you got to create a virtual machine, and they'll give you all the parameters, but you have to make them. In other words, you have to know how to use this portal, or it'll say, hey, this resource is broken. What do I do when I take these exams? I just run the search. Now, in case you're wondering, now I didn't do this, only somebody told me this. When you run that search, it will give you the links to the outside articles, but when you click on them, this is what somebody told me, I would have never done this, never, nope, not me ever. It comes up to the link does not work. It will not let you go look. In other words, our exams are not open book. Definitively not open book, but you can use the search bar to navigate around those exams very quickly when you're trying to create a certain resource or move around to finding a navigate a resource to whatever that task or question they're asking you for. So exam tip, learn to use this search bar. Real life world tip, learn to use this search bar. It is important to how to move around the portal inside of it. So let's go ahead and get into the story of how I actually create a virtual machine. So I'm going to go, and this is just one way we can do this. I'm going to go to all services. Or actually, I'm going to go to create a resource, I should say. And create a resource, I'm going to go to Windows Server Data Center. I'm just going to go ahead and click on that. Make a Windows server, and now it takes me into the wizard to actually step through this. Now, folks, the first time you create anything inside of Azure, I recommend that you use the GUI to create it. So you can see all the wonderful parameters, all the things that go into creating a virtual machine. Down the road in real life, folks, you're going to learn how to script and automate this. And I'm going to talk about some of those tools and techniques in a little while when we get into the management of Azure, but you're going to want to learn how to automate this. But for us right now, we're just going to step through the GUI so I can show you all the stuff that's being created for it. So it says basic, what subscription? And notice the very first question here, what resource group? I have a resource group already created called AZ Fun for our fun that we're going to have today. I'm going to give it a name. We'll just call this Fun VM. This is, by the way, the worst part of my day is typing things in public. I'm going to say fun VM2 because I already have another VM created. I can choose what region I want to put this virtual machine. I'll choose West 2. And notice it comes up, it says availability options. And if I click on the down arrow, notice I have the ability to choose a zone or a set. And I have this option called preview. Now, I'll remind you again in Module 4, but at Microsoft, the life cycle of all our products go through 3 really big general stages. We have a private preview, and that's where we're generally looking for a certain type of customer that's going to do a certain type of thing, and they're invited for a private preview to work with those to actually work with our product group to develop a solution. After it graduates from private preview, it becomes what is known as a public preview, and in Azure we show you those. You're seeing one right now with virtual machine scale set with preview in parentheses. What that is, it's a public preview product. Now the only thing I want to be very clear on, friends don't let friends put production stuff in preview. Why? Because there's no guarantee that a preview product will graduate to its next step, which is called general availability. Now, most products that hit public preview will become general availability. But understand, while it's in preview, generally there's really not a lot of costs associated with it. There is some, but there also is no service level agreement. We give you no guarantee that they're going to run. It doesn't get its official cost or service level agreement until it hits general availability inside of here. But notice I have availability zones. I have the one in preview and sets. But I'm going to just make a quick change. Instead of West 2, I'm going to choose South Central. And notice now, when I highlight this, notice what's not available for me, availability zones. Remember, not all regions are created equal. South Central is one of our older data centers. Now, I don't know if South Central will ever get availability zones, but right now it doesn't have the ability to have availability zones inside of it. And if I want to choose an availability set, because I'm going to put it in South Central, it's going to ask what set do you want. Now remember, what if I already created a set? So Garrett, if I know I created a set, why am I not seeing it here? What would be one of the first things we could check?
Very likely because you put that in a different region. Your availability set's in a different region than where you're trying to create the VM.
100%,
Right.
Yep. Understand, folks, if you've created an availability set, and I get this question all the times, why don't I see it? I know it exists, I created it, you're probably in the wrong region, okay, that are there. So I'm going to choose an availability set. In this case, I don't have one. I kind of fibbed a little bit. I want to see if Garrett was paying attention, keeping awake over there. And I'm going to say create, and I'm just going to say fun set 1 inside of here. Now, folks, word on my naming convention, I just kind of have fun because we're in the fun class. General rule of thumb, have a naming convention. I don't really care what you call your stuff. Just make sure it makes sense to you so you can find and work with resources. So I have an availability set. Then I have an image, and right now I'm pulling a Windows data center image, and this is coming from the marketplace. Understand what we're doing here. I'm buying a brand new license for Windows Server. Well, if I wanted to choose one of the other regions that are, the resources that are here, if I click on this, I have Ubuntu, I have Red Hat. Wait a second, those aren't Microsoft stuff. Those are Linux machines. Azure is a heterogeneous environment. Matter of fact, Linux, from a standpoint from virtual machines, is outgrowing Windows servers currently. We have more Linux systems running, or will be running, in our environments. People like those servers, whatever they want to choose, all right? Why do we choose other systems? It solves a problem for whatever we're trying to do. It might want to save us money. You have images that you can pick and choose from. They all come from the marketplace, but the cool thing about the images, you also can upload your own image. So let's say you have an example, hey, this is what my SQL server looks like, or this is what my Apache server looks like. You can take that image and upload it into your subscription, so now you can use that image for creation of virtual machines that helps speeds up the process for you. Now for us, I'm making a brand new machine, so I'm just going to choose Windows Data Center. Then we have the size of the virtual machine that we have, and notice the size is a DS1 V2, which currently on my subscription costs $46.43 a month to run, but it's one CPU with 3.5 gigs of memory, a fairly generic server. If I click on change size, I have the ability to change the size to other VMs. Now, this is not all the VMs. When you first come into this wizard and you go to change size, it's highly filtered for the different types of generations. But let's say I want a bigger VM, I can simply choose a D2 V3, and that system's going to cost me a certain amount of money, but I can select that, and now that's going to cost me $80, but now I get 2 CPUs and I get 8 gigs of RAM. So I give myself a little more headroom. My general rule of thumb when you're choosing the size of the VM is make sure you pick a VM that you can resize. So go small, go low, all right? You can always change the size after you create the virtual machine as long as that size is available to you in the region you choose. The next thing here, it's important. This is a local administrative account. So I'm going to go ahead and type in my local administrative ID and my password. Oh, and by the way, just kind of a fun here, you can't use words like admin or administrator. For my open source folks out there, you can't use root. But if you happen to be a Marvel fan, you can use Groot. We have to have fun with this, folks. And if I type in M. Hester, I'm just going to use my alias here. And I'm going to type in my password. And trust in the fact that I'm not typing dots. I just typed in the word password inside of here. Notice, and in case you don't believe me, if I hover over top of that and click on it, I've typed in password. It doesn't let me use those words. So you have to come up with a complex password of numbers and numerics that we have. Whoops. I'm going to hide. There we go. And then you have to repeat it in case you just forgot it 2 seconds ago. So I'm going to go ahead and repeat it in. Oops, I knew I got that wrong. Worst part of my day right now is typing passwords. All right, got it matching. Then we have this thing called an inbound port rule. What this is allowing us to do is open up port 3389 for RDP management. So I can log into this VM and do work on it. Remember, this is a virtual machine, it's a server, there's nothing there. But if I want to install and configure it, update it, this is where I would come into that. We're actually modifying what's called the network security group here. We'll talk more about that in module 3, but it's important. But also, notice the warning message here. It's telling you you have a public IP address for this VM and a public port. In other words, this is potentially vulnerable. In most of your organizations, you won't be able to do this. You won't be able to open up this port, and this virtual machine won't get a public IP address. I'll talk more about that in just a little bit when we connect to the VM after we create it, but that's here. We can save money using what is called the hybrid benefit. I'll talk more about that in module 4. If I go next to the drives, just at a high level, I can choose what type of drive I have, which is a premium SSD. If I pick on the down arrow and choose standard, notice what happens. Azure come up and say, hey, look, you can do that, but this may not be as performant as you want. You want to leverage premium drives for all of your virtual systems. Just a performance benefit. But if I just create down here and I expand the advanced, notice it says use managed drives or managed disks. What's that mean? That means Microsoft is going to manage the storage of this virtual machine under the covers for you. You don't have to worry about it. Now you pay a little bit of upcharge for that or a little bit of a premium for that, but the cool thing about it, you don't have to manage that. And remember we talked about sets and zones to give machines availability inside of here. If you just have a single VM, you'll use premium managed drives to get that guaranteed SLA. But if I simply say no to this, notice what it asks me, where are you going to store it? Now I'm responsible for the management of the drive. For us, I'm just going to choose yes, because I want to have it managed by Azure. And by the way, most customers will do this because they don't want to have to manage a storage. Even though I have a set or a zone, I don't have to worry about it.
Hey Matt,
yes.
With the managed disks, does that actually allow for a more predictive cost model? We talked about predictive cost versus variable cost. Is this, using a managed disk, does that give us a more predictive cost on the disk?
It will, because we have controlling of how much traffic is coming in and out of it. That's part of that premium managed storage. But the only thing we can't tell you for certain how much you're going to put inside the VHD. How much data is going to be there. We can give you a really predictive cost of what that service is going to cost you, but then it's how much are you storing inside of that. And hopefully you'll have a general idea. And the cool thing about this, and this is just IT 101, this is just where the OS drive runs, right? Where the actual operating systems run. In real life, and you see the options here, you're going to create and attach your drives for data drives and where you're going to put that information there. So it does help us have that predictive cost, but once again, we still don't know how much you're going to store. So we can get close, but how much is that VHD going to be? And bear in mind, this is a virtual hard drive. I believe, and I'll get this wrong, I always get it wrong, it's going to show up like you have 127 gig, but in reality, that VHD file is maybe 1 or 2 gigs in size. So you're only paying for that 1 or 2 gig, not for the actual what looks like capacity inside the virtual machine, just virtualization. Click on next for networking. Notice inside of networking, everything has to live on a network. Now, I'm not going to do a deep dive into the virtual networks in this course. It's kind of out of the scope of what we have. But folks, I just want to point out, notice we use this, what is called CIDR addressing or CIDR addressing, depending on who you talk to. But you see that nice pretty /24, that tells us our subnet mask for our network ID and our host ID in IP4 mathematics. You won't really see this on this exam, folks, most likely, but I guarantee you'll see it on the other exams. You'll have to know what that /24 is. Now, for the folks that are going, I know IP, I can't remember. If I were to tell you that /24 means the subnet mask is 255.255.255.0, that's what it's telling us. If that makes sense to you, then you're well on your way. But we do offer some courses that help refresh modern IT essentials that are online and available to you if you want to leverage it. So not going to go into a lot here. You'll also notice that inside of here I have my port for the inbound. We have load balancing. We'll talk about that in just a little bit as well. Next, if I go into management, It tells me different things I can do inside of management. Notice we have the Security Center basic plan. Every customer gets that. I think of Security Center as a way that we can advise you what's going on inside the virtual machines. We also have boot diagnostics, which is the general status of the machine. Is it restarting? Is it up and running? What's the general CPU performance? What's the general networking performance? But if you want to reach in and leverage Azure Monitoring Service, you can reach in and install an agent on this VM that will pull out, in this case, it's a Windows server, it'll pull out the event log from the Windows system so we can manage that fully. And now I get one single pane of glass that tells me, hey, this is how the machine's running in Azure, but also now under the covers, how is that machine running? And you think about kind of the problem. When I'm looking at metrics inside of Azure, it's going to say, hey, this machine's at 85% utilization. You're probably going to ask the question, why? The log files inside that VM will tell you that other part of the story. Azure will say you're 85%. Why? You'll reach into the machine and look at the log files to pull out that why inside of it. It's not turned on by default for the simple fact that it does create some additional storage. So we want to make sure customers are aware of that. And you may not need to log inside of there. It all depends how you want to work with it. We have a system managed identity here, just real brief on that. What that basically means is that this machine may need to go access resources in Azure, but it doesn't have a user ID and password. So if I give it a system managed identity, I basically give this VM a user ID so it can run around and consume resources that it may need to do its job. We have the ability to do auto shutdown on VMs. You know, our mom always, or at least my mom always told me, turn the lights off when you leave. One of the common methods that's happening inside of Azure is, why do I have 15 servers running over the weekend when I know 5 servers will cover it? During the week I need all 15, but on the weekend I only need 5. Well, we can enable what is called auto shutdown of those VMs so that every day at 5 o'clock on Friday, it turns off those VMs. Why is that important? You reduce your cost charges. I don't need them. Why leave them on? Why didn't we do this on-prem? We were afraid that the server wouldn't turn back on Monday morning. If anybody's ever done this, okay, I got to turn the server off, I got to reboot it, I hope it comes up, and you hit the power button, you're just going, please, 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 please come up. Well, guess what? Auto shutdown turns off that machine. Now, I want to be very clear here, and it's a marginal thing I just want to make sure you're aware of. Notice it says auto shutdown. There's no auto turn back on. Although you can do that very easily in script to have a script turn VMs back on Monday. It's actually a very straightforward, and within the shutdown article, they talk about how to create that script. I wish it was auto shutdown and turn back off, and so my request, if any product group people are listening to this broadcast, can we get an auto turn back on please feature, whatever we want to call it. I'm going to turn it off for the particular demos here. We can leverage Azure Backup if we want to back up the VM. I'm not going to do that for this particular instance. If I go to Advanced, it tells me what extensions do I want to install here. Extensions add things. Bear in mind, what is this wizard doing? This wizard is installing a brand new virtual machine. What's in the virtual machine? Nothing, just the OS, that's it. So it's a single hand clapping doing nothing. Yeah, exactly right. This is where we can come in and configure it. Now, if I choose the extension to install, just want to give you a quick little tour here. We have all kinds of extensions we can add to this. We can add in our backup. We have Microsoft Anti-Malware, but we have a really pretty one here. It's my favorite one. The reason I come into here, custom script extension. What does that mean? Not only will I build this virtual machine, now I can tell Azure, run a script when you're done. In other words, turn the machine on, create the Windows server, now run this script to go do something. That might be to configure it, that might be to work with that environment. It all depends on what we want to do, but we have the ability to add these custom scripts after the fact. Very common that we do this. Very common that we work with it. So I'm not going to choose any extensions here. Just close that down. Tags. Tags are a huge governance control that we have inside of Azure. We'll talk more about these in Module 3, but one of the common reasons we're going to tag resources is for the simple fact that we want to make sure a resource is properly billed. So if you have multiple departments, how do I know the finance department? Well, that VM's run the finance department. I can use a simple tag to do that to help work with the bill. We'll talk more about that in Module 3. And the last one I'm going to hop into is next review and create. Now, if you're like me when it comes to technology, like just click on the things, okay, just hit create, you're going to miss something just wonderfully important here. On this screen at the very bottom to the far right of the word create, it says download a template for automation. You might be impressed to know that, guess what? As I was going through this wizard, Azure was remembering everything that I was making a choice of. And it was storing it in a template file, and it's a JSON template file that I can use and I can save to recreate this VM down the road. And all the template will do is remove all the uniqueness, my name of the computer, all the IP address. It just makes it unique. So I'm just going to say download a template because I want you to look at this. file for just a moment. And this template file basically has all the parameters that describe that particular VM. And if I go into parameters, you can see the different choices under the covers that are here. If I scroll through this list, notice I have South Central US, I have the name of the VM, I have that RDP port opened up, I have the different environments that are there. I even have my storage type, I have my username, all that stuff is being captured for me. I can take this template and I can add it to my library inside of my subscription, which means now I can pull this back out, dust it off, and deploy another solution. Now, I will tell you quite frankly, folks, this particular template is bigger than it probably needs to be. Most templates that you create inside of Azure are very singular focus. This template's going to create the virtual machine. This template will create the network. This template will create the network security group. They will generally be that way. This is a really big template because it has everything. Virtual machine, storage, networking, public IP address, network security group, any management extensions, blah, 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 blah. It's all inside of here, but we can capture that. Now for us, I'm just going to go back to the create a virtual machine inside of here. And if I scroll down, you'll notice that, hey, you've opened this up, you open up RDP, once again, giving us a recommendation. You're doing something that could possibly create a vulnerability. Tells us all the information about what we're going to create here. And I'm going to simply go ahead and go create. And Azure is going to go run and create this virtual machine. And this virtual machine will be up and running in anywhere between 1 to 2 minutes, depending on what you're doing inside that virtual machine. Now, under the covers, it leverages a thing called the Azure Resource Manager for the actual creation of the virtual machine. You can see the resources are already being populated inside of here. The actual creation, notice that, hey, look at all the stuff it created, all the resources. It's creating the availability set, it created the IP, created the network security group, it created the virtual network interface, and we're going to see this, and as I refresh this deployment, we can see different information that's there for us to use and leverage, and it'll take another minute or two, it'll create the VM, we'll just take a quick look at where that VM is created, and then we'll move on with the rest of our presentation. So we'll give it a second to run here, but Garrett, when you think about this, what are some things that kind of strike you as I went through that wizard? What are some things that you were kind of interested in, or kind of some areas that you want to dig into a little bit?
You know, when I'm thinking about how you're building this, I'm thinking about reusability, right? As an admin, if I'm going to have to stand up a large deployment, I don't want to have to go through this wizard every single time just to create another virtual machine. So I really like the fact that at the end of all of it, you're able to download that file and create that repeatable process in a much simpler fashion.
Yep, and I'll do you one even better. At the end of the module, we're going to talk about other ways. I could have done this all in Azure PowerShell. We also have a thing called the command line interface, CLI for short. I can automate all this in lots of different ways. And so, you know, people sometimes joke at us at Microsoft, well, we have 8 ways to create the same thing. We do, because we want to give you the flexibility, what's the most point. But you bring up a huge word there, repeatability. We want to make sure that we can duplicate this in a very consistent, controlled fashion. And when we start talking about deploying things, templates are one way to do this. I talked about another one. Well, I want to have a server, and this is always going to be what my web server looks like. It's going to have this server, it's going to have Apache, it's going to have this certain configuration. This is where it's going to pull its images file directory from, and I have all that stuff. Well, I could actually just create that as one of the images. So I can, hey, my starting point is just not the OS. My starting point is everything installed and configured, just deploy it. And then I can use a template to call on that, or I can use it via script. And really, it's up to you to actually work with this inside of Azure. Now, while I was talking, it's kind of my stall tactic 101, the VM was all created for me to look at. Let me just go ahead and hop into the resource here. There's a button that says go to resource. And in the resource, I can find information about its public and private IP addresses that were assigned during creation of it. I can also connect to this. We have the RDP opened up. I'm not going to connect to it in this particular one, but we can connect to it. We also have a new one called Bastion, because the question is wait a second, Matt, I have to go in to control it, but Azure's saying that if I open up port 3389, it's a security vulnerability. And they're right. But we actually have a new service in Azure called the Bastion service, where I can actually put this virtual machine with no public IP address behind a separate network that does have a public IP that I have to authenticate against first before I can access that VM. And it becomes a really nice way to connect in a safe and secure. Kind of a little out of scope what you might see on the exam, but from a usability standpoint, remember, what was my one thing? I wanted everybody to learn at least one thing during this class. Understand the Bastion service will eliminate the need to have that public RDP port and public IP. And more to the point, folks, chances are in your organizations, you won't be able to distribute public IPs onto VMs. You'll have IT governance that prevents that. Why? Because you don't want your organization to have a security vulnerability. And You also don't access a VM directly. We'll talk about a couple other ways inside of it. So if I go back in and take a look at the environments here, just a couple highlights. I can connect, but I can always change the size. If I change the size, remember we talked about scalability in the cloud. Inside of here, I can change the size of this VM anytime I want. I can scale it up or I can scale it down by simply picking the new size of whatever I want to choose and clicking resize. Now, just a word of caution here. When you click on resize, there is a period of downtime that occurs because we have to reallocate new hardware. We have to move this VM to new hardware. The cool thing about that downtime is fairly minimal. When I say minimal, think seconds, because we actually have to move this file to a brand new set of hardware and redeploy it. Now, from my personal experience, if you stay inside the same family like the D series, 10, 15 seconds. If you go to a whole new family, like go to a G series VM, it might take a little bit longer, so we have to go dig up that hardware inside the region that you're in, but always think small. But this is a manual process when you're scaling up or scaling down. Remember what that is? Adding resources to that virtual machine for us to use and leverage inside of here. So just a quick tour of the VM, but it's there, it exists, it's available for us to do to whatever workload that we want to use and leverage. What are some other virtual machine services we have inside of Module 2? So understand we have Azure VMs, creating the virtual machine that's inside there. We have a concept called scale sets. Inside of Azure, we have this concept called an auto scale set. What this allows me to do is take an Azure virtual machine and say, hey, I need to add 500 more virtual machines to solve a problem. Maybe you got mentioned on a popular show, your website's going to get popular and need more virtual machines. And the scale sets, based on thresholds, will scale out automatically, whether it's a CPU or a memory threshold. The cool thing about scale sets is that they are elastic, which means not only will we scale out, but as those thresholds are unmet, we'll start to scale in automatically for you. We also have two other ones, app services and functions. Wait a second. Virtual machine services, Matt, those are platform as a service. And yeah, exactly right. App services and functions are very much platform as a service. But what did I tell you about Azure? Everything runs on something under the covers. Now, who manages the virtual machines for those app services or functions? We do. You're in the PaaS side of the house. That's part of our responsibility. You don't have to worry about patching the OS, but know that when you create an app service, you write code natively against Azure, or you create a function, which we'll talk more about those in just a little bit. Under the covers, there's an operating system there, and there's something that's running to support that app and to support that function. Inside of Azure, they're all there for us automatically. So you can't just think, when you think virtual machine, yeah, if you're thinking Azure VMs, that's definitely infrastructure as a service. But when you think app services, that's platform as a service. They all use virtual machines under the covers. Now, other common technique that we have inside of Azure that we're leveraging is actually an industry environment we have, which is called containers. And containers are different than virtual machines. VMs, when we look at them and we look at virtual machines, some people call them bloated, or I call them heavy. And what they are is whenever you have a virtual machine, you have your common OS, you have the runtime, your whatever operational framework, and the application running on top of it. But if something happens to the application, generally you have to reboot the entire operating system to get the application to restart in a proper fashion. And pretty much with virtual machines, you rinse and repeat that. You have the same operating system, it has the same runtime, and you have the application on top of it. More importantly, you have the same OS. So they're very large files, they're heavy, they're not very portable, they're not very cross-platform friendly. In other words, hey, this OS is Windows or this OS is Linux, how do I work with it? Well, along came a concept called container, and I believe Docker was the first one to do this, and mostly for the open source. If you think about open source systems, and you think about the different varieties and distributions of Linux, there was a problem here with folks that were developing Linux. And when I mean problem, just understand there's a logistics issue here. Well, what distribution of Linux did you use to deploy that? So along came this container technology that sits on top of a common OS that gives me a container runtime. In other words, I don't care what your OS is. I'm going to give you a container runtime that we all can adhere to, and I can write my applications on top of it. The cool thing about this, it gets rid of that need of the operating system to run over applications. Because it's one of the age-old things. A good friend of mine, Bill, who I used to work with a long time ago, I used to joke with him because Bill was a developer, very good developer. Actually great, I would probably say. But whenever Bill would come into my room and I'm talking about infrastructure stuff, I'd always joke with Bill. I said, you know, Bill, without my server, you have no place to run your application. And to which Bill would reply, Without my application, you have no reason to run your server. And so we talk about the chicken versus the egg, what comes first. And what this makes this nice, it makes applications very efficient, makes them cross-platform friendly, makes them very portable, makes them movable. Now, if your brain, when you hear the word container, is thinking about a cargo shipping container in the ocean somewhere coming up the port with all the containers, your brain is in the right place, because that's what they're designed to be. Because I don't care what ship that container is. The same thing with our containers in our applications. I don't care. As long as I have that platform, I can move that container to wherever I want. As long as that common platform is there for me, I can run it. Containers become a very fast and efficient way to run code. And you think about that first scenario, if I have to reboot the application, I just have to reboot the app. Very fast and efficient, where you have to reboot the OS, then reboot the app. This is why we're using containers. I always joke with some of the folks in the product group, if we did not have Azure or cloud technologies in our world today, you would all be moving from your Hyper-V or VMware farms into container technology. You'd be doing this on-prem, and it's happening now. The cool thing about Azure is it supports container technology, so we can run this application portability. Now, another fun question, if you ever meet Microsoft folks in these teams, you can kind of ask this question. I call it a debate generating question. Hey, I'll never use containers. I can just use the platform services and write natively. There are benefits to writing containers inside of Azure versus using platform as a service, but it really depends on what that application is going to do and which choice you make, because we do support both containers inside of Azure as well as the Kubernetes services. So container instances inside of Azure is basically a PaaS offering that allows us to upload your containers and work with them inside the Azure platform. So we can put these systems inside of our container service. So our container runtime essentially is Azure container instances under the covers. But then we have a thing called Kubernetes. Now, you think about our containers. We have all these little boxes of containers on that cargo ship. Well, what's the thing that moves them around? It's a big crane, right, that sits on the dock and moves them around inside of it. And who's controlling the crane? Most likely the captain of the ship is saying, hey, put this container here, and they're balancing the workloads. If you've ever watched the show Deadliest Catch on TV, they're trying to organize those containers and the crab cages to organize it. There has to be done in a very logistical fashion, kind of the same thing with our cargo ships. That's what the Kubernetes service does. It's that orchestration for managing those containers. Now, fun geek tip I learned from my friend Chris Henley. Kubernetes in Greek, you know what it stands for in Greek, Garrett?
Yeah, I have no idea, Matt.
It stands for captain in Greek. Loosely translated, by the way, loosely translated from Greek, but Kubernetes stands for captain. If you think about this, and for your exams, keep it straight. The captain of the ship is Kubernetes, it's the orchestrator. What is it orchestrating? The containers for those application codes inside of it. So Kubernetes, Greek for the word captain. Learn something new every day. Some more services we have. We have Azure Network Services. We have the ability inside of Azure to create virtual networks. We did that when we created our virtual machine, and that virtual network is where everything lives. Everything has to have an IP address for communication. We have load balancers. Load balancers are great because that's where your public IPs are going to go. If you have a web farm with 3 servers, when somebody comes to your website, how do you determine which server they go to? Well, what if they all flood number one? Number one's going to get overutilized, and the other 2 are not going to have any work. A load balancer balances the load of that workload coming in from the internet to those different VMs. We also have VPN gateway and peering, and I'm going to talk about those in a moment, but it's one of the key technologies we use under the covers on how we can connect our virtual networks, but also more importantly, how we can connect from on-prem into Azure for hybrid networking. So we're going to use VPN gateways or peering. I'm going to talk about those differences in just a moment. We also have Azure Application Gateway. Well, what about our applications behind the environment where we don't necessarily need a load balancer for those virtual machines? We have app services, and we want to make sure we balance those load. That's where the gateway comes in. The gateway also has a huge security advantage for what is called a firewall, layer 7 firewall security. And what that is, whenever we have data coming into the application, we just let you come in. Hey, your port 443, come on in. Well, what happens is that the application gateway will inspect the traffic to make sure that information is valid traffic and not contain bad packets. Content delivery network. I've mentioned this a couple times, but I'll mention it again. It's how we move large amounts of content in Azure from one region to other Azure regions around the globe. The best case study we have here is the Olympics. The Olympics in Rio actually leverage the content delivery network, and I believe they're going to leverage it for future Olympics. But what happens is when you record an image over here on one side, how do I get that file over to your region that's closest to you as a consumer so you can watch an Olympic event? You know, I oftentimes like the field and track events. They're not always on TV when I can watch them. Well, I can just go to the website, downloaded, it's coming from a content delivery network. It moves content on our networks, on our background. It leverages it. And a lot of services inside of Azure, for example, the front door service uses the content delivery network when people come into our front door without letting them inside of it. So when we talk about network and connectivity options to Azure, this is where we have to talk about a couple things that are important to our networking story. First one is peering. What is peering? Peering is connecting virtual networks together inside of Azure. And so if I have VNet 1 over here and VNet 2 over here, by default, virtual networks are isolation boundaries. They don't talk to each other. So if that's what you want, you never do anything with them. They're ready to go, and you put all the resources in the different networks. But what if I want VNet 1 to talk to VNet 2? I create what is called a peer relationship. Now bear in mind, this is on our network, so this is in our private network, and that peer, all it does is creates a pathway for Azure to be able to talk VNet 1 to VNet 2. It just creates a roadway. Azure under the covers automatically makes the routing table so this occurs fairly easily, and it takes just minutes to set up a peer. Peering, though, does not encrypt traffic between virtual networks. So inside of Azure, we can set up a VPN VNet connection, which will set these two networks up, and then we'll encrypt the traffic inside of it. Now, folks, once again, remember, where are you at? You're inside of Azure. You're already on a private and safe and secure network. Unless you have an application that needs an additional layer of security, you're not going to use VPN gateways. You don't need an additional layer. Now, some customers that might be in some of the governmental data centers may need that for compliancy, but most customers do not. In other words, use peering unless you absolutely need that encryption channel. One, it's easier to set up, it's fast, it's very efficient. But now let's talk about our on-prem environments for a moment. How do I connect my on-prem systems to Azure? And there's three really big ways we can do this. One's called a point to site. And I want you to think as an administrator of the environment. I have something on my laptop and I want my laptop to connect to a virtual network inside of our cloud. I'll use what is called a point to site connection option. In other words, I load essentially a little VPN client on my laptop that I can log on to that VPN client and connect to that virtual network and do whatever I want inside that virtual network. It's a point, administrative point into an Azure virtual network. Now, if you want to connect your business inside of Azure, what you do is called a site-to-site VPN connection. And what this does, every business, you have a public internet-facing router. It sits on the edge of your network. It's how your business can talk to the web and talk to other resources around the world. What you do is at that level, you can configure that router to talk to an Azure virtual network. And what's nice now, you've basically made Azure a branch office of your environment. You've connected these two networks together, and whatever resources I have on-prem here can then talk to the corresponding Azure resources in the cloud just by going over the site-to-site connection. Now, both point-to-site and site-to-site connections run over the public internet. They're VPNs, so that traffic is encrypted from our points to the actual Azure networks that we have inside of there. But they are going over the public internet. Now, with site-to-site and point-to-site, the default traffic speed is 100 megabits a second. And with point-to-site, that's the fastest you can go. Now, it doesn't seem like a lot. In reality, it's not. But when you think about we're just doing RDP and maintenance, it's actually quite a bit of traffic. With site-to-site, you can actually go up to 1 gig. You can actually purchase different SKUs to increase the bandwidth inside of there. But if you don't want to go over the public internet, how can you access Azure? We have a concept called ExpressRoute. An ExpressRoute is a private, dedicated connection that you have on-prem that will connect you directly into Azure so you can access our resources in our data centers. And by the way, it's not just Azure. We're thinking of in the Azure world, but once you have an ExpressRoute connection for your business, you could possibly leverage other services in our Microsoft cloud environments. Things like Dynamics 365 or Office 365 are available for us. That private connection is a dedicated line. Now, folks, ExpressRoute can be expensive and can be cost prohibitive. There is a price that you have to pay for that. And you can go anywhere between 1 gig connection up to 10 gigs. You can have it metered or unmetered. And if you look at the calculator, if you're doing an unmetered connection on our premium switch, it's approximately $50,000 a month for that connection speed. Now, it seems like a lot, but depending on your business, that might be a drop in the bucket to what you need to do. Why we have ExpressRoute connections is when you need that high-speed dedicated channel into Azure, so we have that constant communication, but it's a private network. Now, you also have one other potential charge here. You have to have an MPLS circuit. In other words, you have to have a provider that drops that fiber into your business. They're going to charge you generally a monthly fee for that fiber plus installation and configuration. It's almost like when you buy a brand new house and you get internet access for your home, you have to drop that information inside of it and hope they have fiber or something into your environment to work with it. So we have ExpressRoute connections, which gives private connections into Azure. So we have lots of connectivity options for us to use and leverage on how we connect at a real high level. Now, folks, I just got done talking about networking, and just a little bit before moving to data, networking in a lot of our courses is usually one day all by itself. We spend 8 hours just talking about networking. So I'm just giving you the tip of the iceberg, like we're going to talk about data here. When we talk about data, we have three main types of data. We have structured data, we have semi-structured data, and we have unstructured data. The most popular on this list, by the way, is unstructured data. Inside of Azure, we call unstructured data called blob data, or binary large object. Now, I'm actually rather disappointed when I learned that blob was an acronym, because in my brain, I'm going to the 1970 horrors movie with the green blob running around trying to catch people. But it really is just unstructured data. Most of the files we work with, JPEGs, videos, PDFs, Word documents, Excel spreadsheets, email, Visio diagrams, pretty much anything we put in SharePoint, unstructured data. But how do we use that? Well, I'm going to talk about how we leverage it inside of Azure, inside our blob service in just a moment. But we also have semi-structured data. These are things like NoSQL, where there is some structure to it. So Cosmos database would be semi-structured, because it's a globally distributed NoSQL. We'll talk more about that in a moment. And then we have structured data. These are our relational databases. Think SQL Server, think Oracle, think all those different things where there's a schema and they work with it. Inside of Azure, we have these different categories of storage, but how do we store them inside of Azure? Now, database services are done a little differently, but where you're going to store most of your data is in what is called a storage account. And a storage account inside of Azure spans two different categories. We have infrastructure as a service, IaaS services, and we have platform as a service, or PaaS services. On the IaaS side of the house, we have what is called disk storage. Remember I talked about premium storage and managed storage? Under the covers, Azure automatically creates a storage account that stores your VHD files. Now, we have another version which is called the Azure File Service, and this allows us to put an SMB file share inside of the cloud technology. Server message block is a very common way we access it. Now, if some of you are going, hey, what's server message block? If I were to tell you / server name / share name, that's server message block, and SMB allows us to access those files in the cloud. Now, exam tip 101, I don't even know what tip, I'm probably like 15 by now. Folks, if you see a question on your exam that says you want to access storage in Azure using the SMB protocol, the answer with 100% certainty is files. It's the only one that will ever speak SMB protocol. Everybody else can be accessed via APIs, but if you're SMB, files. SMB, files. Garrett, SMB?
Files.
Very good. So you would have gotten that question right. Exactly what we do inside the environment. We also have platform as a service where we contain the other types of storage. We have containers for our container storage, and our containers really are not for our container storage, for our blob storage. We have page blobs, block blobs, and that's how we're going to use and leverage the information. Under the covers, it's all about read and write accessibility, and we'll talk about that in a moment. We also have append blobs for log files. We're just going to append to the end of that environment. We have tables for NoSQL data, and then our applications need to talk to each other, and we use queues for that application communication. In other words, they have to store their messages somewhere. They use message queues. For exams, kind of know at the real high level the different general ideas what we have inside of it. But what I want to show you is how to actually create a storage account where all this stuff is created. A storage account inside of Azure is just a bucket on where we contain our resources. What can be in a storage account? Can I have structured data? Yep. Can I have unstructured data? Yep. Can I have semi-structured? Yep. It's where we store everything. It's just an account. So I'm going to go through and step through the creation of the account to show you what it is and how to use it. So let me hop back into my portal here. And in my portal, I'm just going to go into my storage accounts. And I'm going to go ahead and add in a storage account here and give it a second to come up. And first thing, with pretty much everything you go here, what subscription and what resource group, constant. So I'm going to say AZ Fun. If I scroll down, it's going to ask, what is your storage account name? Now, this name that you put here, and I'm just going to call it Fun Storage 1, has to be globally unique, which means in all of Azure, this name can never be used, all right? So it has to be globally unique. I give it a region. I have the ability to choose premium. If you choose premium, it does one really big thing important to your replication. It creates what is called locally redundant storage. I'll talk more about that in a second because there's a big story here, folks, that you're going to need to know how to do not only for this exam, but every exam moving forward. You have to understand what we do under the covers for replication. If I choose standard, I can have my general account time. Now, folks, you very rarely will ever change this choice. Just ignore it. This isn't the storage you're looking for, right? Standard V2, if I click on the down arrow for this, I have the general purpose or blob storage. Depending on what region you're in, we have file storage where you have dedicated storage. But remember, the storage account is provisioned to store any type of data that you want to store inside of Azure. So I'm just going to choose V2. And then we get into access tier, just real quick, and then I'm going to talk over our application. We have hot storage. We assume with Azure, anything you put inside of Azure, you're going to want to use it, and that's hot storage, so you pay a little bit for that. You have cool storage, which you can immediately access, but we recommend anything 30 days or older. If it's never changed in 30 days, move it into cool storage. It costs a little less. It's immediately accessible, but there's latency in the terms of seconds to be able to access that file inside of Azure. Now, let's talk about the replication, because locally redundant storage is the default. You might be surprised to know that everything you store in Azure, there's actually 3 copies that are stored automatically for you. One you only pay for, the other 2 are for us, for our fault tolerance. They're behind glass, break in case of emergency, then we'll access one of those 2 files that are available to you. But there's choices here. If I click on the drop down, notice I have a couple choices that are in preview. I'll talk about those as well. What we have is called zone redundant storage. Now, if your brain just went, hey, what? Matt talked about this thing called availability zones. That meant multiple data centers inside of a region. You're in the right headspace. What happens now with zone redundant storage, we get 3 copies of data, but they're put in the different zones inside that region. So now we have a higher availability for our storage. If we go geo-redundant storage, or GRS, we have a total of 6 copies of data. 3 in the region A, and Garrett, any guesses where those other 3 copies are?
In the peer region.
Exactly right, in the pair region that we have 6 copies of data. Now, when you do geo-redundant storage, you will double your storage cost because you'll pay for 1 copy in region A and another copy in region, whatever it's region pair, region B, you'll pay for that. But you also pay for the initial replication, which does create egress traffic charges. I mentioned that to you because if you're replicating for the first time, if you choose GRS, you could have petabytes of data and your bill will reflect that. It may not, it's not really generally a large amount of data, but just be prepared, you do get charged for egress traffic charges. The cool thing about that is that once that initial replication is done, we only replicate the deltas between the data. So we don't do full replication, just what has ever changed. So we'll generally see with customers like, hey, why is my egress traffic charge really high this month? Because you did that initial replication, and after that, it should drop back down with just regular usage. But GRS, 6 copies of data, 3 in the region A, 3 in its region pair. Then we have a variation of GRS, and it's called read access, or RAGRS. What this is, still the same 6 copy days in region A and region B, but that other copy of data up there is read accessible. So in other words, people that are in that region or close to that region can use that data. Types of things of why you might do this, you may have log files up there, maybe you have some analytics and databases, you just want people to see it. Can't change it because you can only change it in the region we created, but read access allows us to do that kind of change. When you look at a cost structure, LRS is the least expensive, followed by the most expensive, which would be RAGRS, and the different calculators will show you that, and we'll talk about the calculator in Module 4. Now the other 2 here are in preview technology. Matter of fact, these previews, from what I've seen and experienced, you can only use them when you're creating the storage account. If you want to try the preview after the fact, you have to recreate the storage account, but the names tell you everything you need to know. Geo Zone Redundant Storage. When you do GRS, we just put it in the different regions. Well, if you do GeoZone, guess what? It puts it in the different regions and the different zones. Our read access Zone Redundant, RAGZRS, 6 copies of data, once again, different zones, but those zones can be read accessible. And so when we create the storage account, we have the ability to do that. So I can click on Next Networking, which allows me to control how I access the storage. Do I want all networks to generally? That's generally what you're going to do. All networks are going to want to come into it, but you can create private endpoints. Really not going to go into that, but we can control. If we know only a certain virtual network or a certain set of systems are going to access this storage account, you can lock it down inside of Azure. Advanced just controls some of the advanced options. Do I want secure transfer? In other words, we store all of our data safe and secure at rest. All the data is encrypted on our data centers. It's all there at rest automatically for you as a customer. But what if you want to make sure you have secure transfer? Is the data moving in transit? You can enable this here, and that will require access. We have soft delete for our blobs, which allow us to control kind of a recycle bin at the blob level. So if I delete a file, I can bring it back very quickly. And then we have some specific things for Azure Files. If you have a large amount of file shares or data lake storage, if you have some things, you might need some of those options. And we also have previews for NFS to access storage as well. Here's our tags for our governance. Next, review and create. Should pass validation. I'm going to go ahead and create the VM. And notice that as that's creating, we have that wonderful download template that was there for us to use. Now this storage account, what can be inside of here? pretty much everything. And I'm just going to give you a quick tour once the storage account is created so you can see all the different things that are available to you and why that name had to be globally unique for you to use and leverage.
Hey Matt,
inside of Azure.
question from one of the attendees. So you mentioned that there was additional charges when we're replicating data if we're selecting geo-redundant storage versus local redundant storage. But are there other times where there's additional charges other than just storing the data, or is it just during that replication?
Well, so yeah, so that replication causes egress traffic charges. And it's a great question. So whoever asked an awesome question. What happens is that we always charge for egress traffic. Replication is one of those egress traffic charges. Well, what if there's a public-facing website and I have my customers pulling data out of my customer website? Just create egress traffic charges. Or if you export your virtual machines out of Azure directly, you have egress traffic. So we charge not only for the storage of the data, but also the transactionally. Now, with that said, I don't want to alarm anybody because the prices normally are fairly minimal and nominal with this, but we do have transactional charges. We have storage cost charges that are going to be there. The type of storage that you have, premium versus standard, matters. That affects storage. So it's not just about how much data you store. And by the way, we only charge you for what you're storing in the cloud. We don't charge any more inside of it, but there could be additional charges. Normally, the transaction charges surprise people the first time they see their bill, and sometimes in the tune of pennies, and if it's the first time they've replicated a petabyte of data, sometimes in the tunes of thousands. So not always a pleasant conversation, but I want to make sure you're aware of those charges. It looks like our storage account has been created, so I'm going to go ahead and hop over to that resource. And in that resource, notice that I have the ability, here's my containers for my blob storage, there's my file shares, there's my tables, and there's my queues. All that information is available to me, and you have inside the wizard all kinds of abilities to work with this. And if I go into the blob service, I can go on containers and create a container. I'll do that in a second. But why did that name have to be globally unique? Let me show you something here. If I go into properties and I scroll down, notice it has my primary blob service endpoint. So endpoints are how we access data inside of Azure programmatically. So if I want to come into a system, how do I work with it? Well, if you look at the endpoints here, and if you look very closely, notice it says Fund Storage 1. Guess what that is? That is my storage account name. Why did the name have to be unique? Because we're using it as an endpoint with a public URL. More importantly, it's followed by blob.core.windows.net. Blob service, it uses fundstorage.1. What's the file service? File.core.windows.net. What's the queue service? Queue.core.windows.net. What's the table service? Table.core.windows.net. That's why that name has to be globally unique, so that when we're accessing it programmatically, we have a name that's unique to that. So let me go into containers real quick, and let me just upload and create a blob. So I go into containers. Let me go ahead and add in the container here. We'll call it Hong Kong, just for giggles. Access level, by default, we have private, which means people can't come in and take a look at that. You have the ability to make it read-only, or you can make it container access, means they can see everything, read and write in that data. I'll leave it private for now, and I'm going to go ahead and click OK. And all this is a container, and all containers are ways that we can control our blob files inside of Azure. The cool thing about this is that once we create this container, now it's just a matter of uploading a blob. What is a blob? It's simply a file. So I'm going to go ahead and hop in to the blob file, and let me upload a file here, very quick to do, and I'm just going to select a file. Let me go into my pictures directory here. Let me go into Hong Kong. And I'm uploading a picture, and I'll show you what this looks like here in a moment. I'm uploading a picture of a panographic image of Microsoft's Hong Kong office, where we actually have a view of the bay. It's actually pretty stellar. I was blessed enough to go there with my good friend Steven, and we got to work with it. So it uploaded the file for me. Let me go ahead and close that little wizard down and open the file here, and I can take a look at that file available for me to use and leverage. Let me see if I can bring this file up. Go ahead and edit it. And notice that this file now is uploaded and in that store. So I see a panographic image of the Hong Kong office patio. It's actually really nice to hang out with. It was really hard to work there, Garrett, because I had to go out and look at the scenery every now and again. But this is how we can upload and work with those files. Now notice I sent private access. Have you ever had to share something with somebody? If I would have said container access or public access, this file would have been immediately publicly accessible. On all I would have had to have done is on my over tab is give somebody that URL, and it's not, so I just want to show you what it looks like. So I'm just going to open up a separate tab here. all I would have to do is give somebody that URL and they would have been able to access that file. It's a publicly accessible. Now I have my access locked down so people can't look at it, but that's how easy it is to create storage and use and leverage it. And all blobs are just those binary unstructured files that we're going to store in Azure. So let me hop back in and let me cover off a lot of the other things that you're going to see inside of Azure and a lot of the other solutions. Now, I'm going to warn everybody here, I'm going to go a little fast because there's a lot of stuff here, but I'm going to give you the overview of things that we're going to need to do and know how to use and leverage inside of Azure. So inside of here, let me go ahead and bring up my slides again, and let's talk about some of the other things that we can store inside of Azure. Specifically, we have Azure Database Services. We have the ability inside of Azure to store lots of databases. We have a Cosmos database server, a globally distributed. It's a NoSQL database. It's table type storage. Cosmos database, when they say globally distributed, it means it can run anywhere. Most of the modern video games that we run in the world today, if you have kids, my son Mitchell, he loves video games, plays Fortnite and Destiny 2. Almost a majority of those video games run some kind of a Cosmos database or Postgres database in the back end for matchmaking, for profile information stored. We also have traditional SQL database. We have Azure SQL. Now, this one's really cool. Azure SQL Database is a PaaS service. Wait a second, Matt. SQL is a server. It is. Inside of Azure, and this is one of the unique things, one of the offerings that would differentiate us from other cloud providers. In other cloud providers, if you want to run SQL, you have to spin up a virtual machine and then run SQL on top of it. We can do that in Azure too. We can spin up a VM and run SQL on top of it. But we also have inside of Azure, Azure SQL Database, which now we don't have to worry about that server. We can just write natively to a database in the cloud. We also have a migration tool that allow you to move data from on-prem, other cloud providers, directly into our database services. We have a database migration service to help move that data into our cloud. Now, folks, I will tell you, moving data, pretty easy to do, but understand that most likely that data is associated with some kind of application. Depending on how that application is using data, once you move it into Azure, you might just have to change the endpoint reference of that application to go talk to that database that's now in a new location. So those changes could be minimal, although those changes could be rather robust as well. We also have a marketplace inside of Azure. There's over 10,000 listings of different partners of ours, of Microsoft, that have made software to do and solve problems. Remember, we talked about platform as a service where we can build solutions, but you might want to go buy a solution. What if I want to buy something? I can use the marketplace to buy those solutions. And just FYI, all those images that we create for virtual machines all come out of the marketplace. So that Windows Server image, because I'm buying a brand new license, comes out of the marketplace. What other Azure solutions we have? We have IoT, Internet of Things. There's a great little case study out there. If you want to use Bing and go search for it, do a search on Azure and rhinoceroses. Now, I know what you're thinking. Wait a second, that's not the first word association you come out. You don't think about Azure and rhinoceroses when you do that. There's actually a really good case study that uses Internet of Things and with machine learning, which we'll talk about in a moment. There's an ecological park in southern Africa that they're trying to prevent poaching and organized crime that are killing off the rhinoceros population. They actually have a bunch of devices that are strung up in trees that are motion-activated cameras that take pictures. It takes those pictures and uploads them into Azure, and then Azure takes machine learning and analyzes them. Is that a poacher, or is that a picture of a giraffe or wind loading? It's a really neat case study, but Internet of Things is used to leverage that. And we have two services. We have IoT Central, and I like to call this kind of the basic service where people are just trying to do proof of concepts. It's a general IoT service that allows you to connect and monitor and manage IoT assets. It's generally a management kind of tool, but when you want to really work with the devices, like in the case of the camera traps, you can use IoT Hub, and this allows you to have bi-directional communication with those devices to upload inside of Azure, to work with, to use and leverage inside of Azure. And so it's a managed service, it's a communication hub, so we can get those pictures from the camera, clean those cameras off if we need to, some really cool things inside of Azure. We also have the ability to handle big data inside of Azure. It was formerly known as Azure Data Warehouse. It's now going to be known as Azure Synapse Analytics, but we have Data Warehouse, which is all about parallel processing large amounts of data. Folks, when you get to large amounts of data inside of Azure, what do you do and how do you manage and maintain it? And really, any large amounts of data, you have to treat it differently. You know, imagine if you have a giant warehouse that has rows and rows and rows and rows of products. And let's say you're the person responsible for making sure those orders get filled. Well, what you can do, well, there's two ways you can approach the problem. If it's by yourself, you're going to run up and down each row until you find the product to put in the package to send out. But that's not how you want to do it. It's not very efficient. And that's what most modern relational databases are. That's essentially what you're doing, just asking the question, running up and down the rows. But when you want to do massive parallel, when you have large amounts of data, really large warehouses, you're going to have a lot of people that are going to running up and down the different rows to find those products that they need to ship out. And that's essentially what a data warehouse is, or in our case, Synapse Analytics. We have HD Insight, once again, reaching into that data and pulling out information about what's going on, finding out what's happening inside that data, looking for seasonality, looking for patterns. We also have data lake analytics. When you think about a data lake, it's very similar to what a lake would look like. So you have a large lake near you, it's information at a massive level on how do I go in and look at that data? How do I actually analyze it? So if I had, like, for example, Lake Erie, and I wanted to find all the fish that were in Lake Erie, how would I ask it a question? Well, I'd use data lake analytics to ask it a question to find out what's inside there and analyze that population. We also have Azure Artificial Intelligence. Now, folks, believe it or not, you use this, you may not even know it. If you're using any of the translating programs in the world today, especially if you use Bing Translator or the Teams Translator or Skype's Translator, you're using artificial intelligence and you're using machine learning behind the covers, learning how to use speak and how you use language. If you use PowerPoint, you actually have Azure Machine Learning with design ideas. And if anybody's ever used PowerPoint recently, you throw pictures on the slide, like Garrett and I, those pictures look really good of our families. We didn't actually make that organized. We just said design, make it happen automatically for us. It was using machine learning services under the covers for us. Now we have two versions of machine learning service. So Garrett, I got to ask you a question. I want to throw you under the bus. Are you a data scientist?
I am absolutely not a data scientist, Matt.
Nor am I, and most likely you're not either. Now, there are two ways we can use this. We have the Azure Machine Learning Service. Those are for our data scientists. For people who really need to get into the math behind this, they can develop, track, train, make their own modules, make their own models to work with it. And then there's the other one, Machine Learning Studio. Notice the bottom line here, Garrett. No need to write code, all right? That's us. It's a really great way to build and test these solutions. I would imagine, although I don't know for certain, with the rhinoceroses, they probably mocked something up in machine learning studio just to see if it could work, and then they did the real work inside the machine learning service that we have. For your exams, know the differences between the two, that we have no code in the studio, learning services for our data scientists and the mathematical engineers that we have. A couple other things. We have serverless computing inside of Azure. Serverless computing, we have three areas we can focus in. That's Azure Functions. How do I describe functions? A function is normally an event that's triggered by something, and it's one event comes in and one event comes out. It'll create infrastructure under the covers for us automatically. Normally they're HTTP triggered events. They don't have to be, but essentially, hey, I create something and spin up a website. One point comes in, one point comes out for us to do and leverage it. We also have logic apps. Logic apps are another way that we can start in Azure. Now a point comes in, but I need to make a decision on that. I actually need to make a decision. Is that a picture of a poacher? Is that a picture of a rhinoceros? Or is that a picture of a wind moving? When you need to make decisions on data that comes in, you're going to use a logic app to go through that workflow, that actual structure to, hey, I need to do this, that, and the other. Then we also have Event Grid, where we have a single point come in and we want multiple things. It's just a routing service. Now think about this. Think about the poacher example for a moment. They get a picture of a poacher. What has to happen? We most likely, well, that function will come in. The picture came in there. That function might have cleaned up that picture, maybe cropped it, maybe sent it along, but then sends it off to a logic app that says, or sends it off to machine learning service. The machine learning service analyzes and says, hey, look, that's a picture of a poacher. Sends it to a logic app. The logic app looks on that, makes a decision, hey, this is a poacher. Then it sends it to Event Grid. And Event Grid says, okay, that's a picture of the poacher. First event, I'm going to send it off to be stored and safe and secured so I can have capture that information. Second event, I'm going to send it down to the people that are trying to go catch the poachers to get in a helicopter to go find the poacher and save the rhinoceros, possibly catch the poacher. The point about these, and it calls serverless computing because under the covers, there's machines that are running all of this information. They work in conjunction depending on what you want to do. I know in the rhinoceros scenario, they do a lot of functions to go through that routing, go through that process of making sure they try to catch a poacher. Some really cool stuff that's there. We also have DevOps services built into Azure. DevOps services used to be the old Visual Studio Team services, and what that is, it's the ability to collaborate and work with code. When you have a group of developers working together, it's not too dissimilar than people when they work together on a Word document for a common proposal or something along the lines. The difference is the type of material that they're working with. With developers, they're working with common code. And so we have to treat that a little differently. So when we want that collaboration with developers, we're going to use the DevOps services to give that, where we can use the Kanban boards, Git repositories, where we can do some load testing. We have some pipeline capabilities here. We can really get a good look at how those developers work together. We're going to use DevOps services. We also have DevTest Labs, another service for developers. And what DevTest Labs allows us to do is actually go in and give developers basically a proof of concept creation environment where they can actually go create and work with things at a lower cost. Now they're locked down. That comes with the caveat, guess what? We have to use those resources in a local fashion. We have to use them in a controlled fashion, not in a production environment. We also have the Azure App Service. This is probably the biggest thing from a development standpoint inside of Azure. Where do developers live in Azure? They live in the app services. And well, what kind of apps do I make? Well, it depends on what they're trying to do, but our web apps are there, our mobile apps, any other service that we're going to use, it's designed to run on our platforms. This is squarely in the platform as a service environment. As a matter of fact, a lot of our software as a service offerings in the marketplace, they started as an app service. A vendor simply came along, I want to make something that does things, and it's going to work inside the app service for its use. The last thing I want to talk about in this module is our management tools. So I led off with the portal and how to create things inside of Azure. That's just one of a few tools that we can use and leverage on how we get things done. And I'm going to give you a quick tour and we'll wrap up module 2 here in just a moment. So the Azure management tools, it starts with this structure. Remember the Azure Resource Manager, or ARM for short. And by the way, our templates are commonly known as ARM templates. Why? Because whenever you do anything, whenever you create something inside of Azure, it goes through the Resource Manager to get that work done under the covers and the subscriptions. So the first thing we have to do against ARM is we have to authenticate into ARM, prove who we are, and then we can do our job. And what are the tools we have? We have the portal. That's what I did to create the virtual machine, the storage accounts. That's what I went into to work with inside of it. We also have the ability to leverage what is called Azure PowerShell. This will run on your local laptops and your clients. It can be a Windows system, a Linux system, or a Mac system to run those environments. If it has Mac, you have to have the .NET Core, but it allows us on our local systems to tell Azure to go do stuff, manage stuff, create things, work with it. We also have other tools. We have the Azure CLI, or the command line interface. This runs on top of a Windows, Linux, or Mac system, on Bash, or on top of PowerShell. It's another way we can work with Azure to manage and maintain that. We also have what is called the Cloud Shell. The Cloud Shell is in the portal. As a matter of fact, I brought it up. I didn't show it to you. It was there for us to use. In other words, I don't have to have the stuff loaded locally on my laptop. I can open Azure and get to the Cloud Shell. And I can open that up and run commands, whether they're PowerShell or Bash, or I can use the CLI. We also have an application. So if you go to your app stores, you can download the Azure app for another mobile experience to work with it. Now, folks, the reason I show you this, regardless of what tool you're going to be able to get into, and I don't, if you have a Mac laptop, a Linux laptop, or a Windows laptop, well, guess what? You can use any management tool. Any of them are open to games. What if you have an Android tablet? Well, you can't load tools on it, so you can't use Azure PowerShell locally, but you do have access to the portal, which means you do have access to the Cloud Shell. So pretty much everything we have, we can access the Cloud Shell. Or what if you have a phone? There's an app. Now that app is generally a monitoring app, but guess what the app also has? Cloud Shell. Why do I tell you that? Because in the Cloud Shell, guess what? It's a browser environment with an editor that you can actually store and have a central repository for your scripts. Now let me show you the Cloud Shell real quick, and then we'll hop out of Module 2. So I'm going to hop into my portal here real quick, and I'm going to hop in my home area. Now inside of here, how do I get to my Cloud Shell? It's up here, this cute little icon. I know it's the PowerShell icon, and some people it's a square with, I don't know, a greater than sign and an underscore. I don't know. I always think like it's a duck sticking out its tongue. However you want to look. I don't know. There's lots of things you can use here for it. It's this icon. Just know this is the Cloud Shell. I'm going to bring the Cloud Shell up, and it's going to bring up my Cloud Shell. It brings a Bash up, which was my last one I went inside of it. Now, I don't know anything about Bash. I know it stands for Born Again Shell, which is a Linux environment. But what I do know is inside of here how to bring up what is called the Azure command line interface, where I can interact with Azure. And I'm just going to type in the letters AZ in my shell and hit enter, and it actually will bring up all the different commands. Now, I always chuckle at Get This Gary. I think this is a long lost art form, the bit art, like being able to type letters that are there. But notice I have CLI, and it gives me the information of what I can do. Now, how do I learn more about this? So I just want to give you a little bit of information here. So I'm going to learn more about this command called group. Group is how we manage resource groups with the CLI. And I'm just going to put azgroup // and it's going to actually bring up that information for me. It gives me the help. Well, I need to know more about this. Well, I can hit the up arrow. I have command remembrance like we do with most command line tools that we have. But I'm going to put in AZ group and I'm going to type in the word create. That's one of the commands. I want to create a group with the command line interface. Inside of here, hit enter, and it shows me an example, the different variables I can put inside of it. Folks, the point I want to make is that when you're going to use CLI, every command begins with the letters AZ. And depending on what you want to work in, can you find out more help? -- help at the end, or -- help at the end, you can work with it. Now, if you're wondering, hey Matt, which tool do I want to use when I get into the Azure environments? Really, I recommend learning CLI. And for your exams, you're going to want to know CLI, but you also want to learn Azure PowerShell. So to do that, let me switch over to my PowerShell environment. Now, folks, not bragging, I've done a lot of work with PowerShell. I have a couple books on PowerShell, a Linda course, and things like that. But I don't tell you that for that because I actually like CLI a little bit better, and you're going to see why. Now, PowerShell we still need because CLI is not quite fully full feature yet. But let me go ahead and just clear my screen out and let me type in. Every CLI command begins with what letters? AZ. So I'm just going to type in AZ, hit enter. And notice I get the same bit art, I get the same command structure. So folks, the reason I like CLI, I don't care if you have PowerShell or Bash, you can interact with Azure at the same command syntax. Same exact command I typed in Bash is the same exact command I type in PowerShell. It's one of the huge advantages of learning the Bash or learning the CLI environment. Now, last thing I want to show you here real quick is if you want to learn about Azure inside of here, if you want to learn more about Azure, first off, what can you do? In any Azure, in any PowerShell, I should say, you want to learn more about PowerShell here, type in git command, and there'll be a test on this. Everybody got that? Okay, those are all the PowerShell commands that I can run, Azure PowerShell commands that I can use inside of it. Now, unlike CLI, where I put the help at the end, if you want to learn more about PowerShell, a certain command, you can type in git help. And I know one of the commands that I could use to resize or work with a VM is called update azvm. These are all called commandlets, git help. Commandlets are in kind of that verb-noun relationship. Get, set, start, restart, delete, followed by a noun, whatever you're trying to do, whatever object you're trying to manipulate. And so if I just say git help, update azvm, it actually has built-in help for me to use and leverage. I can even have some switches like, hey, I want to have an example so I know what this looks like. Just type in examples, and it gives me that command line interface. Folks, I want you to understand that the tools are there. For this particular exam, know the differences and just a little bit about the tools. In real life, learn how to automate it. Garrett talked about the importance of leveraging the different types of technologies for repeatability. Templates are one way. Learning how to create scripts and modify and work with these scripts becomes another way that we can be consistent and repeatable with Azure. So from that standpoint, folks, you really want to learn how to use these languages. Now, if you're kind of like a free agent, you never really used any in the past, I'd recommend learning two. Learn the CLI. Learn how to use the CLI, how to find help, and then learn how to use PowerShell. If you only want to learn this because you're never ever going to real life because you're going to take the exam, learn PowerShell and learn CLI. You're going to see both of these examples in pretty much every exam you take from here on until forever with Microsoft. That's where we focus in that. Now, I mentioned with the exams past AZ900, you might have labs that'll give you tasks. We don't care how you get the task done. If you want to use the GUI, use the GUI. If you want to use Azure PowerShell, if you want to use CLI, you use whatever tool you're comfortable with. So in our exams, we don't really care which tool as long as you know how to do the task. So with that, that brings us to the end of Module 2, where we talked about a lot of the core services. Once again, an inch deep but a mile wide. We started with the physical architectural availability zones and availability sets. We focused on virtual machines, networking, and storage. And then we spent a time talking about all the other types of solutions that we can run in Azure. from perimeter to network to what happens on the actual compute, what about the application, to the data itself, which is where their ultimate goal is. They're trying to get inside there. So we have to think about this in a layered approach to security. And when you start working inside of Azure, the great thing about this, just like we do with compute with shared responsibility, we also have shared security responsibility. And we think about on-prem, you're responsible for all of this. But now when you start looking at the different workloads from IaaS, PaaS, and SaaS, now you get some help. Now you get some security under the covers to help strengthen your security story to make sure that it's very difficult for the bad folks to get in and take your information or become a part of it. And really, it all starts with the story of the physical security. And when you look at our data centers, they're hard to get into. And if you get a chance to go and give a tour, you definitely want to go tour these facilities. Not everybody gets to do this. And by the way, we're one of the few vendors that let you come in and tour our data centers, but it's all done in a very secure fashion. Bear in mind that everything we put in our data centers is safe and secure and locked behind doors, folks, and that's where you're trusting us as a customer of Azure looking at those layered approaches. But when we start talking about security after the physical security, what's the area where you have to protect the most? And that's identity and access. And we're going to talk about those core identity services we have in Azure right now. And really it starts with the concepts of authentication versus authorization. You have to understand the differences between the two. Authentication is simply proving who you are. That's logging in with your user ID and password. It's establishing your identity. If you go to a professional sporting event, this is your ticket. Your ticket lets you get past the guard at the gate so you can get into the stadium. That's part of that, what that ticket does. The ticket does the other part, which is authorization. What seat can I sit at? Where can I buy my food? Am I in the club level? Do I get to go down close to the sidelines, or am I stuck in the nosebleed seats? When you think about this, you have authentication always happens first. You prove who you are, followed by authorization. Inside of Azure, we authenticate with Azure Active Directory, and our authorization of what we can do inside the actual subscriptions is done with what is called role-based access control, both of which we're going to cover inside this module. So understand, authorization happens after authentication, proving who you are, and then what can you do with that information. And really it all starts with Azure Active Directory, our identity solution. Now, why do we spend time on this, and why do we talk about authentication, authorization, and Azure Active Directory? Because this is how we authenticate. Your user IDs and where they're stored is important. And folks, if you don't believe me, a little bit of homework for you. There's an excellent book out there called The Cuckoo's Egg. It was written in the early 80s, and it talked about an identity solution. It was written by a gentleman named Cliff Stoll, and he found a hacker had compromised a mainframe computer, found a user ID and password, and was trying to use the Berkeley's network to break into ARPANET. The hacker was in Germany. So if you don't think identity matters here, especially in the security story, it's vitally important. And the great thing about Azure Active Directory, you have a centralized identity solution that really helps govern access to everything we do, from our authentication. We can have set up single sign-on. We have application and device management. And when you think about this, folks, just to be very open and honest, it's not necessarily what you might think from a group policy or an Intune or AirWatch or Mobile Iron perspective, but when we think about application and device management in Azure Active Directory, application management, for example, is what applications our users are allowed to do single sign-on. And because of the way that Azure Active Directory is designed, there's over 3,000 applications that know how to use Azure Active Directory for authentication into those applications. And device management, simply put, my laptop here, guess what? Can it get in to Azure? Well, I had to be given permission at the laptop. This device can be managed and used to leverage. But we also have business-to-business consumer tenants, so we can actually have our business-to-business trust, and we also have business-to-customer tenants and identity services built into Azure Active Directory. But the problem becomes is that we have this term Active Directory, and we have it in two places. We have Azure Active Directory, and then we have Active Directory on-prem, known as Active Directory Domain Services. And what's the difference? First off, they're very different. You can't think, well, hey, I have Active Directory on-prem, I know what Azure is. No, they're different to the point of how we talk to them. With Active Directory on-prem, we use LDAP, we use Kerberos for authentication. There's no federation services built in. We have a concept of organizational units and how we organize our users and groups. In Azure, it's not a one-to-one comparison, but when you look at resource groups, they're kind of replacing the need of what we do with organizational units. But in Active Directory on-prem, we had a fantastic management solution called Group Policy, where we could really control users' desktops. We don't have that in Azure Active Directory. If you want to do group policy-like things, you can use Intune, which is our cloud-based solution for full device and application management inside of Azure. But what makes Azure Active Directory special? It's cloud-based. It speaks common protocols. We access it via HTTP or HTTPS. We use common APIs, so not only the applications that are in the cloud today can leverage it, but applications your developers write can leverage Azure Active Directory for authentication purposes. But we also use SAML, WS Federation, and OpenID for authentication, and OAuth for authorization. These are common industry protocols. Why is this important? Well, it leads us into our federation services. Azure Active Directory can speak to many, many applications in the world today. Some of the most common: Salesforce, Box, Dropbox, G Suite, Amazon Web Services. Now I know what you're thinking. You're thinking, Matt, wait a second. Azure Active Directory can speak to Amazon Web Services? You betcha. As a matter of fact, you can use Azure Active Directory as your authentication mechanism if you have a dual cloud strategy, which a lot of our customers do. You can have one central managed identity with Azure Active Directory, and users can log in with that user ID and password and be allowed to use Amazon Web Services. We can have true single sign-on across all of these services. But at the end of the day, that's all Azure Active Directory is. It's a flat structure, users and groups, and that's all. It's extremely powerful, but all the other things are done by the other components inside of Azure. So when we look at Azure Active Directory, it is radically different than Active Directory on-prem. But when you look at the cloud world that we're in today, guess what, folks? It's perfect for what we're doing inside the world that we have today. More importantly, one of the things that Azure Active Directory comes with, folks, is multi-factor authentication. Not just Microsoft, but many of the security vendors in the world today have simply made one statement, and it might have shocked all of you. Your user ID and password is no longer enough. Why? It just takes time to crack any password. It just takes effort. So now what do? How do we set this up? Remember, authentication is proving who you are. All multi-factor authentication is proving who you are in multiple ways. And it's around three big tenets. Something you know, that's your user ID and password. Something you possess. This might be your phone, it might be an application on the phone, or it might be a text message. How many of you have forgotten a password of one of your common SaaS applications today? And you can't remember, and all of a sudden you get a text message with a little verification code that you put in the forgot password screen, and you get your password reset. We do this today. And then something you are. That's your biometrics, it's your face. Windows Hello is an example that does all three. Because on our laptops, we have Hello enabled, so I can just basically log in the morning with my face, and it logs me to the system. But to set that up, I had to first know my user ID and password. I had to set it up on this laptop, and then I can use my face to log on. So when we think about it, it's fantastic. However, folks, it does have a dark side. One thing about multi-factor authentication you have to realize, you're going to forget your actual password. And you're going to have problems with this. And when you have to reset, I don't know what it is. Fun story, I was blessed enough to go to Hong Kong a while back, a few months back, and I got to go deliver some training. And I had to print some things out on the printer at the Microsoft office. And I go to the printer, I'm all ready to print, have my badge, and it says, before you can print, you need to verify your identity. Can you log in with your user ID and password? I didn't know what my user ID and password was, so I had to go reset my password to log onto the printer so I could use my badge to print out the stuff for my course that I happen to be delivering. So understand, when you get into multi-factor authentication, you will most likely change your lose your passwords and may have to change it. But because you're using multi-factor authentication, a lot of organizations are lengthening their password histories. It doesn't matter anymore because we're not using that. We're using different mechanisms that verify your identity. And I thought it was something like 95% of password brute force attacks are thwarted because of multi-factor authentication. You have it in Azure Active Directory. It's available to you. And folks, if you're not turning it on, I'm just pleading. Turn it on inside your environment. It's going to help prevent those identity crises that you may have if somebody compromises your information. So our identity services, core, Azure Active Directory is what we do inside of here. So that's our first layer. What's our next layer? Network. How do we start securing the network? And everybody's familiar with this, right? How do we start talking about it? In Azure, we have network solutions. We have to look at layers. We have the perimeter layer. Wait, you all had this. We had this today. You have firewalls. You have really big firewalls that sit out there. And if I had to guess, let me think, okay? You have port 443 open and maybe port 80. That's all you have open. But you have to start protecting it because you got to open up ports. That's how you do business. We got to let people in to get to our website so they can order our products and services. That's our perimeter. Now, how do we prevent things from happening inside there? So if I have 443 opened up, how do I protect it? Well, I throw a firewall there, and commonly known as a layer 7 firewall or a stateful firewall, or in our case, is a web application firewall. It's just on the very edge, and what it does, it scans the information. Just like it is when I go to the airport. What's the first thing that happened? I have to go to TSA, have my ticket, have my ID, I can get in. Everybody can go there. If they have a ticket, they're allowed to walk into that environment. Now what happens? If you've traveled lately in an airport, what happens after you get past the security person? You throw all your bags on a scanner, they get scanned, and you yourself walk through some kind of scanner. It's exactly what a firewall does, folks. That's all it does. It's just at the very edge. Yeah, you can come in port 80 and 443, but now we're going to verify who you are. Then we also have a special protection, distributed denial of service protection. And every customer gets this in Azure, and there's a basic feature that everybody gets. It's free. And we also have a standard feature which does a little more proactive remediation if things like happen. And all this is, a distributed denial of service attack, is a hacker just floods your internet with so much traffic. Guess what? Real traffic can't come in. Azure's been protecting it since really the beginning of Azure, preventing from these styles of attacks. We have the networking layer. Now we're past the perimeter. What about inside our networks? If you think about your world that you live in today in your data centers, how many of you actually were very secure on the inside? Or you just hope the firewall would keep all the bad people at bay? Well, a lot of the really good social engineer hackers in the world today, they know how to walk around your firewall. In other words, they leveraged a really friendly receptionist and were able to walk by your perimeter layer. Now they just have to put a port scanner inside any one of your open jacks, and they're in the network layer. But can they do things? Well, inside of Azure, we use a concept, and I'm telling you what, folks, it is a huge concept. They're called NSGs, or Network Security Groups. They're a filterer. They're not a firewall. They don't inspect traffic. They're and some people would call it a stateless firewall, but just a filterer. It filters inbound and outbound traffic. It's very easy to set up. And basically, a network security group is, who are you and where are you trying to go? Either I'm going to let you go there or I'm going to deny you. And that's it. But that's on the inside of the network, and it's fine-grained filterer. And I'm going to show this to you as we take a look at some of these technologies, but now it makes it easier to secure the inside of our networks, all right? And that's the networking layer we have. When we look at Azure Firewall, we already talked about it's inbound and traffic firewall, what ports can come in. And now we can come in and look at firewall, we can look at what happens inside those packets. And the Azure Application Gateway has this built in for your applications behind it. So there's a couple ways inside of Azure to do this. Now folks, this is the Azure Firewall. I want you to have a firewall on the perimeter of your environment. I don't really care which one you use. Use something. We have a lot of common vendors, Palo Alto, F5, just to name a few inside of our marketplace, folks. Use them. Have something on the perimeter of your network scanning that traffic. We have some great built-in services, but if you're familiar with some, just use one, all right? Then we have distributed denial of service. Everybody gets this basic service for free. I will tell you, for most customers, the basic free service is going to be perfect for you. If you add the standard service, it's transactional based and it can be kind of costly, but it adds mitigation. It helps protect all your other resources. And really, when we talk about cost and security breach, what's the cost if you get breached, right? What happens inside of your environments and how do you want to prevent that? Or what's the cost if your customers can't get to your website because it, for some reason, got by the basic service? I will tell you most customers are very, very happy with the basic service, but you might want to consider the standard service. Now, what about the inside? I've gotten past the perimeter. I'm valid traffic. I'm allowed port 83. Now, how do I move around inside of Azure? Firewall, DDoS, perimeter, external. Network security groups inside of Azure. So when you start working with your traffic, how do we dive in and use all this? We have some default rules we'll take a look at in a few minutes. As a matter of fact, we're going to talk about that because the great thing about network security groups is that we don't have to necessarily use all kinds of fancy things. We can use application security groups as a part of our NSG story. And I'm going to show you the network security groups and where ASGs come in. But the great thing about application security groups, they allow us to group computers by names. In other words, I don't have to know their IP address. I don't have to know anything else about them. I just have to put them in a name, a group name that allows me to organize it and control flow of traffic. And when we see the network security group here in just a minute, you're going to see how application security groups can actually govern all of that. So let's take a look. Let me show you what network security groups can do and how we can set it up. So I'm going to hop in fairly quickly because I want to show you the power behind these things. So I'm going to hop into my environment. I'm going to go to my network security groups. I'm going to hop into my AZ Fun network security group. And I'm just going to go right to the inbound rules and I'm going to go right to add. Now I hop in here very quickly because this is where the power of the network security group lies. It's a fairly straightforward filter, and notice the first two options here. First one says Source, any. Where are you coming from and what port are you coming from? Every network traffic has to have an origin port. But look at the any. It says any source, but look at the choices. I can choose an IP address range, so you have to know how to use site or addressing to control what subnets are going to be coming inside of that. I also have service tag. What's a service tag? Services. And notice the default one is internet. So this says if I have traffic that's come from outside of Azure, internet-based traffic in here, I can lump everybody into internet traffic. I don't have to worry about IP address ranges, I don't have to worry about any of that. But notice the service tags we have here because it's really, really big. We have virtual networks. This is virtual networks inside of Azure. So we have a rule specifically for our VNets inside of Azure. But as you scroll through this list, look at all the Azure services that are there, and they're all designed to help you filter traffic inside that list. And notice when I get down into storage, it's broken down into regions. So if I only know a certain region can come into this area, guess what? Lock it down. Why say any when they come inside of it? Lock down to those very specific resources that we have inside of Azure. It helps you control traffic because guess what? If I choose Storage Central India, which happened to be the one I landed on, guess what? If I don't come from Storage Central India, I don't get in. It's blocked, right? I have to be on that list. So let me go back, and we're going to have some fun with this. So I'm going to say any. I'm going to leave the port range at wide open, although generally speaking, if you know where the port's coming from that's supposed to get in here, lock it down again. Destination. Where are you trying to go? Who are you, and where are you trying to go? The destination, any, IP address range. Are you trying to go to a specific network? Because a network security group can sit in front of multiple virtual networks. Or I can do application security group. So I can have that group of computers. And they work like this. I maybe have all of my web servers grouped in a thing called web server. I'd say internet traffic can talk to web servers. And then under web servers, I might have my database servers, and that means web servers can talk to database servers. In other words, a hacker, if they're going to try to come in, they have to go through the web servers before they can get to the database servers. Everything else is just blocked. So for us, just to have fun, I'm going to say any. And what port do you want to go to? I'm going to say 3389 is my port. I can use any protocol here. I'm going to use TCP. And this one I'm going to deny. And I just want you to make note of the priority rule, which is currently 310 that we have inside of it. And the port, I'm just going to say RDP2. And I'm going to go ahead and click on Add. And I want you to take a look at what we have here once this rule is created so we can see it. It'll come up here in just a moment. And then we'll talk about how this works inside of Azure. So let me just refresh this so I see it. Now, Garrett, I'm going to ask you a question. Notice that I have two rules here. I have one over 3389, TCP any, allows, and one that denies. And best guess here, what do you think? Are we going to let traffic in, yes or no?
Yeah, I'm going to say we're definitely going to let traffic in because of priority of the rule.
Yeah, exactly right. Perfect. High five. Good answer. All right. Folks, understand this. Most of the times when you think about security, you think deny always wins. Not in the case of network security. What did I tell you it was? It was a simple filterer. And here's how it works. When a packet comes across the network security group, it says, who are you? Where are you trying to go? And it looks at the rule. And the minute it gets an answer to that question, it takes its action. So in this case, look at the priority rule. It's 300. The allow is before the deny. Now, if I were to simply do this experiment with it and flip these rules, and say instead of 310, I'm just going to make it just one little itty-bitty number ahead of it, make it 299 and save it. Now I flip the rules. Now denies before allow, and you're exactly right. That priority number matters inside of here. Now that priority is not going to let that traffic in because it hits the deny rule first. And so when you start working with network security groups, it's really important that you understand how these are set up so you can start controlling your network traffic inside. So how do you become hard and crunchy on the inside of your network? My friends, network security group is the answer. And this is just a quick example. You can have rules, priorities from rule priority 100 to priority 4096. So how many rules can you have? A whole bunch of rules inside of here to really govern traffic, to be very, very specific about how this traffic flows inside the environments. Now, one thing I want to show you, and it's a little bit extra, I don't know if it's on the exam, but quite frankly, this is about skilling and teaching you. When you start working with network security groups, my friends, oh crud, how do I get around? How do I work with this? We actually have an amazing tool inside of Azure called the Network Watcher. So let me show you this tool. And if I go into Network Watcher, it's a troubleshooting diagnostic tool. Now, it does a couple really cool things that I want to show you. One is effective security rules, and I'm not going to show you that because in my demo I don't really have a lot. I would just repeat what you've already seen. But when you start working with a lot of network security groups and you have a lot of flow of traffic between virtual networks, well, what is the rule? I have these rules here, I don't know what's going on. You can run the effective security rules and it's going to tell you what's going to happen. Now, let me show you 3 of my favorite things in this tool, and I just want to give you a quick overview. My first one is topology. Now, Garrett, I don't know about you. I've been asked to do network topology diagrams before. Isn't that a fun way to spend your day, isn't it?
It's the most fun.
Okay, so what I'm going to say, the sarcasm comes out, right?
Sorry.
The cool thing about this is that when you have these things, we can do it in Azure very quickly. Now, I'm not going to tell anybody what I'm about ready to show you. And folks, I'm not going to tell any of your bosses either, but watch what happens. So I'm going to say my Windows group, I'm just going to select my AZ Fun group. And notice what happens here in a second. It automatically diagrams my virtual networks that are in that group. And by the way, all those icons are live links. So now I've just diagrammed. You can download it, throw your PowerPoint. I'll tell your bosses, it took you all day to do that. Okay, so it's there, but it's easy to do. So we have that built into Azure. Learn how to use topology, see what's out there. Now we have 2 other tools. When we're on-prem and when we've been troubleshooting, what's the most common tool? We use ping. Hey, can I get there? I just want to send a simple packet and get a response. Inside of Azure, we have its equivalent. It's called IP Flow Verify. So when you start working with network security groups, you have to start to understand how you troubleshoot it. So IP Flow Verify is a way I can essentially do it a ping at the Azure level. So I don't have to worry about diving into the virtual machines, what's the password. Hey, can I get from point A to point B when I have VMs involved? And the other one we have is called Nextop. This is the equivalent of traceroute that we have inside of Azure as well. So folks, I don't know if this is on AZ900. I do know it's on every other exam after that. But from a standpoint, when you start working with network security groups, you have to know how to troubleshoot them. Network Watcher is one of those tools. And it does a whole lot else. I just show you some of my favorite things that are going to really help you get through that. So understand we have some great tools to secure a network, and we have some great tools to help you troubleshoot that flow. Can I get from point A to B? Did I effective rule? Did it deny me somewhere and I have to go look at it? And when you look at those network security groups, and this is where Garrett figured it out, when I looked at the network security group, if you notice the default rules, the very last rule that is created, and by the way, you can't get rid of the default rules, the very last rule is any, deny. So it basically says, if you come up to the network security group and it doesn't know who you are, it doesn't know where you're trying to go, it hits that last rule, deny. I don't know who you are, see the last rule. But I really want to get in, see the last rule. But please, see the last rule. You're not on the list, you don't get in. All right, and that's why we have those rules there and in place. And pretty much everything that you make in our network security group is an exception to that very last rule, which is deny. I'm just going to allow traffic to come in, or I'm going to deny and create some filters or some uniqueness that are here. I spent a little bit of time, folks. It is one of the biggest concepts we can do inside of Azure, is that's the network security groups. So let's go ahead and switch back in and talk about some of the other great security stuff. I could spend all day in network security groups, but we got some stuff to talk about. Let's talk about some of the other tools and features we have built into Azure. First off, we have Security Center. Congratulations, everybody's Security Center at a basic level that's going to help do some analysis. It's a monitoring service that really looks at not only your Azure resources, but your also on-prem resources, and it provides recommendations based on how you configure this. In other words, a lot of people say, well, how would Microsoft secure us? The Security Center is our answer to that. It helps monitor that environment across both our clouds, our on-prem to see what's going on, and it'll apply your policies as you're provisioning them. So Security Center really helps look at that, but it also does a lot of things around detecting, assessing the issue, diagnosing it, giving you some kind of stabilization recommendations or best practices, and then closing it. They're incident response tools, so how we can find out what's going on in our environment, we can use Security Center to do that. We also have a thing called Key Vault. Now, Garrett, be honest with you. Have you ever forgotten your user ID and password?
I've forgotten it many times. Yes, absolutely.
Sometimes we forget user ID and passwords. Now, have you ever forgotten your BitLocker key?
I don't typically remember my BitLocker key. Yes, that's correct.
Yeah, we don't know that, or it's stored in ours. It's stored in part of our Active Directory, although it's changed now. But folks, if you ever call Microsoft and, hey, I forgot my user ID and password, we generally will help you with that. We'll reset you. We can do a password reset for you. But if you call Microsoft and say, I forgot my encryption key, or I forgot my BitLocker key, or I put a little password on my Word document to password protect it, they're going to be sympathetic. They're going to say, I'm sorry, you don't know your key, but we can't help you because we don't know that. So when you get these important secrets, and you get these important things like maybe a shared administrative password, you have to have a place to centralize, store it, and work with it. And this is what we use inside the Key Vault that we can leverage inside of here. So let me show you how this works. Oh, and side note, the Key Vault is also used programmatically. When your developers write code, they're going to want to be able to leverage certificate management, maybe a public and private secret, maybe a key pair, something. They're going to want to leverage it. Developers traditionally don't like to put this in their code. It adds bulk to their code. It adds a lot of extra latency they may not need. The great thing about this, the Key Vault can be accessed via APIs. So now our developers don't have to know the keys and the certificates. They just call the Key Vault whatever endpoints we give it to be able to leverage that. But let me show you an example of how the Key Vault can be used. So Garrett, I have, inside of my environment, I have a virtual machine I have logged on, and I've used Microsoft Azure's backup tool, and I want to recover some information from here. So I'm just going to bring up my backup tool that we have. And if you've never used Azure Backup, it's actually a quite cool tool. It's out of the scope of this class, but it's really, really cool to use and leverage. Now, for those of you looking at the tool, hey, that looks like Windows Backup. Yeah, it is. The only difference is, guess what? It's backing up to Azure. So I want to recover some data. And the first question it's going to ask, where did you actually create the data from? Well, inside of here, I created the data from another server. So it's on another system. First thing it asks me, hey, what's your vault credentials? It's trying to verify my identity of who I am. So I'm going to go ahead and browse for this. I'm going to choose my vault credentials. And it tells me my recovery services vault, my subscriber ID, and all that information. Then it says which server in the vault, and these are all the different systems that I've backed up to this particular environment. It asks me my passphrase. I told you the passphrase before we started. You remember what I told you?
I definitely don't remember it.
You don't remember, right?
No, but didn't you put it in your Key Vault?
I did put it in my Key Vault.
There
I saw
you
how
go.
to do it. And understand, folks, when you do these types of things, if I don't have this passphrase, guess what I don't get to do? Recover my data. I don't get to bring back that information. So all I did when I created the backup, and this happens when you configure it, it asks you for this passphrase. I can't remember what it is. So what I can do is go into my subscription, go into my Key Vault, and inside my Key Vault, I'll find my one that I have, and I have a couple of keys, and this is called a simple secret. So secrets are great for that common administrative password, that just generic environment, and this particular one is just my this laptop here, and I'll drill into the actual key itself. So this is where the secret's stored. There's the endpoint that I have, and notice it has my secret value. I don't even have to know what it is. I can just simply copy this value, go back to my wizard, paste that in, and now I can begin. And the fact that I can get here tells me that it's going to work, and I'll be able to decrypt that data as I recover it. Now, I'm not going to do a full recovery operation, but that's how you might use Key Vault. Understand it's a place we can store those certificates, because unfortunately, anybody who's in the security industry, and a lot of our companies in the world today, have even turned down the government. Hey, do you have that key? Like, no, we don't have it. We don't know what it is. That's part of that shared responsibility. You have to know what those secrets are. The great thing about it, inside of Azure, you can leverage your Key Vaults for that. Now I know what you're thinking. Matt, wait a second. What if I forget my global administrative user ID and password for Azure, where my Key Vault key is, and I can't get to it? You can actually call Microsoft and get those global administrative passwords reset. Now, it's not as simple as like Garrett can't call your company and say, hey, I'm Garrett, I want to get your password. It doesn't work that way. There's a lot of vetting that goes on when a global administrative password has to be reset. But especially for some of our smaller and medium customers where they might hire a partner that does work on their behalf, this does happen from time to time. Microsoft have facilities to make sure that they reset that password for the valid people, not the invalid folks that are there. So some really good things that'll happen inside of it. So let me go ahead and hop back in, and let's finish some of the stories. So I just want to show you Key Vault, and let's talk about some of the other tools that we can use inside of Azure. The first one is Azure Information Protection. It protects your information. I know that seems kind of redundant of the school of redundancy, but we've all done this. We have information. How many of you on your, and Gary, I think you've done this before, you select a little toolbar and it says confidential. And what did it do when you set it confidential?
So it sets permissions on the message so that only certain people who are receiving the message are able to actually open it.
Yeah, and that's done automatically in coverage. You set it manually, but a lot of rules happen. That's Azure Information Protection. We're Microsoft. We are using information protection, but we also can do it automatically. Let's say Garrett sends an email that has maybe a credit card number into it. We can actually automatically classify that as super confidential, whatever it happens to be, or give Garrett a note, say, hey, look, you're putting a credit card information. Are you sure you want to do that? We can give them tips, and that's all information protection does. It helps label and protect our documents. We can do it manually, or we can have it applied automatically. Then we also have advanced threat protection. Now, look at this. Solution for identifying and investigating threats, compromised identities, and malicious insider actions. When I got to go to Hong Kong, threat protection kicked in. It basically said, wait a second, Matt, you're usually somewhere in the United States. What are you doing in Hong Kong? And it was flagged. And what happened is when I logged onto the hotel's network, I was forced to use multi-factor authentication. So we had conditional access tied with, oh, something's not right here. The cool thing about this is that we can put sensors, not only inside of, we use sensors inside of Azure, but we can put these on our on-prem domain controllers to monitor what's going on, to see what's going on inside the environment, to look at those types of things. And I like this one, it says malicious insider actions. So what is that? Basically, all of a sudden, I come in, I'm downloading a terabyte of data from the secure server. Well, I never ever done that. Alerts are gonna happen. People are gonna get notified, wait, Matt's doing something he doesn't normally do. And we also have with threat protection, we have another variation of this called identity protection. It looks at the same things that are unique to me. So for example, one of the things that identity protection does is Matt just logged on at 8 o'clock in LA and 1 minute later logged in New York. Well, that's not possible. So we have that type of information stored inside of Azure. More importantly, behind both threat protection and identity protection is Azure Machine Learning Services. Looking at how you're doing, it's looking at patterns, it's collecting data, so we know how you're doing these things. And when you think about how your users are, every user has a pattern on how they work with the systems. And we can get ahead of those potential threats if somebody gets compromised. Well, why is Matt trying to break into the secure server? He doesn't have access. He's never done it before. People are gonna get notified, so you can help keep your environment safe and secure. Whew, lots of stuff in this module so far. And now we're getting to the big topic. You think, wait, Matt, you've talked about identity, you've talked about network security group, all these other things. Now let's talk about governance. For those of you that have children or people that you don't ask to do tasks or coworkers, or if you manage people, how many times have you ever asked somebody, and Garrett, how many times have you asked, I know you have kids because we have 5, my 3, how many times did you ask your kids to do something? They did to the letter of law what you asked, but they didn't do it the way you would have done it.
I would say that happens on a regular basis.
They did it, and you can't get mad at them because
they got it done.
Yeah, they found a loophole somewhere in what you said to do. They said, hey, empty the trash on a day that ends in Y, and they waited and they found a day that ends in Y and did all these things. Well, inside of Azure, how do we control how folks do things inside of our environments? It's all around governance, and we have several things we're going to talk about inside of here. We're going to start with a conversation with policy. We're going to talk about role-based access control. We're going to talk about locks and everything in between. But now we start talking about, if I give you access, if I authorize you to use Azure, are you going to create the virtual machines that I want you to create? We've gone through as IT and verified who they are, and we know which regions we want to use. How do I make sure you use the regions? Like, hey, you can only use Central, but you can't use South Africa.
Yeah, we're going to have to create some Azure policies.
Yeah, exactly right. We're going to have to create some Azure policies that are up here. And those are examples of policies. And all policies are our way as IT to govern how you create things. Examples, virtual machine. You got to create a virtual machine of this family. You got to put it in this region. You have to put it in a tag. You have to have a public IP, you can't have a public IP address. You have to use the hybrid benefit for licensing. All these policies are designed to help us control how people create things inside of Azure. It's how we govern this. It's how we make sure they adhere to compliances that we may have inside the organization. Policies are extremely important because we control how users create stuff inside of Azure. Now, when you think about the policies, the examples I just laid out, region, VM, no IP, user licensing, very singular. And that's how you want to set them up, because the tool inside of Azure for policy is going to flag, hey, this is not in compliance. Well, if you have a bunch of policies in a single policy file, you're going to have to figure out why they're not in compliance. So you keep them fairly siloed. But when you start working with Azure, how do you implement those policies? Well, after you create the definition file, you apply it, you assign it a scope, and you evaluate it to see what's going on. And policies have two effects. They can be audit policies, just a report, or they can have deny policies, which prevent users. So if Garrett were to try to create a policy in South Africa and I'm preventing that region, he'll be denied. The resource will not be created, and it'll tell him why. You can't do those things. But when we start working with policies, when you start thinking about just virtual machine creation, and we talked about this in module 2, and then we went through that wizard and all those settings. Well, what if I was configuring all those, 30, 40 settings that I can do? I wouldn't want to apply each one of those individually. What you'll do is create a thing called an initiative. And all an initiative is a collection of policies. So the way this works, you create all your policies, so all those individual settings, and they might be related, like I want to have a VM creation definition or an initiative. You put them all in that initiative, and then you apply that initiative to the scope you want to apply it. Remember our hierarchy from module 2? We have management groups, subscriptions, and resource groups. That's where we can assign our initiatives to. And it makes it very easy for us to control how users can create. So folks, you may be running this today. If you're using Azure in your organization and you can't create something in a certain region, or you can't create a certain VM, very well, your IT department may have already implemented policies in your Azure. It's an okay thing because they're trying to govern how you control things. They might be for compliance. The best thing about this, though, is if you can't do something that you need to do, you can go ask IT. Because IT wants you to use Azure. We want you to leverage it. They want you to see inside of it. And you can say, hey, look, I need this VM, and then you can open up a dialogue of why that's important. And as long as it adheres to your compliances, chances are they're going to give you a policy that lets you do those things. So policies and initiatives inside of Azure.
Hey, Matt, we just had a question come in. This person is saying that they don't want the people in their development team to stand up a really high-powered VM with a lot of cores. Is this something that Azure Policy can help us with?
Oh, absolutely it can. That's where we can control those environments. Now, one of the reasons why, if I'm thinking about that policy, for example, why they can't set up high-powered, they're probably worried about cost. Because when you get into those really high-powered machines, we're talking $1,000 an hour type of machines, lots of cores, lots of memory, earn $2,000 a month, that kind of stuff that's there. So they're worried about costs, so we're going to prevent that. Now in Module 4, we're going to talk about what if we do need a bunch of those high-powered machines? How can we eliminate some of the costs to alleviate that? But generally speaking, whenever I want to control what people can or cannot do inside of Azure, guess what? I'm going to use policies to control that. And it's kind of like I would call our dad rule. You and I are dads, right? Hey, you got to do it, but now you got to do it the way I say you have to do it, right? And do it in the way that I want to. And that's what policies and initiatives do for us inside of Azure. That's what governance is inside of it. So policies are how we can create it, but can I even create it? Am I allowed to use Azure, right? I have to do it in a certain way with policy. Am I allowed to use it? And this is role-based access control. So role-based access control is how we do these things, folks, and it's fine-grained management. Now, we apply it at the subscription level, the resource group level, or the individual resource level, and they allow us to govern our authorization. So understand, we authenticated against Azure Active Directory, proved we're allowed to be here. Now, what am I authorized to do? That's all done by role-based access control. It's how we grant permissions inside the organization, and generally how it works, you have your users, they're going to be in groups, and we assign those groups roles inside of Azure, and those roles under the covers have rights and permissions to do something. Depending on what role it is going to determine what you can actually do. Role-based access control, or RBAC for short. And so when we take a look at this, it's really straightforward. So I'm going to show you two examples in this demo. I'm going to show you how it looks from an end user perspective, in other words, somebody that has RBAC being applied to them, and then how do we change it. So let me hop into my systems here. So I'm logged in as admin 2 in this particular tenant, and this tenant has a subscription assigned to it. This is the same tenant that I've been using in all of my demonstrations that I have, and I have lots of resource groups. As a matter of fact, we created a resource group for our VMs. If I go to resource groups, logged in as admin 2, notice I only see the one resource group, RBAC test. What you're seeing here is role-based access control in action. Admin 2 only has permission in this one specific resource group. Even though I know there are more resource groups in this subscription, admin 2 hasn't been given permission yet. Even if admin 2 knows how to get around it by going to create a resource, choose the VM, and say, I know there's more, even in the drop-down list, they only show the one resource group that are there. So that's what it looks like from a perspective of a user that has RBAC applied to them. Now, how do I change it? So let me switch over to my other browser, and I can actually show you how this works. So in my other environment, I'm going to go in and I'm going to go to the resource groups. And notice I see all the resource groups. Now, in case you didn't believe I was in the same subscription, you see the RBAC test group that I'm here. But I have this AZ Fund group. So I want to give admin 2 permissions to use AZ Fund. And this is how it works, right? Traditionally speaking, when your organization sets up an Azure subscription for consumption of Azure resources, the very next thing they're going to do is control who can create what and where they can create it. And generally, they'll do it at a resource group. So if Garrett says, hey, I want to use some Azure, great, Garrett, I'm going to give you a resource group, and I'm going to give you ownership of that resource group. You can do whatever you want inside that resource group, but I'm not going to let you govern up unless that's part of his role. Let me show you how this is set up. So I'm going to go into my resource group, and in my resource group, there's an option up here that's at the top. It says access control, and it says IAM at the end. I like IAM. It stands for Identity Access Management. When I think about role-based access control, it says, I am so-and-so. Do you know who I am? Let me in, right? The kind of those types of things that we have. So I'm going to choose access control. And inside of here, I'm going to go role assignments. Now I see some legacy, and I have some things I've been doing a lot in this environment. But I have this RAID 78 account. Now this is a special account. This is my global administrator. It's the ID that I use for this particular environment. And they have this role assigned to them called User Access Administrator. All that role allows RAID 78 to do, and they're a global administrator, so they actually have a lot of other hidden rights and other things. Basically, the global admin can do whatever they want, wherever they want inside the subscription. But User Access Administrator has a very specific right. See this list of users that I have? This user can change that list, and that's it. User Access Administration, controlling the access of the users that we have inside the environment. So let me go ahead and add in a role assignment. So I'm going to say add a role assignment. It's going to say, what role do you have? If I click on this down arrow, folks, look at this. Now, aside from the top 3, owner, contributor, and reader, they're all in alphabetical order. And if you scroll through this list, like I get down to, here's one that says backup reader, backup operator. This is very specific. It's giving me access to the backup service to be able to read, I think in this case, the backup policies, just to be able to look at that information. Well, if I don't have anything backup related in this resource group, guess what this user can do? Effectively nothing. Even though they have the rights, it's for that particular service. The reason I point out these other roles is because sometimes when we think about role-based access control, we get siloed in thinking of just users and groups. But in reality, remember, we have Azure services running around Azure trying to access and use things. And we can really, once again, just like with network security groups, lock down the different types of roles that we want to use and leverage inside of Azure. But the 3 big roles at the top, and you see owner, you see reader, you see contributor, you see all that stuff that's here. So it really starts with these 3 roles at the top: owner, contributor, and reader. The owner of the resource can do anything inside. In this specific case, it'll be anything inside of the AZ Fund resource group. That's my scope. They can do whatever they want. They can control the resources. They can even modify the access control list here on the screen. They can even control locks. They have full ownership over that. Then we have contributor. Contributor can do anything inside the resource group. They can add any resources, delete resources. They can do whatever they want as long as they have permissions on those resources inside that group. Do whatever they want. However, the contributor cannot change this list of access. Only the owner or the User Access Administrator can change the access list that we have here. And then we have reader. Pretty obvious what that one is. Reader is, they just look at the resources. That's all they can see what's going on inside of it. So I'm going to make my user owner. Now notice it says assign users using groups. Remember I told you that there might be other resources. We actually have system managed identities. We have different Azure services. We have the ability to really control how our users and our resources leverage the different resources in the resource groups or wherever we scope them to be. I'm going to leave on my user. I'm just going to go ahead and put an admin 2, which will give me my user, and I'm going to go ahead and save that. And it'll take a second here, but now I have given admin 2 ownership of that resource group, which means now admin 2, as I try to stall Garrett here and make sure and lengthen this out so it'll hopefully take place, because it doesn't always take place right away, but admin 2 will be given rights and roles to that user, that resource group. So if everything goes right, when I hop over there, I might have to do a quick refresh. AZ Fund resource group should just show up for that user to use and leverage. So the great thing about this is that role-based access control, when you set it up, it takes place immediately. You generally don't have to log off and log back in to make it work. And I may have to, just as a refresh on the screens that are here. Notice as I'm keeping to stalling here, I'm trying to make sure this works. So let me go ahead and switch over to my second browsing window here, and let me see if by chance AZ Fun has shown up. So I'm going to go ahead and switch over to that now. And let me go into my in private group. All right, which I was in the Create Virtual Machine. So let's go to Resource Groups now. And look, it worked. My stall tactics work. There we go. A demo is live. Logged in as admin 2. You see role-based access control. Now I have full ownership of that group. And that's how role-based access control works at a very high level. Remember, you take a user or group, you assign it a role, you find a scope. Remember, subscription, resource group, or resource. And then you assign it a role. And under the covers, that role has rights and permissions. You can make your own roles if you want to. You can customize all of this. You have to do a little bit of work to make it happen, but it's actually pretty straightforward once you start working with those roles. So RBAC is a great way we control the authorization. So we authenticate against Active Directory. We use policy to say this is how you have to create things, and then we use RBAC to say, can you create things? This is how it all starts to work together in a governance story. So let's go ahead and switch back. We got some even more security stuff to talk about. We got one of my favorite topics coming up right now, and that's resource locks. Oh, I love me some resource locks because we talked about in Module 2, what happens when you delete a resource group? What happens to all the resources?
They're deleted. They're gone forever.
They're deleted. They're gone forever. We don't back them up, so hope you have a backup. But we can put in place a free thing. By the way, resource locks don't cost you anything. There's no latency involved with them, but they do simple things. And we have 2 types of locks. I didn't name these locks. We have a read lock, we have a delete lock. We have a new lock coming into our subscriptions as well as an update lock, but I'm going to focus on the 2 delete and read locks that we have inside of there. And let me take a look, and to show you this, I just want to hop in because it's the best way to see how this works. Now remember, I'm logged in as my global administrator, so let me hop into my subscription as my global administrator. And let me go into my resource groups. And typically what we do at the end of our classes that we teach, we're going to reach into this resource group and delete it. Now I'm the global administrator. RAID 78 is the global administrator. Folks, you just have to trust me, it's a global administrator. And I'm going to delete the resource group. So I'm going to go up here and say delete the resource group. And I'm a global administrator, so I don't actually type anything. I just copy and paste things. I hear the laughter coming from afar. And I'm going to go ahead and paste that in. By the way, if you delete resource groups via script, you can put a no wait and a force script so you don't get this extra confirmation. Be very careful with that, right? The confirmations are there to help protect us from, well, quite frankly, us. So I'm going to go ahead and try to delete this resource group. And notice it failed because it has been locked. Now, does this mean I can't delete this resource group? No, it simply means I can't delete this resource group while the lock is in place. As the owner of that resource or the global administrator, I can remove the lock and then I can reach in and delete the group. But you have to remove the lock first. It's something you have to explicitly add and something you have to explicitly remove inside the environments. Now, where did I set this up? I set this up inside my locks. So if I go to locks, you'll see the lock for that resource group. There's the can't delete, which is a delete lock. But I also have this one for read only. But notice the scope. I put it on FunVM2 is where I put the scope, but it's read only. Now, the read-only lock is another special type of lock we have, and it's actually very specific. It's actually even more restrictive. It does everything the delete lock does, but it also marks the resources as read-only. And this is where I want to be very clear. It marks them read-only from an Azure perspective. In other words, I put this on a VM that's currently running. And let me show you what this does. So let me hop into that VM, and this has a read-only lock inside of it, and I'm just going to try to stop it. It's currently running. So I'm just going to go ahead and stop that VM. It's going to say, are you sure? Yep. And it's not going to let me stop it. Why? I'm changing its Azure property. So anything inside of here is read-only. Means I can't start or stop that VM. But what it doesn't mean, I can't change things inside the VM. That doesn't mean that. So it means what I can do? I can't do anything inside of Azure. I can't resize it. I can't stop it. I can't start it. I can't change anything about the properties of this VM. But I can still reach into the VM and change properties inside of it. So I can modify configuration files, add documents, I can work with things. And so when you use the read-only locks, be very careful with them. They're very restrictive because they deny changing of properties. Now, when you think about this, why might I use a read-only lock in conjunction of an environment? I use a VM just to show you a quick example, but chances are in your resource group, and by the way, when you apply a lock at a resource group, it automatically applies to all the resources below it. Well, why would I put a read-only lock? Well, maybe you have a public IP address there, or you have a configuration that you don't want to change. Mark those as read-only. Let people look at them, but don't let anybody change it because that could impact your entire application. So these locks are greatly important. Understand how they work, especially for your exam. And you're going to see these once again pretty much on every exam from here on out, even on the architecture exams. Resource locks are incredibly important to help protect our resources. Now, folks, when we start thinking about this, when we start thinking about how this works, why I can't do something inside of Azure, we talked about security from a layered approach. You also have to think about troubleshooting from a layered approach. If I can't change a resource, what could it be? Now, your brain's heavy on locks right now because we just got done talking about it. Well, if you can't change a resource, oh, I have a read-only lock. Well, that's not the only way. Is there RBAC control? Do I have permission to change it? Have I been authorized to change it? Oh, yeah, maybe. And then the other one is, do you have network access to that resource you're trying to change? Is there an NSG? So you have to start thinking about security in a layered approach, not only how you approach it, but also how you troubleshoot it. It's the age-old adage, check the least common denominator, find what's going on. How many of you are, and I don't know if you ever did this, Garrett, I know I did it. How many ever messed with somebody's system and you wiggled the RJ45 cable just outside of the network? So it wasn't making that connection. They drove them nuts because they can figure out what's going on. Or you did it to somebody's mouse. You wiggled out the USB just so it looked like it was going there. They can't move their mouse or
take
change
the
a
ball
battery.
out of the bottom.
Take the ball out of the bottom, exactly right. Understand their layered approaches here. So when we start approaching the security and all the stuff that we're giving you, that once again, just kind of giving you an inch deep and a mile wide, the security stuff, start to understand we have to start thinking about troubleshooting and how do we move around. That's why I show you Network Watcher. That's why I show you where to find all this stuff in the portal. So let me switch back. Got a few more things to cover off in this module inside of Azure. Blueprints. Blueprints are actually pretty cool as well. So when you start thinking about all the stuff that we can create inside of Azure, we have role-based access we have role-based access control, we have policies, we have templates. When I give somebody a subscription, how do I give them something that's kind of pre-canned, like the Betty Crocker Easy Bake Oven? Here you go, boom, there's your cookies, right? How can I do that? Blueprints are my way I can do that. It allows me to combine templates, policies, my DevOps stuff, and put it into one basic big giant blueprint, and I can give you a subscription with already resources deployed, and that's what blueprints do at a real high level. But we also have subscription governance. So how do we control the different things? We can control billing and chargeback. That's going to be done with most likely tags. We have access control at the deployment level. When we look at subscriptions, though, we can use subscriptions as a government level. So I can say, okay, here's subscription for my development environment, here's subscription for my production environment. There are access boundaries. We can also set different limits on different subscriptions so we can control how people work with those. More importantly, even at Microsoft, we have limits inside of what you can initially use inside of a subscription. Now, don't worry, even though you might run into those limits occasionally, you can make a simple request to Microsoft and get those limits increased. Hey, I need more virtual networks, or I need more resources, virtual machines. We oftentimes will grant those requests if they're within reason. And by the way, when I say within reason, you say, hey, I need 1,000 more, that's within reason that we have. And in my entire career, I've only seen, working with Azure past the 6 or 7 years, I've only seen a denial once. And it wasn't technically a hard denial, it was a very soft denial. It was like, look, and it basically amounted to, when you read the email, we can't give it to you just yet. The data center's in renovation, we're doing some remodeling basically. They were adding resources to the data centers. Like, look, we can't do it now. If you need it now, you're gonna have to use another region. But guess what? In a couple months we can do this. So it wasn't a hard no, and we normally will let those resource limits be there. Now, how do you know if all this stuff is working? Monitoring and report. We talked about tags. That's how we can control or organize our resources. They're basically a key name value pair. Hey, this is called the region tag, and you have to have the value West region, and that's how we work with it. Or this is your department tag, and it's the whatever finance department. The main reason we use tags is for billing, because we want to be able to make sure how to charge back to the different departments and organization. Understand, when you get a bill from Microsoft, essentially it's just a really big spreadsheet with line item after line item after line item, all the resources you're creating, but there's also a column that's specified for tags. And the great thing about those tags, guess what? we now can organize that and secure it, and we can actually understand it. We also might use tags for a project. Like I have a tag for what's your project name, Project X. Now I can understand how much does that project cost me. I can just do a simple query on tags. It also makes it very easy to find all the resources that might have that tag associated with it. So tags are an organizational unit as much as they are a billing purpose as well. We have Azure Monitor. Folks, this is a 2-hour module in and of itself in one of our courses on monitoring. And what monitoring allows us to do is look at data, and we can collect not only the metrics of things, this is running at 85%, but we can also collect the logs of things. Why is it running at 85%? So the monitoring is really a platform that includes our log analytics. It helps us collect data. And the minute you start working with this, the monitor's in place. It's already starting to find that telemetry. It's already starting to work. The minute you start putting things inside of Azure, you have the monitoring. We can look at the different applications. We even have the ability with monitoring, folks. We have a thing called Azure Application Insights, which is a part of our monitoring platform that can reach into code and say, you know what? That line of code is why your application's slow. Here's what we're seeing from that. It can tell you those specifics. It can help you respond to alerts. What happens here? Think about this. I have a monitor. I'm looking at stuff. I've set a condition. Say if I reach over this certain resource parameter, so a condition and a resource, I'm monitoring all that. I can create a thing called an action group inside of Azure. And what the action group does allows me to do things. Now, what kind of things are in the action group? Oh, you can send emails, you can send text, you can run Azure Functions, Azure App Services, you can do scripts. Pretty much when I have an alert that is triggered by our monitoring, we can pretty much do whatever we want to help maintain or remediate or fix or do whatever we need to. So I talked about in Module 2, when you want to scale up a resource like a virtual machine, you want to add more hardware to it because it's at capacity or need more CPU, or you're measuring the monitoring. That's a manual process. It's actually really easy to do inside of Azure. Say, you know what? That system's at CPU is 85%. We need to get another bigger VM, and what we'll do inside of Azure is reach in, alert triggers the monitor. We have an action group that runs a script that increases the size of that VM automatically. So you can automate a lot of this stuff. Or we can monitor, hey, the VM's off at 6 a.m. on Monday, turn it on. That's part of the things that we can work with inside of a monitoring environment. So we can monitor our health. Now, how do you know when you're looking at things, if Azure's running slow or pokey or something is not right, how do you know if it's what you're doing inside of Azure versus is Microsoft having a problem, something's wrong inside of Azure? So we use Monitor to see what's going on inside your subscription, but we use Azure Service Health. It's our way of Microsoft to communicate with you, you know what, there might be an issue inside of your subscription. There might be an issue in all of Azure that might impact all the regions. It might impact a region you have stuff in, but we actually do this with what's called Service Health, and allows us to look at those different dynamics inside of Azure. We can look at all the health of our services, and you can filter on it just for the regions you have stuff. It's our way at Microsoft to say, hey, something happened. And when there are service health issues inside of Azure, we'll not only tell you the status of the issue, is it currently being actively worked, has it been resolved, has it been remediated, we'll also share with you, as long as we don't violate any compliances in this process, the root cause analysis. So one of the things that we had happened, we had a 19-hour outage, by the way, a really bad outage a little while back in one of our South Central data center. And when you led the root cause analysis, it pretty much led with, the facility is hit by multiple lightning strikes. And everybody thinks I'm disclosing some kind of Microsoft secret. No, it was in the public root cause analysis document that every Azure customers can look at. And even folks, even if you're not a customer, you have to go and figure that out in the news wires that are out there. But we publish this stuff. We want to be open and transparent with you about how we actually use our Azure environments inside of here. So Service Health. We also have Azure Advisor. Now, Azure Advisor is free. It's a free tool that runs across your environments and say, hey, based on what I see, you may want to do something. This is Microsoft, what I like to call Microsoft's best recommendations tool. In other words, customers ask us all the time, how would Microsoft do this? Advisor is a free tool that will help you do all this. It's going to identify things inside of Azure. It's saying, hey, you can do this a little bit better, you can do this a little bit better, you can improve the resources here. Azure Advisor is going to help you do things according to what Microsoft considers best practices. My advice to you when you look at Advisor, take a look at the advice it gives you, but take that advice with a grain of salt. Make sure that whatever actions it is asking you to do, it doesn't violate any internal compliances. And so you actually can work with that information. And it's a down the middle tool. I have had customers say, hey, this is Microsoft's upsell tool. It's always trying to get me to do other things and best practices. And we are going to say, hey, look, you have a single VM. Have you thought about having an availability set, which means you have to spin up another VM, which means it's going to cost you more money, but we're going to give you that recommendation. It's up to you whether you want to take it. But the tool will also go the other way. Say, you know what, that VM you're running is only at 25% utilization. Have you considered using a smaller VM that costs you less and will help you save money? So Advisor is a free tool to allow us to do those types of things very easily inside of Azure. The last topic, privacy, compliance, and data protection standards. So we have a lot of stuff here, but really everything centers around, and say it with me, Garrett, Trust Center.
Trust Center.
Trust Center.
Trust Center.
All right, Trust Center. So whenever a customer asks us, hey, what Microsoft compliances do you have? What's your privacy statement? What are your standards around data protection? How does Microsoft as a business? We want to be your trusted IT provider. We want to have you trust in our cloud. Whenever you have this, you can just simply pull up Bing and do Azure Trust Center, and it's a website, and I'm going to show it to you here in a moment, where all this information is stored. It's all our compliancy terms and requirements. We share with you. You can even download the audit reports for most of these compliancies to find out how our cloud is verified. And by the way, we don't verify these ourselves. These are all third-party organizations that come in and vet us. Just like you have to get vetted when you have compliancy, we have to adhere to the same standards you do inside of it. And we have HIPAA compliance. We have GDPRs built into our DNA. It's been that way as well. And if you ever get a chance, if you go to any one of our conferences, our customer conferences that we have, if you get a chance and if compliancy and trust is important to you, all I have to say is if you see Brad Smith speaking anywhere, and he's our chief legal officer, I just call him the head legal dude, but he's our big lawyer in the sky at Microsoft. His number one concern, open and transparent communication to his customers. And folks, if you want to hear somebody that's a really good speaker talking about this at a level of our company, go see Brad Smith.
Yeah, and even if you don't get an opportunity to actually go out and see Brad at a conference or whatnot, Brad has a blog, and he is very actively posting on his blog about all the different things that Microsoft is doing to really protect your data. Because when Microsoft thinks about data, the data is yours. You're entrusting us to store the data for you, but that's not our data. That belongs to you, and we will go to bat for you to help protect that data. And Brad loves to post about that, so I highly recommend checking out his blog.
Yeah, he's an amazing resource that we have. He lives and breathes this every day. Our privacy statement's up there. We have our Trust Center. You know what? Let me hop out and let me show you what the Trust Center is, where you can find it. And literally, folks, it's as easy as just doing a quick search on the internet and saying, let's go Azure Trust Center, and this is what it's going to look like when you come to the site. And we change this frequently, so depending on when you actually do the search, it may have a different splash screen or what's on, but you can see the investments that we're making in R&D. We have cybersecurity experts employed by our company. We even have, I talk about them in the dream job now. I think my other favorite dream job, we have a red and blue team inside of Microsoft. We actually have internal Microsoft employees that every day they wake up trying to defeat each other. They try to break in, and we have defenders. I mean, we have this type of stuff. We think about this. And we talk about Brad Smith, another one, and he's the father of Azure, Mark Rusinovich. If you ever get a chance to hear him talk, especially if you're looking where our future of our cloud is going, once again, hugely entertaining, hugely smart dude that we have inside of here. But we also have compliance offerings. Now, I like this one because I get asked this all the time. What does Microsoft have around compliance? So if I say learn about compliance offerings, we can actually come in and take a look at all the compliances we offer as an organization. We lead the industry in this. Now, when I say that, I always smile because generally once we get a compliancy, people will follow along because cloud technologies have to be treated differently, but everything we do is vetted here. It's all approved and verified for us to see. The cool thing about this is that we can look at all these compliance standards. We can see what's inside of there. The other word of note here is if a new compliancy comes out, Microsoft may or may not have that compliancy on our roadmap, but it takes time to get these compliances. It might take months. If a new compliancy comes out, don't expect Microsoft or really any cloud provider, oh, the new compliance came out yesterday, we're going to have it tomorrow. No, that's not how it works inside of here. Let's go ahead and take a look at one, the International Traffic in Arms Regulation, or ITAR. And if I look at it, it gives you an overview of what the compliancy is, talks about how Microsoft's looking at it, and it tells you what in-scope services we have. This is very, very important. Just because we say Azure has ITAR does not mean all of Azure has ITAR. And specifically in this one, it says Azure Government. That means only the customers in our Azure Government environment can use this. It's only, and by the way, it's really the only ones it applies to. But if I open this up, it's going to come up with a document saying, hey, an overview of Microsoft compliancy. and it has a document for you to look at. I'm going to go ahead and just agree to that to download this. And I want to show you what this is, because when you start using Azure, if compliancy is important to you, you have to understand not only what compliance offerings we have, but you also have to know this document. We update this document frequently, but it'll tell you the different compliances that we have here. And as I scroll this, here's ITAR, so I just click on ITAR, and it tells me what it is and gives me what services scopes. And it says, see Azure Services and FedRAMP and DoD SRG audit scope. These are all a part of it. Now, where's all that information? Now, I'm going to scroll all the way down to the bottom of this document, dun, 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 go all the way bottom, and look at the table we have. So just because we say we have a compliance for Azure government doesn't mean all the services inside of Azure have that as well. Now, you'll notice there's a lot of checks, which means generally we do try to certify everything, but sometimes a service doesn't meet those standards or it's not going to be using those standards. Understand what compliance is important to you. You have to understand these compliance offerings and what we can do. So even before you start to design a solution, if you have a certain governmental compliance that you have to adhere to, do a quick research. Check this document to make sure the stuff you're going to use falls in compliance. Now, we also have another tool called the Compliance Manager. It's one of the few demos we can't do with our subscriptions that we have here, but it'll actually run across your Azure environment and tell you what compliances you're hearing. Hey, I'm looking for this compliance. Do I meet that? It's going to basically do that fact check, pull out this table and check all of that information for you. So we have ways to look at the compliance offerings inside of Azure. Now, the one thing I want to show you, because I mentioned it, let me hop back into my system and let me just show you Advisor real quick. I just want to show you what's there. So I'm just going to do a quick search on Advisor. I know it's a top result. And Advisor comes across and looks at recommendations. And notice I have a recommendation for high availability. I have a recommendation for operational excellence, and it's still checking for performance, security, and cost. We'll see if it comes up with anything here in a second. This is that free tool that's going to give me ideas. So I'm doing well in security, performance is all right, cost is all right. If I say, let's look at the recommendations for high availability, it's going to say, hey, look, you might want to enable a virtual machine backup. You might want to use availability sets. So it's telling me some information. And if I click on, let's use availability sets because we talked about it in this course, it's going to say, talk about move a machine. And by say it says move a machine to availability set. This is where I got excited the first time I saw this. It's an export and an import operation. It'll lead you through those steps. But if I go back to the Advisor and I go to operational excellence, notice it says create a service health alert. This is what it's saying, hey, look, we advertise this and you can look for our Azure Service Health if something happened, but this is saying, you know what, why don't you create an alert so if a service health issue impacts your Azure environment, from a Microsoft perspective, you get a notification on this. And let me show you what this looks like, because what I'm going to dig into here is actually the monitoring platform for just a second. It tells me here's what my target is and what I want to do, and I can simply create an action group. So we'll just call this creative name test, short name test, and what are the actions? And we'll say email. And what I can do is set the action type. I can set emails, I can do IT service management, I can run a logic app, I can also do automation runbook, which is our scripting environment. So if I go just email, it then says, what do you want to send an email to? What do you want to send an SMS to? You want push notifications? You want a voicemail? This is all that alerting environment does. So this is the tip of the iceberg for monitoring, but when you start thinking about, hey, we monitor for condition, and I want to be alerted here how it's going to go, and those actions, you can have an email and do an action group, an automation script, then run a web function. You can put whatever you want inside the action group. So I just wanted to show that to you briefly because we were out here in the portal. So let me dig back up and we'll close out Module 3 inside of our environments today. And what I want to close out with is just a couple special notes, and I've already mentioned it a few times. We have two things in Azure we have Azure, and the Azure that you've been seeing today is what I call Azure Commercial. It's what probably 90% of all of our customers use. It's most likely the customers you're going to use, what you're going to use inside of Azure. It's kind of our public environment of Azure. But we have a couple of special, what are called community clouds, very siloed focus. The first one we have is Azure Government Services. It's specifically designed for U.S. agencies and their contractors where they do things in a very special version of Azure. Matter of fact, physically they are separate regions, they're separate data centers, they're even treated differently. They're very different than our actual public Azure environment, or commercial environment, designed specifically for government compliance. And they adhere to all the government standards, especially when it comes to data center maintenance, logistic management. Compliances are abundant there at the government resources. I can't use the government cloud. You may not be able to use the government cloud. Why? You have to go through a vetting process. You have to be screened and authorized. But some of our customers that have both a public side of a business, like some of our airline companies and some of our manufacturers, they have a public side of the business, but they also have government contracts. Sometimes some of those organizations will span both. They'll be in the Azure Commercial for their commercial side of their business, and they'll be in Azure Government for their government side of the business. So we have the ability to support those clouds, but they are separate clouds. They can't cross information between. They're treated completely separate. We also have a special cloud in adherence with the Chinese government rules and regulations. It's called Azure China. To access this, you have to access it via 21 ViaNet. And the reason we chose 21 ViaNet is simply because we want to make sure that the cloud is operated by a provider that is in compliance. So we chose 21 ViaNet because they met all the Chinese government regulations to work with that. So on your exam, understand we have Azure Commercial, we have Azure Government, and we have Azure China accessed via 21 ViaNet. Wow, that was a whirlwind. We talked about all the things in security. We covered, network security groups, identity and access, locks, governance, identity protection, and then we ended up with compliance, and we just got done talking about China and government cloud services. So as you can see, folks, there's a lot of stuff around security, privacy, compliancy, and trust. And that brings us to the end of Module 3. Let's go ahead and get started with Azure Fundamentals Module 4, Pricing and Support. Now, you might be thinking, wait a second, Matt, I'm never ever going to buy Azure. It's already been bought and they already bought a support agreement. Why do I have to have this? Folks, I will be honest with you that a lot of things in this module you may not have to use, but I am going to show you some resources, the calculator, the free services, things that you might use in your day-to-day job. Especially if you build projects in Azure, you're going to have to know how to estimate it. So inside this section, we're going to talk about all those key things that govern cost, our subscriptions. We'll talk about service level agreements, especially when you use more than one Azure service. You have to understand how to create what is called a composite SLA, so you know what the support is that Microsoft's going to give you for that solution that uses multiple services. So let's take a look and hop right in and start with the first one, subscriptions. That's where you get your stuff done. It's how we provide billing and access boundaries for our customers and for folks like yourselves. We have an account can have multiple subscriptions. So generally what we see is most customers have one Azure Active Directory tenant and they have all the subscriptions for Azure underneath it. Now, one just special note about that, Azure subscriptions is one type of subscription we have. We have Office 365, we have Dynamics 365. They're all different subscriptions that can be tied to that one tenant. Oftentimes with most customers, we have one user ID tied to multiple subscriptions. We organize those subscriptions with a concept called management groups, and you go up to 6 levels of depth in management groups, but they allow us to control the flow of our policies and some of our security. So when we looked at Azure Policy in Module 3, we got to see how we can work with those different things, and we can inherit conditions. It's how we organize when we have multiple subscriptions, because most customers that we work with have lots of subscriptions. A lot of our enterprise customers have hundreds of subscriptions. Well, how do we manage it from a cost perspective, a policy perspective? We use management groups because it's one of the scopes that we can apply those policies at. When we look at our subscription offers, what types of things do we have? Well, we have a free subscription, believe it or not, and I'll show you how to access that in just a moment. But we have pay-as-you-go. I like to call this the full retail price. In other words, you got really bored one day. It was 2 a.m. in the morning. You pulled out your credit card and said, I want some Azure. It's full retail pricing. It's pay-as-you-go, and that's full price. But we also have an enterprise agreement. Some of my enterprise customers that may be listening right now, you probably have an EA for your organization. And what that is, you've signed up to commit to spend so much in Azure over a 3-year period of time. And based on that commitment level, you get a discount. So your prices are less inside of it. We have a student subscription. When you think about these different types of subscription offerings, they dictate price, but inside of an organization, you can have multiple ways that you acquire Azure for your organization. Now, most businesses will be in an enterprise agreement. Why? It's a great way that we can catalog, get a discount, and work with the environment. But we do have free services. You have the ability to test Azure for 12 months or a $200 credit that allows you to explore Azure. You can also look at these things for 12 months for popular service, 30 days for other services, and there's a bunch of other stuff that's free. Now, at the end of the trial, you will have the choice to upgrade as pay-as-you-go. Now, folks, when you look at Azure free accounts, when you sign up for the first time, it's going to ask you for a credit card information, and really that's to prove that you're a human, that you belong. It's not going to charge your card unless you explicitly say, I want to move from a trial to pay-as-you-go pricing, and then that's when your card will start being billed. Now, also a special note, the subscription that I use for a lot of the demonstrations and as I teach and learn is I use my Visual Studio subscription. So if you are a developer and you have a former MSDN and Visual Studio subscription, you actually have monthly benefits. So I have a Visual Studio Ultimate subscription. I get $150 every month to work inside of Azure. So there's lots of ways to get and use in Azure, but understand my subscription is all by itself. It cannot be combined with those subscriptions designed specifically for dev and test purposes. In my case, I happen to use it to teach. So what I want to do is I want to hop in the portal and show you where the free services are. So let me go ahead and switch into the portal. And in my portal, I'm just going to do a quick search for free services. And I type in free and just go ahead and open it up. And it tells me how to get the 12-month with free Azure account. It tells me what I get for 12 months for free. But as I scroll down, I want to point out something here that's really nice. Always free services. Folks, now I tell you that most of your businesses, you're not going to run in the always free services category, but I like to show this because you might work for nonprofits or small community environments where they need just a little bit of computing power or a little bit of horsepower. You might be able to do that for free inside of Azure. So research these, especially if you're involved in some of those committees outside of work. I'm telling you what, folks, it's a really good way to work in Azure. And if you don't, guess what? this is a good way to kind of kick the tires. See what's there. You have all kinds of technologies you can kind of explore and research and leverage inside of Azure. So you definitely want to take a look at those free services. Not a lot of folks know that they're there, but they've always been there. They've always been there for us to use and leverage. We have our free services. So let's go ahead and switch back. Just wanted to show that to you real quick. And inside of Azure, we took a look at our free services, but now let's talk about how to plan and manage costs. And I know I hear the yawns, but folks, you have to understand how you're billed. And first off, how is pricing and purchasing determined? Well, under the covers, we have this little concept called a usage meter. Now, if you're thinking like, hey, is that like my meter, my electric meter, or my water meter? Yeah, exactly it is. Whenever you start to work with Azure resources, the meter starts to spin. Well, how fast does it spin? What's my price? Well, it depends. It depends on what type of customer are you. Are you an enterprise customer and have an EA with the discounted rate, which means it changed how that usage meter spins? Or are you a cloud solution provider, a CSP? This is generally for our mid-sized to smaller organizations where they hire a partner come in to build those solutions in Azure on their behalf, and sometimes those partners will have discounts, so that can control the price. Then we also have the Web Direct or the pay-as-you-go. That's basically the full retail price of Azure. So it depends on how you acquire your subscription is going to control your price. But we also have other factors that come into play. What type of resource? Every resource inside of Azure has different price points. And also we have different types of services that are basic services, that are premium services, that are standard service. Those all dictate that. And then we also have the ever popular location, location, location. What region you put that stuff in matters as well. There's lots of factors that come into that pricing and purchasing. And when we look at Azure, you have to understand this. When you start standing resources up, how do we calculate that? So knowing where your stuff is, knowing how you acquired that is going to determine what your bill is going to be. Now we also have charges for zones, and we have different billing zones. Now really, the main reason we have these zones are for bandwidth purposes. We've talked about in some of the modules, modules 2 specifically, we talked about egress traffic charges. When we have charges that go outside, when we have outbound data transfer, it's all dictated by the different zones that we have, and these billing zones control that environment based on that pricing for outbound data transfers. And really, you'll see this in the calculator when you're working with these. And generally speaking, the zones are kind of a higher level abstract for billing, higher than the geographies that we have inside of Azure. How do you estimate costs? Remember, we talked one of the benefits of cloud, and one of the terms we did in Module 1, predictive cost. Well, how do I predict my cost? We actually have a pricing calculator that will allow you to come in and see what those price resources. I'm going to show this to you in just a moment so I can show you how it works and how the different pivots and switches and how we can control costs and see what's there. And I'm going to show you how to save a lot of money on a virtual machine without having to change what you actually get. So let's take a look at that calculator right now. So let me switch into the calculator. And in my pricing calculator, and let me clear out my calculator because I've done this a few times. We have the ability to come in here and do any of the services that we want. We have compute, we can look at networking, we can look at storage. Pretty much every service inside of Azure has the ability to have a calculator for it. So I'm just going to go up to the feature because I want to use virtual machines because they do such a good example what's here. Now folks, if you're going to build something in Azure, I'm willing to bet somebody's going to ask you, how much is this going to cost me? Well, you're going to have to know how to use the calculator. So here I am in the calculator. I'm just going to go into virtual machines, and it's going to add it to my calculator here. And notice that, and I'm going to kind of keep this, pay attention to this little number. Right now we're at $152.62 a month for this virtual machine, which is a D2 V3 virtual machine. It's currently running Windows. Now bear in mind, the cost of this virtual machine has not only what operating system you have, but also what type of virtual machine we have. So this is Windows. What if I want to run Linux, which doesn't have a licensing cost? Notice what happens to the price. Now it's down to $85. Same virtual machine, but now we don't have to pay that licensing. So when you work with these environments, when you have this, you're buying the license for that. Linux and Ubuntu and CentOS, they don't have licenses, but we have the ability to work with that. But also location matters. Notice I'm in West US. Well, let's go to the newer version of West. Let's go to West 2. And notice what happens. That price goes down to $137. Why? West 2 is a newer data center. It's more efficient. Remember, economies of scale, we pass those savings on to you as our customers, even in the US. I don't know. Garrett, pick a region for me.
Let's go East US.
East US. East US is 137. East 2, also 137. Let's go Japanese. Let's go to the Far East. 161 for that same VM. Let's go to India. 173. So different locations in different regions. So folks, as you're moving this environment around, understand that the location matters, the location of where we put the resources. And why might you choose one region or another? Well, global reach and latency are going to factor in. Put your regions close to the resources you're going to consume. But if you really don't care, pick the one that's going to save you some money inside of it. So I'll go back to West, so we're back to our 152. Now, remember, this is for the Windows system. What if I want to have some SQL with it? Now, understand what I'm getting ready to do, because you're going to see the number jump quite significantly, because we think you want to buy SQL Enterprise. When I choose SQL here, it's not that I'm going to run SQL on top of this. This means I'm buying a Windows server with a brand new Windows license and a brand new SQL license that I have. And this means I'm going to pay for not only the virtual machine, but also the SQL license. And in this case, it defaults to Enterprise. So I went from 152 to 1,200, a little over $1,200.
That's a pretty significant jump.
Well, I don't want to use Enterprise. Maybe I go down to Web. Price goes into it. What do you buy in a brand new license? Now, folks, a lot of your organizations have bought SQL under what is called putting SQL in the image that you pull from the marketplace. You'll build a Windows server, install SQL separately, and apply your license to that. And you won't have to pay that cost inside of here. So I'm going to turn off SQL here. We have the different type of tier. I have standard, and I have one called low priority. And low priority machines are basically our way of saying, okay, you know what, I'd like to have 5 servers always, but I'd like to have 10 just to have. Well, you can buy 5 additional low priority servers, but if Azure needs that capacity for whatever reason, we're going to take those servers away from you. But to do that, we give you a price discount on those machines. So normally what we'll see is we'll see 5 folks, hey, I have 5 servers running the full price, don't ever touch them, and then I have 5 running low priority, which are called spot instances that Azure can take back if it needs capacity. And because you do that, you get a discounted rate. And choose standard. By the way, basic here are the real minimal servers. There are A-level servers, and we're talking like, a quarter of a gig of RAM, real small single-purpose machines. I'm just going to leave it on standard. Now, the type of machine matters here. So I'm West 16 or D32 here, $2,000. What do you difference here? How many CPUs? How much gig of RAM? What type of hardware are you looking at? Now, folks, you're looking at a number. I know what you're thinking. Wait a second, $2,000 a month? Are you nuts, Matt? Remember, total cost matters here. This is just for the hardware. And if you're just thinking that, then yeah, Azure may be more expensive than what you're used to seeing. But bear in mind, you have to look at the total cost. How much would it look and create if you were to have the total power, heating, cooling, the IT management for that system on-prem? You have to look at the total cost of ownership, and I'll show you, we have a calculator to help you figure that as well. So let me go back to my D2V3, $150 a month. Okay, seems reasonable. But now we have to get a little specialized in licensing. Now, folks, I had a choice when I joined Microsoft 19 years ago. I could go down the technical path or I could go down some of the licensing paths. Our licensings can be complex. And I'm not asking anybody on this, listening to this, to be a licensing expert, but you want to be smart of how you purchase Azure and what you can do to leverage licenses you may already have, but also how you can prepay some of this. So one of the concepts we have inside of Azure is called a reservation. And what this allows us to do is simply say, you know what, I'm going to prepay for this machine, and I'm going to pay for so many instances of this. So after you've done your proof of concept and say, you know what, the D2V3 machine that I have can solve my problem, and I need 10 of them. Well, in Azure, you can say, you know what, I'm going to buy 10 of them as a reserve instance, and I'm going to prepay for them for 3 years. And if you choose to prepay for that VM, we'll charge you. By the way, this can be in installments, so you don't have to pay it in one big lump sum, and that's actually relatively new. But we have the ability to say, hey, you know what, I'm going to use these 10 VMs at a D2V3. Now, the reservation is a subscription property, so we apply this to our subscription, and whenever we spin up a D2V3 machine, Azure automatically applies the discount. In other words, your folks don't have, oh, okay, I got to make a reserve instance. No, you apply it to the subscription level, then that reservation property seeps through the entire subscription for you automatically. And since you've only prepaid for 10, well, what happens when I get to the 11th virtual machine? It'll go back to that $150 a month. Now, bear in mind, same VM, I'm just prepaying because I know I'm going to use it. Now I'm down to $104 a month for that same VM.
Hey, Matt, I've got a question for you. So we talk about reservations, and they sound like they're a great way for us to potentially be saving money. Now, let's say I prepay for a 3-year reservation. That's what you've got selected there. Yep. And I decide I've got this 3 years and I want to prepay for this, but then a year and a half in, I realize that I need to upgrade because I need more powerful virtual machines. Am I locked in for the full 3 years, or is there something I can do there?
You absolutely aren't locked into the full 3 years. When you want to upgrade, you can take what you've purchased and apply it to that upgraded price. So we'll give you the new price. It's going to allow you to move that forward. Now, likewise, let's say, hey, you know what? I don't want to prepay and I want to get out of it. There is a bit of a fee to get out of the agreement, but it's not as bad as you have. And there's a really good document, matter of fact, on the calculator that talks about the penalties if you have to move out. But I'll tell you what, when folks have had to do this, it's a very minimal charge. But we do charge you a little bit. But it's not like, okay, it's a $10 million penalty because no, it's not how it works. And especially when you want to upgrade those machines, you can do so as well. And you basically take what you've purchased and apply that as a credit essentially inside the environment. But reserve instances, really great way to save money. And folks, you're thinking, oh, Matt is droning on about reserve instances. My personal experience, I saw questions on AZ900, AZ103, AZ300, and AZ301. Folks, you will be tested on this because sometimes our exam questions will always have a qualifier at the end of the questions. And you're going to see two qualifiers. Just exam tip for a moment here. Indulge me, folks. I hope you don't mind. Take a break from pricing for a moment. When you have exam questions, we're going to give you some kind of qualifier at the end of a question that's going to help you distinguish the right and wrong answers. And two of the most common qualifiers you'll most likely see on your exams, at least what I've seen on mine, you're going to give you a scenario, it's going to give you a solution, and it's going to say choose the option that is the least administrative effort. In other words, which one is the easiest to do? And it's going to give you 4 different options, and one might be 5 steps, one might be 20 steps. Well, what's easier to do? The 5 steps, all right? Then you're going to have another option that says, of all these solutions, which one is the most cost effective? And you might see reservations in there. You might see hybrid benefit, which I'm getting ready to show you. Understand how you can save money. But more importantly, folks, real life, folks are going to ask you, wait a second, man, you're running this, Garrett. It's 150. Can you save money? Is there any way you can lower the cost? Well, yes, I can. And these are how we can do things. So be smart enough about your licensing. Know how to talk to your purchasing department to understand what your company's always purchased. Now I'm getting ready to show you something that might flip your brain. Remember, $150 a month is what we started at. We're down to 100 by just prepaying, 104. But what if you already had a Windows Server license? What if you already had a license that you bought for on-prem and you covered it with software assurance? You can leverage what is called the hybrid benefit. And really what that means, you take that license that you purchased on-prem and you bring it to bear inside of your Azure environment. That's called the hybrid benefit. I'm just going to make one little switch here. Watch what happens to that price. Same VM, haven't changed region, nothing else, nothing up my sleeve. It's like a magic trick. I click on it, now I'm down to $37 for the same exact virtual machine because I'm smart about my licensing. Folks, I'm not a licensing expert. I didn't want to be a licensing expert at Microsoft, not to knock those folks because they're brilliant. I wanted to be a technologist. But you have to understand how to price things and how you can save money because I guarantee you as you move on your cloud journey, especially when you start talking about virtual machines, 2 things are going to happen. One, how can I save costs in the virtual machine? And eventually they might say, you know what? I want to go into a PaaS service. Most of our PaaS services are going to be less expensive than virtual machines. So there's lots of ways to save money. You got to be smart about licensing as well as what service you use to leverage it. So same system that we're here. Now I want to show you a trick. And I'm going to show you a trick here for real life inside of it. Now, when I scroll all the way down to my calculator here, we have this option that says licensing program. It says Microsoft Online Services Agreement. That's pretty much the pay-as-you-go full retail pricing that we have for this. But if you have an enterprise agreement or another agreement with us as a company, how do you get what that pricing is? One little quick trick. So all I'm going to do is up here in the right-hand corner, just sign in. And I'm going to go ahead and sign in with my Microsoft credentials, and it actually auto signs in for me. And I'm going to scroll all the way back down to my calculator. And now notice at the bottom of this list, it says Microsoft Online Services Agreement. Now it says EA Agreement. So I can actually say EA, and I won't be able to fully show this, but it's there, and select my EA agreement for my customer or whatever I have. And what will happen to this calculator, some kind of magical, it'll put your EA pricing inside of it. And then, because we're Microsoft, we don't have EA agreements, obviously reasons, but where you can get your real pricing. Now, when you're in your portal inside your subscriptions for your company, any price you see inside the portal will be reflective of your enterprise agreement. But you can use the calculator to get that real pricing as well, which is a little trick by simply signing into that calculator to work with it. So let me switch back. Oh, actually, you know why I'm here? We're not going to switch back. I just want to cover the total cost of ownership calculator real quick. Now, the calculator just showed you a pretty easy exercise. Put some stuff in, tell you how much you want, gives you a price. This is not one of those tools. The TCO calculator is basically our pizza as a service. How much does it really cost to make pizza at home? How much does it cost? How much does my oven cost? How much does it cost for my time and labor? How much does it cost for cleanup? All that stuff. We have that ability to do that from an Azure perspective. And we can look at what servers we want to move, what databases we want to move, what storage we want to move, what our networking consumption is. We can put this all into the calculator to help us get a total cost of ownership. And the other thing that we can do, if I go to the next step in the calculator, we can also factor in our different costs. Do we have software assurance? Do we have geo-redundant storage? Do we have virtual machines? What's our electricity cost? What's our storage cost? What's our IT labor cost? We have all these assumptions built into the tool. Now, folks, the only thing I'll ask, if you use the TCO tool, one, be patient. It's going to take some time to build everything in here, but also be open and honest with this tool. The data you put in here, now you're seeing all those other costs associated with running a data center. And at the very end of this tool, when it's done, it's going to spit out a report that's going to show you this is how much it costs to run on-prem those solutions, and this is how much it's going to cost and how much you can save by running them inside of Azure. And so we have that total cost of ownership. And whenever I see this, I'm thinking of pizza and how much it costs to clean the dishes and do everything we eat home. As Garrett says, if you cook, you don't have to clean. How do we factor those costs in when we start talking about data? Because when you look at that big machine where it was, what, $2,000 a month, understand that even on-prem, there's a lot of additional costs. And this tool is designed to help calculate that for you. So let me go ahead and switch back into our slides and finish off with some of the other things we have in the calculator. I talked about the total cost of ownership. What you're seeing here is an example of what the reports would look like that are there, and there's some sample reports you can use. So how do you minimize costs? What are some best practices? Use the calculators, use the pricing tools, monitor your usage, Azure Monitor, use Advisor. Advisor might come up with cost-saving tips. You can set spending limits inside of Azure. Now, the spending limits you set here are soft limits. In other words, when somebody goes over the spend limit, it's going to give them warnings. It doesn't turn them off. Now, with mine, with my Visual Studio, it's a $150 limit, which means when I hit $150 spend in the month, it does deallocate everything until the next month, until my credit. But that's unique to that subscription. Use reservations and hybrid benefit. Choose low-cost regions. Keep everything up to date with your latest offerings. As we change Azure and we add features and functions, sometimes they will be cheaper than what you're currently doing. Use cost owners. Use tags to help apply those things. There's lots of ways we can help minimize costs inside the Azure environment. We also have an Azure Cost Management utility where we can come in and get patterns and seasonality. We can see how much virtual machines are costing us versus Azure functions versus storage. We have all that ability inside of cost management. We can even get recommendations from that. We have the ability to take Azure to the next level. So pricing, very important. What about support? We have lots of support options inside of Azure of how you can work with it. Now, it all starts with our support plan options. And what you see here is a subset of the support plan options that we can have. Basically, when you look at the support plans, you have the ability to pay for support. We have basic support, which is free. You have developer support, which you get some limited capabilities, but we also have standard, professional, direct, and premier. Depending on what you want to use, they all have a price point. But the main things that customers choose support for is our SLAs to get back to you, our guarantee, but also what services you get. A lot of our enterprise customers, and maybe a lot of you watching this session, have a premier. Why? Because you get a technical account manager. You basically get a quarterback for your resources, for your support issues. So if something goes wrong, you have a full-time Microsoft employee that's going to help and run with it to loop in all the right resources to solve whatever problems that you have. Now, I want to show you real quick, just a quick website that has all of this information. And this is in the fun path, the online learning path, the aka.ms/az fun path. But when you take the exam, you're going to want to know these different agreements. I know in real life, folks, you have a support plan that you use for your organization. For the exam, you're going to be tested across the broad set of this. And so there's actually a website you can go to that has all of our support plans for you to use and leverage. And if you take a look at the website, you can see a lot of nuances between what the technical support is, what the response rates are, what the different severity is. We have all this up on the websites. If you go to azure.microsoft.com/support plans, you will find that, and you have the different costs that are here. Now notice for the Premier, it says contact us. You have to have an enterprise agreement to have a Premier contract. They're fairly expensive, but once again, if your business is relying on Azure, it's great to have Microsoft in your corner if something does go wrong inside the environment. So understand these plans. Folks, just from the exam standpoint, you will be asked about these. Just review this table, understand what's available to you. In real life, if you have mission critical applications inside of Azure, guess what? You're going to use Premier to work with that environment. So let me go back into the slides real quick. We also have alternative support channels. We have our MSDN Azure forums, we have Stack Overflow, we have Server Fault, we have a general feedback channel. We also have a Twitter channel. Now, I heard a chuckle. I heard a chuckle all the way across. Everybody listen to me. Twitter really mad? Are you serious? At Azure Support. Now, folks, I cannot stress to you, you have full-time Microsoft employees on this channel. You have community members, which are called Microsoft Valuable Professionals on this channel. What I'm trying to tell you is just don't make fun of it because it's Twitter. You have 400 level experts on these channels. And even in some cases, from the Microsoft perspective, our employees have to be on the channel to help support our customers in this way. So you have very, very smart people here asking questions. So don't look at this going, hey, it's Twitter, it's just gonna be community advice. No, chances are you're gonna have a full-time Microsoft employee that's deep in whatever you're asking, answering your question at a 400 level depth for free because it's inside of Twitter. Now, I don't know if I'd run a business on it, but folks, the folks there are the same folks you might get through premieres, through other agreements that are available to you. There's not always there for you. There's no SLA and how quick they'll respond to the Twitter, but it's definitely something we want to look at inside of Azure. We also have a knowledge center where you can query our knowledge center looking for different help, looking for virtual machines. A lot of documentation's up there. A lot of known issues might be up there, kind of like the old TechNet event center, where if you had an event ID, you could put it in there and get an idea of what it's going to be. We have a knowledge center where you can go and get help. It's a searchable database. But we also have the ability to open a support request. Now let's have some fun with this. Now, if Azure's behaving properly, let me show you how we open a support request, but more importantly, let me show you some of the things that Azure does on our behalf. So I'm gonna hop back into my portal here, and I'm gonna go all the way down to the bottom and choose help and support. Now, I'm gonna start the story here, how I open a support request, but I wanna show you a little trick. And I'm gonna come back to the screen. If I go into my virtual machines, and I go into one of my virtual machines, like FunVM2, and I scroll all the way down, I also have a new support request. The great thing about this, when I go here, it automatically fills in the context where I'm at. So it says, hey, you're running a virtual machine, running Windows, it's called FunVM2. It's already started to fill in the help and request tool for me. So I don't have to do it. By the way, pretty much everywhere inside of Azure, that new support request is available to you, so you can save some time if you know you're having problems with a specific resource. Now I want to take you kind of the long way so I can show you what this looks like from the get-go. So I'm going to go and scroll back down and go back into help and support. And they give us our community. There's our Twitter channel. We can access it right from the portal. I'm going to simply say new support request. It's going to say, what's your issue? Is it technical, billing, what's going on? We'll say this is technical. It's going to ask what subscription I'm going to have. It's also going to select a service. I'm having a problem with a virtual machine running Windows. It's going to say what resource. I'm having trouble with the RBAC test VM. In other words, won't connect. What's my problem type? Cannot connect to my VM. What's my sub-problem type? My configuration is impacted. We'll say, put that one in there. And notice what comes up. Hey, it's stopped and it's deallocating that machine. It's actually looking at this going, hey, something's on with this machine. The virtual machine is stopped and deallocated. In other words, turn it on. So when we go through the support and request, Azure has some technology behind it that's going to say, you know what? There's something wrong. And in this case, I knew the machine was turned off, and this tool told me. So it ran across my subscription. It even gives me some recommended best steps to how to actually move forward inside of there. So I have the ability to troubleshoot this. I chose this machine purposely because it is turned off. It's going to get those high-level basics, but this may not be enough for you. If I go next to details, this is where it comes in. You see my subscription. Hey, look, hey, why don't you call somebody and pay for a plan? If you have a Premier agreement and you have a technical account manager, what'll happen from here is it'll actually open up the rest of the support request details. You'll fill in some information, and the technical account manager will get that request and then run for it. Most likely you're gonna get a phone call, depending on the severity, usually within a few minutes, I think guaranteed within an hour, you'll hear from somebody at Microsoft and you'll start quarterbacking and solving whatever that problem is. So knowing how to open a support and request is very important to our Azure environment. It's very important for you as a customer to help. How do you get help? If something breaks, how do you work inside of it? How do you actually deal with those issues? And if you don't have a Premier agreement, you have ways to get plans, pay for support instance, so you can help get resolution to whatever problem. And I hope you don't have any problems, but if you do, there's a lot of help here, a lot of free help. And if you have to go pay for somebody, it's fairly reasonable when we take a look at the support issues that you might have to pay for. So let me go ahead and switch back in. And let's finish up some of the other topics inside of this module that are here, and let's talk about service level agreements. Every Azure service inside of your subscriptions have service level agreements. Now, with the exception of virtual machines where you have to configure them in certain ways or use availability sets or availability zones, you have service level agreements. And all this basically means is, you know what? We define how much guaranteed uptime you have for a product, and if we as a company don't meet that requirement, we're going to pay you back a credit. They're financially backed service level agreements, but it talks about how we define how things are going to be performant for you. So when you have outages, how do we give you credits to say that? And trust me, here at Microsoft, we hate outages just as much as you do, and we work really hard to resolve them. And how do we work with that, or how do we help meet those requirements? So first off, understand what we mean by service level agreements. It's measured in uptime, and every Microsoft product has anywhere between 3 nines to 4 nines on the average of uptime. What does that mean? Well, if you're 3 nines, that means downtime per month is 43 minutes. Downtime for an entire year at worst would be 8 hours. If we don't adhere to that, you get credits based on that service. We guarantee that monthly request, and you might have some of your monthly fees waived, you might be get accredited, it all depends on what that outage looks like. Now, some resources inside of Azure, guess what? We have different service level agreements on how you configure it. So Cosmos database, for example, if you configure it in a certain read-only perspective, you can get up to 5 nines. And that's for our services. Now, we talked about storage. Storage has its own SLA, and just kind of a fun note, locally redundant storage, LRS, 9 nines by default, and GRS, the last time I checked, 16 nines of availability. So we have different availability levels in our different areas of Azure. Now the challenge becomes is when you start working with multiple Azure services that have different SLAs. So as the writing of this slide, we had an SLA for the app services, which is 3.5 nines, and Azure SQL Database had 4 nines. How do you calculate what the actual service level agreement is? You calculate it by multiplying the two percentages together, and you come up with what's called a composite SLA. It is always going to be lower than the lowest composite, and the reason being is we have to factor in multiple points of failure here. We could have a failure at the web app, which impacts the SLA for SQL, and vice versa. So we have to be able to calculate it. And that would be what we'd have to adhere to as Microsoft for the SLA for that solution. Now, why do I show you this? Because you have to understand how to calculate it. You have to understand how it works with it. If you get a question like this on any of your exams, and just a general broad statement, if you get a question on any of your exams that requires you to do math, you do not have to do it in your brain. You'll be provided the Microsoft calculator to solve that problem. If you get this question on your exam, you simply multiply the two percentages together, and it'll give you the resulting percentage. And they just show you on the slide here, take it down to the decimal points, and it'll tell you what that actual percentage is. But understand we have those composite SLAs to help factor in the multiple points of failure. Application SLAs, when you start building those requirements, designed for resilience availability, you determine the SLA based on what those application needs are going to be. Look at the metrics behind that application. How long does it take to recover, or how long do we tolerate failures? If you have recovery inside of that, what's our RPO, recovery point objective? What's our RTO, recovery time objective? How long do we bring these things back? So when you start looking at your applications, you have to look at a lot of factors. Like, for example, we had the app services and the SQL database. Well, is there a way we can choose another service that has an higher SLA than app services to do the same thing? These are questions you ask when you start architecting solutions inside of Azure, and then you build to those availability requirements. And when you look at things like virtual machines, by simply putting things in availability zone, you get 4 nines guaranteed SLA for those virtual machines that are in that availability zone. So we have all kinds of ways to do that. One of the last topics we're going to get into is service lifecycle management. When we take a look at all our products inside of our service lifecycle, we have 3 big stages. And along those stages, we have different costs and different SLA and support will come to bear. We have private preview. Private preview, very simply much, product is being reviewed by the product group. Generally, it's an invite only. We're looking for a very specific type of customer doing a very specific type of scenario with whatever feature. Now, if that feature survives through private preview, it goes to public preview, where customers then can open and test it. Remember, and we talked about this, I believe, in Module 2, when you're in preview products, do not put production stuff, do not put production stuff, do not put production stuff in preview. Friends don't let friends put stuff in production in preview.
Hey, Matt?
Yes?
Should I put my production workload in preview?
No.
Oh, okay.
All right. You can, by the way, and this is the challenge. We can put production stuff in here. Don't do it. Why? Because there's no guarantee the product will make it out of preview. Now, with that said, we have a lot of faith in our product group. When things hit public preview, they're normally going to make general availability. How long that takes depends on the product. Generally, it's within 6 months to a year. When it hits public preview, it's going to become generally availability. That's when you can put things in production. You use general availability. That's when it gets a cost, that's when it gets an official SLA, and it gets official support, but not until it becomes GA along that life cycle. All right? So You also have the ability, we change our portal often, and this is a challenge for Garrett and his team and for myself, is that we do live demonstrations. And so I never know what the portal is going to look like, but I can look at a preview of the portal. Everybody, customers, you have the ability, if you go to preview.portal.azure.com, guess what? You can get a preview portal experience. Now, it's a little flaky every now and again. You might have some refreshes where you have to work with it, but we're trying to navigate and give you the best experience. You have an ability to get feedback in a forum. You also have to report a bug. Say, hey, look, we're having an issue with this particular portal. We can give feedback back to the product group to design a better portal experience for you. And I will tell you, folks, I have seen so many wonderful changes from the initial Azure portal to where we're at today. They really want to make the experience easy and intuitive, and you can kind of see what we're working on by going to Preview Portal. You have the ability to work with it, and it'll be on your production environment. Now, quite frankly, if you're really doing everything day to day and you need to be there, don't use the Preview Portal. It's something if you want to test and kind of explore, but if you're trying to really do stuff inside of Azure, go to the real portal, portal.azure.com, because it's going to be that full functionality. You don't have to worry about any potential bugs that are going to be there. We also publish our, not only can you look at the preview of our portal, you can look at the roadmap of our products. You have the ability to get into our roadmap and see what we're working on. Now, when you go into our roadmap, it'll show you what features we have currently in preview, what are in private preview, what features we've deprecated. In other words, sometimes when a new feature comes out in Azure, we're going to pull its old feature out. We're going to let you know that. We have the ability to look at the roadmap. You can do a quick search on the internet and do a search for the roadmap. You can look at all the data that's there. Now, the one thing I will prepare you for when you go to the roadmap, don't expect dates. We very rarely will tell you what the dates are for the resources. We're going to tell you, hey, here's the new feature we're working on. Here's why we're working on it. Here's if it's a public preview or private preview, here's where you can possibly sign up and go inside of it. So you can monitor those resources and work with it. So as you can see, even though we focused on the updates and you can see what's there, there's a lot to do with pricing and support. And folks, in real life, you may not do a lot of this, but know the calculator. If you do work in the community, know how to get the free service inside of Azure. Know what's there and know how to purchase. Be a little smart about licensing when you start having those costs inside of Azure. But for your exam, folks, there's a lot of memorization here. Know the support plans. Know the different way we can acquire Azure. Know the different tools we can use to control Azure costs, from reservations to hybrid benefit as an example. So when you get ready to take your exams, Module 4 is pretty important, and really, it is part of fundamental. How do we price and support our stuff? We have to know this at a real high level, but when you get in your exams, just a little bit of memorization here goes a long, long way. And that brings us to the end of Module 4.
All right. Thank you all for joining us today to learn about Azure fundamentals and for sticking with us throughout the entire day. We wish you good luck on your exams and happy studying.